Hello? Hello?
Yep, it's working.
Okay, okay,
You
great.
want me to turn it off or leave it on?
I mean, it's like 2 minutes technically,
Okay.
so we can leave it on.
And then there's a hand mic here. Do you want me to introduce you, or I guess you can introduce yourself?
I can, yeah, I just probably need hand mic for Q&A,
Yeah,
if any will happen. Thank you so much. No, really, really appreciate it. Really appreciate it. No, I don't. No, I don't. No, I don't. I have my finger.
Okay.
I'm good. Thank you. I'm
I'll
fine.
just move it
Yeah,
here
yeah. Okay, now we can leave it here, yeah. I mean, actually, I can try this one, I guess. Hold on, let me see, because I tested mine. I did not test this one. Now, this one does not like me. This one likes me. Okay. Okay.
Sure this is off.
Yeah, we do not need this one in process.
Perfect.
All right, awesomeness. All right. All right. So can everybody hear me? I assume yes, right? Thank you. So since there is no moderator, today I am just starting because I always start on time. So if anybody been to my Chicago Park PostgreSQL user group, they know I start on time even when the speaker does not show up. I make a quick substitute because it's a way to keep people organized because, other people need to be done and get on the train or whatever. So anyway, good morning, everybody. Thank you so much for coming for the first talk of the day, and especially coming into this room, which is a freezer. So I know that's some sacrifice choosing between this room and the other room, so I really appreciate you choosing my talk. So today we will be talking about securing your Postgres data. And I'm delighted to speak at SCaLE for the first time in my life, so it's all new for me. That's a huge conference, and there are people whom I usually do not meet at the conferences, so thank you everybody who is at my talk for the first time. So I'm Hetty. Do not bother about last name. There is only one Hetty in Postgres. Google Hetty Postgres. You will know everything about me, more than probably I want to know, so there will be plenty of information. So I'm Hetty on LinkedIn, Hetty on GitHub, and Hetty everywhere. So I've been doing lots of stuff with databases in general and Postgres specifically. And at the moment, I'm a database architect at the DRW Holdings in Chicago. They said they're going to change my title because nobody knows what architects does, and rumors are that data architects do not do anything, which is not the case in my case. But anyway, at the moment, I am a database architect. So more important title, which I hold longer than any of my job titles, I am the local organizer of the Chicago PostgreSQL user group. So I'm leading this group since December 2016, and I did not check recently. At some point, it was second largest user group in the Western Hemisphere. I think there are a larger group now, but I am happy that I led this group through pandemic. We actually continued to, we switched on to Zoom in April 2020, so I missed just one meetup, and since then we are meeting both virtually and in person. And during pandemic, I promised that I will always live stream my meetups when they will return to be in person, and I still do. So if you are interested, we are meeting once a month. So go to Meetup and find Chicago PostgreSQL user group, and I will always have a link to our Zoom version of Meetup. So even if you are not in Chicago, you can join me virtually. Another very important thing I'm doing in my life is I'm the part of operations committee of PG Day Chicago. And that is, by the way, only the second PG Day in the United States. I was shocked when I learned it because there are so many PG Days in Europe, and so there are only 2 legit PG Days in the United States, PG Conf New York and PG Day Chicago. It is happening now for the second time, and so far it's a one-day conference, so please support it because if I will meet the goal for this year, then hopefully next year I will be given 2 days conference. So I still need sponsors. I still need participants. Registration is open. It's still like plenty of time. If you can do even like small sponsorship, please sign up. If you want to attend, please sign up. The program is awesome. So check our website. It's like a great program, free tracks. And I returned it back to Chicago Loop, so at least you are not looking at, oh my gosh, I do not want to look at the windows. You will look at all the like best of Chicago from the windows if you are not looking at what people are presenting. So please come and join me, okay? Why this talk? So for those who know me, I'm all about performance. I'm like performance, like whatever, they're saying performance queen, whatever, like this Russian lady who comes and like, tells people like how things should work. So anyway, normally I'm doing talks about performance and about my projects. I have several open source projects which I love. So that is my first security talk. So why I'm talking all of a sudden about security, I never did before. So before I will go with official slide, here is unofficial story. At some point during my employment with DRW Holdings, I had to automate security settings, which all this talk will be about. And when I started to convert databases from disaster to proper security, I found so many issues with how Postgres is doing security. I was like shocked. I wrote a blog post, and it was like, it was not a WordPress discussion, it was like Facebook-style discussion. People became very angry, people were writing long responses to me, so that was a disaster, and then I'm like, okay, I need to let the world know. And I started to submit this talk, and I got rejected. So I talked to my friend Leticia Avro, like, I got rejected for the 5th time, what's wrong? Like how I can let the world know what I think, because otherwise nobody will listen to me. And she said, you know what, first of all, you do not call the talk what is wrong with Postgres, because everybody will get like upset and like, okay, it is something which is wrong with Postgres, so how you want me to do this? And she said, okay, you know what, like use ChatGPT, that's what I do with all my talk descriptions, and you will get accepted. I'm like, nah, ChatGPT is not me. Everybody will see it's not me. Like, try. So I tried. So ChatGPT replied something like, oh my gosh, that's not me. No, I'm not doing it. And I thought for a couple of days, okay, I will take ChatGPT version, I will make it look like me, and this one got accepted. So that is ChatGPT plus Hetty, okay? So finally, I have a chance to talk about what I wanted to talk for like, for a whole year, okay? So now official version, why I'm doing this talk. We live in the time of age of data breaches, and I do not even need to enumerate any recent ones because everybody knows. Everybody heard, many of you have been like a victim of data breach, so we know, right? So securing data is high priority. Like anywhere, here we have the whole track about security. By the way, they did not accept my talk. Postgres accepted my talk. The security track on SCaLE said it's not important. You know why they said it's not important? Because they believe that only thing you need to do, you need to secure your network, you need to secure it from intruders from outside. From inside, the moment you get into your super secured network, you can do everything because nobody protects data on the database level, okay? And by the way, Postgres has everything. So you look at any other database system, Postgres has the most sophisticated, most flexible system to provide the permissions in very fine granularity, exactly what you need. Postgres has it all. Still, you know what happens in real life. Not in theory, not when the contributors tell us, oh, we did row-level security. So you know what happens in real life, right? Who knows what happens in real life? It's interactive. Who knows what happens in real life? Hmm? Now, that's what happens in real life. like production applications, you know what? My internal customers come to me, we need to install this application, we just paid tons of money. I'm like, I cannot install it because it's like this. But yeah, they require super user, they require public schema. Okay, so, and you know why it happens. There is a reason why it happens. There is a reason, no matter how hard we try, this happens. And I will tell you why. So, just to start, what will be covered? So we will go through most important security challenges, which is like what I said yesterday. I want this to be part of Postgres, not hating things in Postgres. We will, I will explain the necessity of standardizing approach, and I will show the security models which we adopted in DRW Holdings, and how we use automation, and what is next, what I'm trying to achieve, except for making half of it part of Postgres. Okay? So, the reason why it's still a public schema user Postgres. There are several challenges. First challenge is you do not need to have any security to start working with Postgres. So Postgres has very low entrance barrier, right? We know, because nobody needs to learn Postgres. You get it, you install it, open source, and then maybe you start reading documentation. But for the moment, you installed it locally, you are automatically connected as Postgres, you are automatically like within public schema, go, okay. If you decide to look at documentation, that's the table of contents of documentation. Anywhere, anything about roles, users, permissions. Tell me, do you know where is it? I know actually where is it. It's like nothing, right? Remember, okay, most of us have been with Oracle at some point of our career. Let's be honest, let's admit it. So remember when you start with Oracle, you do this Scott Tiger thingy, you cannot be like nobody, right? You can be nobody, or you can be everybody. You can be super user in Postgres. So I will tell you where in documentation, like the first word about privileges appear. In the middle, right? So you are done through what is Postgres, how to use it, quick start, everything, all of a sudden. Oh, now we can talk about users. And if you click on this, do you see where privileges are? Not in the beginning, right here. So you're kind of like, you already stopped reading documentation because you did quick start, you know how to do everything. There's it. And the most alarming thing. So you know how happy I was when Magnus just announced that the special status of public schema is removed in Postgres 15? Still, in 15, in 16, all examples in documentation are from public schema. Like look through it. Like nobody ever mentioned you can create something other than a public schema. Goes by default. So then we have hard time telling users that that is wrong. You know, I heard like, you know, users like, okay, you just told us the schemas exist. We did not know before. Like seriously, I'm not even kidding. So that was challenge number one. So as a result, what happens? So applications are developed using Postgres user because it's easier. When they go to production, they don't have time because like it's deadline, it's deployment, and you know we will lose money if we won't deploy it today. You know, no matter how long you develop, but we cannot do anything. Okay. Then the other thing, like for some reason, whoever designs, like contributes to Postgres, they forget that in real life there are no users typing, there are applications using connection pool. So forget about role security, whatever. Everybody are connected using the same user. And how often this user is Postgres? More than you want to know. So as the same database user. So challenge number two, the wonders of inheritance. We did it long time ago. Actually, you know, yesterday was the conversation who started when. I was still there at 7.3. I remember when we moved to 8. So the difference between groups and users was eliminated in 7.3 because now we have everything is a role. So now user is a role with login, and we can grant anything to anything, anybody to anybody. So if we create role 1, then that will be role, no login role. We create role 2 with login, so that is a user. That's OK. We create user 1 is the same as a role with password, so that's same role. So now all of these grants will work. Postgres does not see anything wrong with this. So you grant role 1 to a user. You grant one user to other user. By the way, forget you secured this user with password. You granted this user. So another user does not need to know this password. You go. And at the end, values of inheritance. You create another role, and you grant this role to role 1. And when you grant, you do not know who else owns this role 1, who else has it. So everybody will grant, will receive this grant. Everybody who have role 1 will have also role 3. And when you will grant permissions to role 3, everything will go up, and you do not even know what will happen. Okay? So you know, it creates total security hazard like in 2 steps. 2 steps is enough to create total security hazard in your database. The one horrible thing I had in real life, not like recently, but accidentally everybody, say like public, was granted a super user. Like by the by ways of multiple inheritance. So another thing which for some reason, okay, people who work with Postgres professionally know, but for some reason everybody forget. People think that user is created for database because you are connected to a database and you create user. And you do not create it for the database because users are created on instance level. And I cannot tell you how many times people say, we want this in separate database. I like, why? For security reasons. There is no security. Any user you create have automatically connect permission to the new database. And yes, you can explicitly remove it. But when you create another database, it will, again, you need to know what to remove. So you need to know from which users you want to remove access. So you create a user, by default, they have access. So they have connect. And if you have public, anybody from any database, anybody can create anything in public schema of any of other databases. And also, sometimes you say, we need super user because of whatever. So if you made this mistake, this super user can do anything in all databases on this instance. So hello, no security here. Okay. Now, we actually know how to do things the right way. And until I started with DRW Holdings, I thought I know how to do things the right way. Because when people know that we need to use schemas as units of security, we need to have an owner of the schema, we need to have roles, we are not granting privileges to users directly, we create a role which holds the privileges. And so what I'm going to demonstrate now, it is like written in many, many blog posts, not in Postgres documentation because we are flexible, but any blog post from anybody who tries to do it the right way, you will find something like this. Using schema and granting roles to users. So you will have something like this. You create a schema owned by owner role. You grant this role to a user. You create read-write role, and you create read-only role, and you operate like this. So that's not new. That's not Hattie invented. It had been around for a very long time. Okay. Now, and what you do, you grant select on all tables to orders read-only. You grant select insert update delete to tables on all tables to orders read-write. So What won't work? What won't work? It's interactive. Truncate, yes, no, but not only. What else? Truncate, yes, thank you. What else? What else will not work? Hey, any application developers here? What? Thank you, yes, thank you. The default privilege challenge. And by the way, one thing everybody forgets here, grant usage. Because I still need to understand why it has to be grant usage, but when you grant read, write, whatever, things do not work. And then, you need to define default privileges, because the previous grant, this one which we had here, okay, so here we only granted permissions to tables which were already in the schema. So if we just created the schema, it's nothing. So we need to do default privileges, okay? So default privileges. Alter default privilege in schema orders, grant select on tables to read user, grant everything else to read write. This should be OK, because now what we're saying, any table which we create, and views, by the way, views are also tables in this situation, read user will have select, write user will have everything. So, and remember, we created role, we created user, so all good, right? So there is a user who can create tables. Okay. We create a table. By default, permission not applied. It's interactive. By default, permission not applied. You create a table, they are not applied. Why? Okay, because, yes? No. All tables is all good. No, it's not. It's I created a table. So remember, I had the owner user, owner role. I did alter. So I'm admin who can create. I create table, default privileges are not applied. You know why? I mean. What matters is that you need to grant default privileges, not to whatever, but for specific user. Because if you issue these alter default privileges, you know to whom it will alter default privileges? To the user who was doing this. So if you have a database owner when you did this alter schema, it will grant to Postgres, to whoever, not to whom you intended. Okay. So now, yes, that's what you need to do. You need to alter default privileges for the schema owner because you want them to be kind of like encapsulated on this database owner. This actually leads to other situation, because if you are now admin user, you need to explicitly switch to this role, because otherwise you can create table, but default privileges won't be applied as well. So there are like two things which can go wrong here. All right. Wonders of ownership. That's the thing which blows mind for everybody who comes from Oracle. So we own schema, right? Create schema orders on orders on. So this is created by default. So you do not do this, grant all on schema orders to orders owner. It is implicitly granted when you create the schema. So this role, orders owner, can create all objects, has all select, insert, update, delete, truncate, whatever. So now, and I face it all the time when like people, oh my gosh, we actually need to reduce security. If you do alter schema orders owner to new orders owner, who knows what will happen with permissions? Anybody knows? Anybody tried it? Who knows what happens with permissions? Okay, the answer is nothing happens with permissions, like literally nothing. So the schema will change the owner, but the old owner will still have all set of privileges. So in order to switch the owner, what you need to do, you need to revoke everything from the previous owner. You need to read catalog, go through all the objects. You need to switch an owner. And yes, there is reassign command. Reassign only does ownership. It does nothing with privileges. So you need to explicitly revoke all the default privileges, grant new default privilege. So it's a huge project. So like one of my asks is why if we want to be flexible, why at least we won't allow some flag, okay, like switch ownerships like Cascade or something like this, because that is a huge project if you have lots of objects in the schema. So, and lots of other things. And I can talk like the whole hour about all other weird things, but like just couple of things, okay? For example, okay, so you granted select on the table to a role. Then you grant insert, update, delete on the same table to another role. You create user. You grant this role 2 to user 1. So now user 1 can update, insert, update, delete. So then says, actually, we do not want this user to do delete. What will happen if you revoke delete? Who knows what happens? Yes, correct. It does not do anything. It does not do anything because we never granted delete. We granted a role which has delete. Delete as a separate privilege was never granted. But do you think Postgres tells you you are doing something wrong? It does not. Not only it will not work, there will be no error. So you execute revoke. It will say, yes, revoked, and then this user can delete. So that's like one thing I reported long time ago, and that's like what I was referring to. Yeah, that's probably wrong, but we have like 120 other things which we need to address. So if you revoke permission, which you did not grant it, or nobody granted, it would not tell that, no, this is wrong. It revoked, all good. And also, if you grant the same permission multiple times, the only time when it will report, or you already have it, is when you grant the existing role one more time. Okay. Then, in addition, other challenges. You cannot drop the user which has any privileges. So it's a mistake, right? It will error, and like you cannot drop this user. You cannot drop user cascade, because you know with all other things you can drop user cascade, you cannot drop user cascade. So it will tell, no, you need to revoke all privileges explicitly. And remember, they can be in different database. No? And most interesting, there is no easy way to tell which permissions this user has. Like, trust me, because I wrote a function which lists all the privileges for the user. This function is like about 100 lines long, and other people who try to do the same, they kind of end up in about 100 lines of code, just to list all privileges for one user. So, okay. Now, it's all okay when you have several databases, okay? So I have 280 approximately. We are not sure how many we have in organization, but something along that lines. And we have a team of, we have a team of very little number of people, because also Postgres is not our only and not even our most often used database in our organization. And we have total DBA team of 14 people, like for all databases. And again, Postgres is just one and not the biggest. So, what we're going to do. First of all, I work in trading. And in trading, people are super secretive. They want them to be isolated. As we already know, databases, separate databases would not help. Separate instance for each project. I had an internal customer who requested a new instance literally for each new pair of tables because they wanted to be separated. So that also kind of expensive, even for trading. So what are other approaches? So that's kind of like what led me to developing this security framework. Again, why I'm talking about these 280 instances. So there is no room for error. Previously, I could say, hey, you know what? You did not switch to correct role. I'm sorry, you'll need to start anew. I cannot tell it to owners of 280 databases. So I need to have some automation which does not allow anything like right and left. Okay? So here is my security model. So it's kind of like not really open source, so I only will show the pieces of code. So I will try to show ideas rather than how it is done. So if you want like more clarification, I will try. Please like stop me, but just telling you it's not exactly pieces of code, it's more like what we did. Okay. So what are basic principles? So first of all, principle of least privileges, that's like principle of any security settings. So user is given minimal level of access needed to perform their actions. So if you do not need something, you do not have this. Only exactly what you need, not more. Second is durability, which means it's like we tried. Again, I promise to take a person who will break it out to fancy restaurant if they will break. So far nobody broke it, because I challenged my DBA team to try to break it without being a super user. So it's pretty much unbreakable. And flexibility, because different customers have different needs in like securing their data. So I was struggling with different package versions. So the version which I have now is flexible. So just using 2 flags there, I can satisfy pretty much everybody's security and permission needs. Now, what are the key features, how it works? So first of all, again, that's my big ask of Postgres. Postgres, I do not want to create event triggers for this. I actually want it to be kind of, you should be able to set this up in Postgres. But now I have an event trigger which switches permissions when object is created. So pretty much what it does, it forces permissions to be correct in the correct schema. Then I have security level matrix, and I will go through this matrix like in a second. Security is on the database level. So not on instance level, on each database, you set security package, and you can set your security level on each database. And how it is all executed, I have a set of security definer functions, which do everything instead of user issuing commands. So I'm not giving anybody the super user, but users can create schemas, grant permissions, create users, only through security definer schemas and security definer functions, and they can only execute things which we allow them to execute.
Do you let them change their own passwords?
Yes, I do. Yes. So there is a security package which set a function. It is by default installed in each Postgres database, and it is dormant until we explicitly initiate it by setting it up with security metrics. You cannot change settings after they're set once for the database, otherwise, it's like, it will be bad. So there is like one function which a Postgres user executes, grants, creates schema users, and it uses permission settings, which I will show on the next slide. The permission settings are recorded for this particular database, and if you redeploy this package, because the biggest challenge I have, I made changes in the existing function, so I do not want to break it and start over. So if I already had security set up, the installation script picks it up and re-implements it. So I do not need to do it. I can redeploy multiple times. So that is the matrix, and I will highlight all of them. So we have schema owner and account owner thingy. So how it all happened. So first was this schema, which I described previously. So database owner owns all the schemas, and grants read-only or read-write. It covers most of the situation. Then one of my internal customers came and said, no, we actually want to be isolated per schema because there are different teams who are creating objects, and we want them to know nothing about others. And if you can do this for us without us being creating yet another instance, it would be great. So there comes model number 2, schema owner true. Where each schema is owned by separate user. Schemas are still created by admin, but each schema is owned by its own user and gives its own privileges to their application user. Then there's another customer. You know what, actually, I want something different. I want 2 power users, which each can create their own schemas, but not knowing anything about each other. So then it was modeled with account owner, and account owner has the schema ownership. And then there was one more user, and they said, we are selling services, so we want to create accounts. And these accounts can create their own schemas. And again, they can do everything within their own schemas, but know nothing about each other. So I said, okay. And that was kind of like finalization of this matrix. So at the moment, again, if somebody knows anything else, please tell me. But so far, this matrix covers everything, what we can do. So let's, so let's look at what is done for each of them. So in first case, false, false, it is each schema is created by database owner, and this schema is created with 2 users, read only and read write, and the roles are granted, the privileges are granted to these roles. So that's like classic. Everybody who does security on schema level does this. So next one, again, database admin creates, users admin, creates schemas. For each schema, it creates the schema owner role, and same story creates a read-only role and read-write role. And again, here the owner is the schema owner. So in this situation, we create account, and account has some privileges, privileges to create schemas, again, via security-defined functions, and it also creates read-only and read-write users. And this last one, each schema is created by account owner, but for each schema, they create separate schema owner, and all the default permissions are cascading in this manner. And in this case, the account owner can do everything with their schemas, but the schema owners can do everything within their schemas. Oof. Okay. So what are the functions doing? So honestly, the biggest challenge for people to adopt it when they realize what advantages it gives them, they love it. But the problem is that they need to call functions. And again, I would love it not to be functions. I would love it to be like you can switch to some flag or option on create schema, create table, whatever, and be happy. But anyway, create schema roles as first function. So whoever has a permission to create it, they can, this function will create schema. It will create application user. It can create user and password at the same time, doesn't have to. It can create schema owner if the security level is with schema owner, and can create the password. And it might designate it to specific account, again, if account is applicable. It is defaulted to the current user, and you cannot really change it. I will tell in a second why. Again, the call is the same. Everything inside is driven by the existing security matrix. So which roles are created, which not. drop schema roles. So remember, you cannot drop anything without dropping all the privileges. And the worst thing is, if you drop schema, which you can, then you have all these remaining users, and you cannot recreate the schema because you cannot recreate these users. So instead of drop schema, you call drop schema users, and you pass schema name as a parameter. So what it does, it revokes all the associated roles from the users, and it drops these roles, and it drops the schema. So all of these things, just clean drop. Then assignment functions. So you can assign the schema owner user. You can pass schema name, the username, and the password. So here is what it does. If it's a new user, it creates the user with a password. If it's an existing user, it will, if you do not pass the password, you just assign the role. If it is existing user and you pass the password, it will change the password. So that's how it works, pretty much. So same for the application user. So same story, but for the application. And obviously, there is one function underneath of it, but our users do not need to know there's one function with the rules at all. And for read-only user, again, same story. It's underneath is the same function. And also, there are all these revoke functions. So same, you can grant role, and you can revoke role. And again, everything is done kind of in a clean way. So we do not drop users because, remember, we do not know what else these users do. Because, there are some creative people who actually reuse the users. So we're like doing it safely. All right. And additional security defined functions, again, those are the functions which are like very, very, very needed. So first of all, select all privileges. So if anybody in the previous lives ever saw my diff project, I create these differences between different instances. So this function is copy from the diff, and it does list all privileges kind of like disassembled to atomic level. So no matter how the privileges are granted by roles or directly, so this will list everything, everything, everything. So it's good self-check. And the other two are scene blocking processes and PGStat activities. So why we need this? Because by default, again, we're not giving people super user privileges. Otherwise, you can only see your own SQL. And if you run it, you will see if it's not you, there will be no SQL and displayed, because it's security, and admin wants to know who did this. So this function works as a security definer, as like Postgres, and it can display all the code of the queries. So that's very important in our situation, because in the queries, you can see all the data, and you know what, again, working in trading, I see all the data which I severely want to unsee, but I have to see. So, so nobody except of the admin is entitled to see things. All right, so code details. Again, it's no magic, so how I am forcing privileges. Again, that is the part of the event trigger. So when you create any object, it's not one create, it's whole bunch of creates. Because when you create table, it's create table, create constraint, create index if you have some primary key or unique key, and whole bunch of things. So event trigger on create goes through all the objects which are created, changes ownerships and permissions when it makes sense, because there are lots of little things like you do not change ownership on index, but index needs to be created after ownership is already changed. So everything is done inside this trigger. So no matter who you are, no matter how many times you forgot to switch to correct role, if you own this role, if you have a right to create objects in the schema, the permissions will be, the ownerships and permissions will be assigned correctly using the event trigger. Now, how I know that you have a right to do this? That's how I know. That's again, part of the code which that it's standard recursion, which identifies which role do you have, plus if you were smart and explicitly switch to the right role, which you do not have, but like you know you should. This basically returns true if you are allowed to do things in this schema. Now, another thing is, so that is like you are allowed, but how you know you're allowed? Or we have the security matrix, we have the account owners, so I need to know who you are. But now you are about to go to the security define function. In security define function, when you are inside, you're already Postgres, so how I know who you were before you come? So I actually have non-security define function on top, which passes me a current user. And then, okay, if I'm allowed to do security definer, how can I make sure that I am not, nobody calls it directly? And for this, I am actually checking the stack. So security define function can be only called not standalone, but from non-security define function. This way, I know that I captured who you are correctly. So, and then I know, are you allowed not just to execute the security define function, but to execute it on this particular object. So you cannot drop somebody else's schema. You cannot create objects in somebody else's schema. You cannot assign new user to somebody else's schema. You can only do it as you, and by the way, Postgres as well. So like, it's like disappointment for our DBAs, but yeah. All right. So that is like, again, very briefly how it works. And I know it was not enough code. The package is pretty gigantic. What is next about this? So first of all, users are keeping asking me about reporting. And although I have this list all privileges, but it's on my backlog to create reporting which tells you, okay, this database has these accounts, these schemas, and those are the people who like have this role. So nice JSON is due. It will happen. Unit testing, you know what, nobody wants. So first of all, people do not understand that you need unit tests. It's like the whole big thing. Nobody wants to do this. Not like I love doing unit tests, but with this complexity, I actually had to do this. I am like 80% done with unit tests. You know, it turns out each time that I did not cover some of the cases. I have like about 100 tests for each of the versions of this matrix, and it's still not enough. I'm still finding cases. So hopefully it will be done soon. And conversion automation. So if the big thing is that we have customers who are not on security framework, and now we're making it as a company-wide standard. And we want to automate the conversion from God knows what, like literally, like you cannot imagine what can happen, to a proper security framework. So far, it's severely manual process because, again, people are so creative. They are like schemas owned by login user. Then you need to do several things. There are objects which are owned by different users within one schema. So fun part is I try to kind of automate it, create functions. So when you have partition table and partitions are like several thousand and we have it in honest to God, it's legit in many cases, then I'm like running off DDL logs in transaction. So I actually, before I do this, I need to investigate how many schemas have partition tables, and then I need to change ownership because, yes, all partitions ownership is separate. So far, it's like very, very loosely automated process. So that's my backlog. Again, most importantly, I would love to have lots of these things as part of Postgres. Like to summarize, I do not think Postgres should revoke things which do not exist silently. I think there should be some hint. I would love to have an option. I created the schema. Please make sure all objects in the schema are owned by schema owner. I would love to. That is a minimum, you know. I talked to many people. They already told me that preventing from granting privileges directly to user is not working since we did what we did with roles and users. So, and I know that you can create something as no login role, and then you can just add a password, you are login role, great. So like, yeah, no salvation there. But you know, at least the way we are doing it now, it helps. And each time any of our internal customers kind of like, oh my gosh, what's happening? We like do not know, like we lost permission here, like permission not granted, whatever. Like, okay, switch to this. This framework gives some sanity to DBAs on support, because at least we know what to expect. And again, we know that nobody, even other DBA on support, who does not know. I got so many calls from DBAs on support. Why I have this error? Because you are not allowed to do things directly. Yes, yeah, yes. So yeah, so that's it. Thank you for listening. Hopefully it was interesting. And questions?
Yeah, questions? To you first.
Hello, hello. As far as visibility into the issues you presented, do you or have you ever considered using like a threat modeling tool or other command line tools to identify permission issues or other issues with databases, like Microsoft Threat Modeling Tool, or would it work?
No, okay, so permission issues happen. So the thing is, like everything what I demonstrated, I came across when I was trying to convert people and was trying to switch permissions. I found so many things, I like don't want to know how many I found. And then the question is like how you, that's a big problem because there is no like command in PSQL which allows you to list all permissions. You can, there are some SQLs like this recursion which allows you to list all roles, but that's pretty much it. You cannot really list all atomic permissions. So I have this diff package is open source. So again, it's one hat in Postgres, hat in GitHub. There's diff package, D-I-F-F, and I have it there. So that's a function which you can like deploy. Okay. On your database, it's not an extension, and it will list you all permissions. So other things like maybe there is something else. I'm listing all I found, but it's like inconsistent. Slides will be, okay, if they won't be there within the next hour, you can find me and like beat me, okay? I was making changes like until this morning because I forgot to adjust to display size.
Does either you or the Chicago group that you work with have any fabulous GitHub repos where we can borrow some of your code?
Sorry, say it again. What was what we do?
Do you or the Chicago group have a GitHub repo where we can borrow code samples?
Okay, so this one is not open source because I developed it for the company, and I still need to figure out what I will outsource, What all my open source projects are in my repo. I have 5 open source projects. Again, HTTD, I'm visible, okay, so you'll find me.
Okay.
I will try to open source, like at the moment it's proprietary code, but I'm planning to open source as much as I can. At the moment it's not.
So for the security piece, did you reference any like NIST or CIS or any security-related templates to secure your module? Did you use that in your module?
Wait. No. It's all like empiric. So pretty much, you know, like first security scheme is everybody using, and I started to use it. I used it my 3 previous jobs in startups, and then all of a sudden I learned that people need way more, and I just started to come up with models, and then I generalized them. So far, all I have within this like 280 databases fits in one of these 4.
Anybody else? Any other questions?
All right.
Okay. Yeah.
Do you have any strong feelings towards row-level security?
Scary things about security?
Yeah, how do you feel about row-level security?
RLS, row-level security, where it restricts,
okay.
which restricts which rows, yeah.
So, okay, I can tell how I feel because people whom I want to hear this are not here, but I will tell anyway. This is one of these things when people who came up with this, they do not know how people use Postgres in the real world because it's like not needed. It's like not needed 100% because they are not users who are sitting and typing commands. There are applications, and most applications, like if we have like one user per application, it's already huge. Plus, very often, it's like one user for all applications. So forget about this. So I think it just like one of these things when I try to be voice of reality here, you know?
So
I'm not a contributor, I'm nobody.
So then do you think it's a bad idea to have many different users accessing a single database where maybe?
No, it's great.
Okay.
It's a great idea to separate by users, but the world does not work this way. Again, I'm in the real world. I'm a realist. I know that there is ORM, no matter how much I hate ORM is there to stay. No matter how I hate many things which are out there, they are here to stay, and my goal is to assist application developers to do what they need without creating hazard in the database. That's all I'm trying to do. So like row-level security is something which like I was always wondering what was the idea behind this, because it's like absolutely not like applicable to real life.
I actually have customers who use it, so.
All right, okay, no, I'm happy if somebody does, you know?
Okay, awesome. Any other questions?
All right, thank you. Thank you, Dan.
I think so.
Thank you.
Thank you so much.
Test, test, test. Hello? Test, test, there we go. Cool. Maybe. No, I can always speak louder. All right. Yeah, I feel like I'm at the dentist. That is definitely not comfortable. Test, test. Hello?
Is there a way to turn the volume on?
Oh, it is on. Oh, turn it up.
on means,
I don't know. Like,
the volume.
turn up the volume. I don't know if I could do it from here. There's probably a. Or like again, I could just do the handheld mic. I'm
They are
quite.
the same.
Yeah, but it'll be easier to control.
You can use that microphone, but you need to repeat every question.
Yeah, yeah,
It's okay for you?
yeah. That's fine.
Okay. So,
This
take it
is-
on.
Yeah.
Okay.
Test, test. Cool. Much better. All right, good morning. How's everyone? Good? Cold, yeah. So I apologize, unfortunately I don't control the temperature or the weather, so there's only so much I can do. Yeah. You control the, okay, so Devrim can control the weather, so thank you, Devrim. Hopefully it'll get a little bit warmer. But this is a very hot topic, so that will also get it warmer. So I'm Jonathan Katz. I work at AWS. I'm also on the core team of the Postgres project, and for better or worse, I have been staring at this problem of vectors for well over a year now. And I'm very excited to talk about this topic today, which I'm terming vectors are the new JSON. And maybe before we start, like, it sounds kind of weird. Like, what do you mean vectors are the new JSON? Like, that sounds like you're just trying to do something that's like clickbait or get attention to it. But allow me, please entertain me for a bit. So here's a JSON document, and this seems it has some content in it. It's about Postgres. It contains something about supported versions, and we saw at one point that we might have like an application that has this JSON document, and you're like, okay, cool, well, I love using Postgres. I'm gonna take that JSON document, I'm gonna turn it into a relational structure. Side note, I think that pretty much all JSON can be turned into a relational structure, and stored in a database. Cool. But then we got the notion saying like, hey, that seems like a lot of work. I already have structured data. Might not necessarily have a schema as we know it from a database standpoint, but it has structure. Why can't I just take it and store it directly in a database? So people did that. We saw a lot of these JSON databases or document databases come up in the late 2000s, and likewise, Postgres ended up supporting it, in part because as I could say right here, JSON's a data type. It's a complex data type, but it's just a data type. And one thing that Postgres does very well is that it stores a data type. And it stores it, it basically has a representation. It's storage that allows you to query it and manipulate it and get all sorts of insights on it. And that goes beyond just Postgres. To be fair, that when you have a data type and you have a database or a data storage system, you can store it, you can query it, and you can do all sorts of things with it. Postgres has a long, rich history with JSON, starting back in 2012. I mean, as JSON really became popular in the late 2000s with web apps, we saw like a huge demand for folks who just wanted to store their JSON data in Postgres because it either lived next to their other application data or it was their application data, and it was just much simpler for what they were doing to be able to query it directly. What was cool is Postgres was the first relational database to be able to store JSON, and lo and behold, it became part of the SQL standard, which is pretty neat. Now, fast forward a bit, right? This started back in 2000. Let's go to 2024. And this notion of this like kind of weird line has become very popular. This is a vector. And to the best of my abilities, I drew a two-dimensional vector of 0.5, 0.5 coordinates or attributes, bear with me. And a vector has two key properties. It has magnitude or size, you know how big it is, and it has an angle. So basically, you have some kind of size, and you're pointing somewhere in space. And it's kind of cool because you can add more attributes and more dimensions to it, and you can see that, okay, here I am in 3 dimensions, or hopefully you can see the 3 dimensions. My parents are grateful that I didn't go to art school. And you can see that I'm pointing, I can see where I am in space. Vectors are kind of old. JSON's a newer data type. Vectors, they have some history to it. They have about, let's call it like 120, 130-ish of history. And there's this book in 1901 that codified the early mathematics to vectors. Now, back then you saw vectors in more mathematical applications around physics. You kind of study vectors when you're learning about forces in physics, or even and then translate back to introductory computer science classes where you learn that you can have a vector as being a specialized form of an array. But vectors have become very popular as of late, which again is interesting, right? Because I said, wait a second, we kind of learn about vectors indirectly in an introductory computer science class, but they're a big deal now in these storage systems. And it really is because of generative AI, which in some ways I take a step back even further. I think the reason why it's become very popular is that it's much simpler to use AI and ML systems today. True story, back when I was in college, I thought I was going to go into machine learning. I was fascinated by the fact that you could take these systems and learn on them and be able to create inferences or, some kind of artificial intelligence. It's something that really fascinated me. But at the time, I was looking at all the research going into machine learning, and I was like, oh, everything's ad hoc. Whenever you want to do something, you have to build your own model. It takes time to train it. It's very exhaustive. I'm impatient. I'm going to go into the startup world. I'm going to build web apps, yada, yada, yada. And of course, why I kick myself is I didn't have the foresight to see that this would be commoditized, that using these models would be as simple as making a REST call. And that's really the transformation in many ways, is that yes, these models are much smarter and they're able to get these inferences that are much deeper today, but they're so accessible. Like, we can use them very easily. Like, we can just go right now and, you can probably go in right now and have one of these models build out the talk that I'm giving right now. And that's really cool. But the other key thing about what we're seeing with, the big foundation models is that they're trained on public information or information that is widely distributed. I like to think of like the entire internet as being that kind of database. But there's a lot of information that's in private databases. Information that you've been collecting for your applications or whatever things that you're doing that the foundation models don't know, but yet there should be a way to be able to take that information that you have in your database and be able to use these foundation models to be able to build that generative AI experience or that richer, add a richer AI experience to your applications. And the example I like to give is something called, the technique that's become very popular is retrieval augmented generation, which I'll explain in a second, but I'll start with an example. So when I first built this out, I was sitting in my in-laws' sunroom in Florida, and my father-in-law loves to collect all sorts of like Florida tchotchkes, that's like alligator heads, toucans, all sorts of kind of birds. So I'm like, okay, let's say I had a store that was selling tchotchkes. And I took the example of like a blue elephant vase, because blue elephants, I kind of like them. And it's like, okay, well, let's say I go to a foundation model, and out of the blue, I'm like, how much does this cost in my store? And the foundation model is going to be like, I don't know. I don't have access to the information in your store. I don't have access to that database. And that's where retrieval augmented generation comes in, which I'm just going to say RAG from now on, because I'm going to trip up over those words. But the idea with RAG is that you do have information in a private database that you can use to augment the model. So in this case, I have a product catalog, I have pricing information, I know how much a blue elephant vase costs, and when that question comes in, I can basically take that information residing in my database and put it into the, the foundation model to be able to trigger the response, to which I could say, oh no. Yes, a blue elephant vase does cost about $20. And that's the really cool part, is that you don't need to have to train your own foundation model to get that experience. You can take the information in your database and be able to augment that. Then the question becomes, that's great, how do I do that? And that's where the vector comes in. We basically need a way to be able to take the information in our database and have in some ways like a lingua franca or a universal language to be able to move the information from the database to the foundation model and back. And that's where this occurs in the RAG workflow. So RAG occurs in two parts. The first part is you need to be able to take your raw information, it could be unstructured data and what have you, and be able to create a numerical representation of it. And today that numerical representation is the vector. So that's that first part down here. The example here is like I have a bunch of PDF documents. Let's say this is like my store catalog. You have to do something called chunking it up, because the way these embedding models work is that they look over a subset of the information, and then they're able to assign that numerical representation to it. You put into the embedding model, and then you store it in a vector database, or we'll get more into that. So that's part one. That basically builds up your data set to be able to be used for RAG. Part two is, well, I got a customer. They want to know how much a blue elephant vase costs. They come in and they ask a question, how much is a blue elephant vase? So the next part is that you have to take that question and turn it into a vector. Because what you're going to do is you're going to do something called a vector similarity search in the database to find the things that most resemble your blue elephant vase. And you'll see like, oh, okay, I have a blue elephant vase. Here's the pricing information. Take that question, provide that additional context on price, send it to the foundation model, and then get that response that we saw before. So that's part two. So the vector is important in both parts, because that's basically linking that unstructured information, whether it's the information about the products itself or the question that's coming from the customer, and it ties it all together to be able to deliver the answer to the user. So that's pretty cool. So we'll hold questions at the end, please. Thank you. So that's RAG in a nutshell. And it's a fairly simple workflow, but there are some challenges that are presented, particularly with vectors. And in the case of RAG and generative AI, the first part is how long it takes to generate embeddings. Some of these things can take tens of milliseconds, hundreds of milliseconds, or depending on how busy the model is, maybe longer. And okay, maybe that's not so bad if you're doing this as part of asking a question, but if you're generating it or you need to generate it in real time, you don't want to go through your whole data set and have to generate these embeddings all at once. You want to be able to be able to cache them somewhere. The other thing is that they get to be quite large. A lot of the models, they return over 1,000 dimensions, here 1,500 dimensions, and the attribute, the individual dimensions of the vector are 4-byte floats. So that becomes quite large very quickly. Like one of these vectors is about 6 kilobytes. Again, you're probably like, Jonathan, like 6 kilobytes is not big, but imagine you have 1 million of these. That's already like 5.7 gigabytes that you have to store. Now, again, you might say like, Jonathan, that's not very big. Like I have like all these PDF documents that are much larger. But if you think about it from a database standpoint, like your average database row is nowhere near 6 kilobytes. It's probably closer to 600 bytes. It's not taking up that much space. So you have 1 million of these, you're already paying a lot more for space. And you're like, well, look, we got compression, right? We can like shrink things down, but not really for vectors. Because these are a bunch of random 4-byte floats. Like there's no patterns that you can use to shrink them down. There's different techniques. There's quantization techniques. There's principal component analysis where you can make the vectors smaller, but you lose information when you do that. And that's part of the challenge that we're going to discuss a little bit later. So, all right. So we're already seeing that this is already pretty challenging, but what about querying them? The primary operation to compare two vectors is called you're finding the distance between two vectors. You might hear it as a similarity search. And there's two things that go on here, is that if you want to find the vectors that are most similar to your query vector in a data set, you have to query every single vector in that data set to find the ones that are most similar to you. So again, you have 1 million vectors, you're doing similarity search, you have to query all 1 million vectors. But wait, it gets worse, because when you do that, there's no shortcuts. You have to query against every single dimension in that data set. So if you have 1 million vectors, each of them with 1,536 dimensions, if a query vector, you're doing a lot of calculations there. So there's no shortcuts. Well, there's one shortcut. Something called approximate nearest neighbor search. So the idea with approximate nearest neighbor search, or again, I'm going to abbreviate to ANN, is that you can find similar vectors in your data set without searching through all of them, which sounds a lot like indexing from a traditional database standpoint. And it is a kind of index, because you are looking over a subset of the data set. And again, if you don't have to look at all 1 million vectors in your data set, if you only have to look at 100, let's say, to get your answer, that's way better. That's going to be a much faster query. And it is. It's much faster than, they call it traditional nearest neighbor search, or traditional exact nearest neighbor search, which is the term we have today. But because you're not looking over every vector in the data set, you can't be sure that you're getting the most relevant results. And that goes into this measurement called recall, which is your percentage of expected results. So take those 10 orange blocks to the, 10 orange circles to the side. Let's say those are my expected results. That if I have a query vector, I expect to see those 10 vectors. But I only return 8 of those when I search the index. My recall is 80%, because I only got 80% of my expected results. For people who've been working with databases a long time, this is a very weird concept, because you're kind of like, wait a second, I put in a query, I expect to get the exact results that I stored in back, but you're saying, I'm not getting my expected results. That personally tripped me up the first time I worked with PG Vector. I'm like, this is wrong, I'm getting the wrong results. But this is how approximate nearest neighbor search is, because you're looking over a subset of all the data in the set, and you're making a best guess. And some of these indexing algorithms are very good, that you're going to get a high level of recall, 95%, 99%, but you might not get the best answers or all the answers that you'd like to see there. So this is a very important concept to keep in mind as we go further into this journey. So before diving into one of my favorite topics, first, a very good thing to ask is when you're looking at storing vectors is, does vector storage even fit into your workflow? Like, do you need to actually have a quote vector database to store the vectors, or is it something where you can do it entirely in memory? You can use a library like Feist to be able to calculate everything. That's one thing that you do have to determine. Like, you may not need to store vectors. But if you do, like part of that math is like, how much data am I storing? Is it millions, tens of millions, billions, hundreds of thousands? And because based upon that, there's going to be all sorts of costs associated with it. I mean, as we saw, these very large vectors have a payload. 6 kilobytes for a 1,500 dimensional vector is a lot. If you have tens of billions of those, you're probably going to look for cheaper storage. But if you have 100,000, 250,000, whatever it is, that's still not that much. And then from there, you're going to decide, what makes the most sense for me. Like, do I want something that's high performance? Am I most interested in 100% relevancy? Like, I always need to do that exact nearest neighbor search. And ultimately, what is my budget? And from there, like, once you understand which attributes are most important to you, then you can make designs for your vector database. Traditional things like schema design, which is my favorite thing when working with a database. And you can determine like, what's your indexing technique you're going to use? Do you need an indexing technique? What's your target query time? Which brings us into Postgres as a vector store. So this is really cool, right? Because Postgres has a long history. I'm roughly the same age as Postgres, and Postgres has evolved through the years from being your traditional relational database to being a geospatial database, being a time series database, being a document database. And what's great is that now we can see Postgres as a vector database. And in part is this because Postgres from the get-go was designed to be extensible. You can add functionality to Postgres without having to fork Postgres. And that's a really powerful concept. And what's also really cool about that is that over the past several years, Postgres added the ability to build your own custom indexing techniques without leveraging one of the existing indexing frameworks in it. And this is very powerful, particularly when we're looking at vector searches, because one of the reasons why Postgres has become popular for vector searches is that it can work with your existing client libraries. Again, I'll make a confession in front of a bunch of database folks. I like using ORMs when I was an app developer. It was very easy and convenient. But that's great, right? Because now if I want these vector capabilities in my database, I can continue using my favorite ORM and I don't need to change anything. And that's powerful too. And also because likely in my application, my AI/ML data is, I want to keep that on the same database as the rest of my data. And being able to have that co-location is powerful because I don't need to store my data all over the place and suddenly have like a distributed data problem. I can keep everything all in one place. And that's very nice. And then you get Postgres with your vector database because Postgres does a lot of things for you that you might take for granted. Being an ACID compliant database is very important. I always like to focus on the D of ACID compliance, the durability, that I know that if my database is writing data to the disk, it's getting stored to the disk. I know that's a very powerful property, as well as the properties around like visibility and how things ultimately get searched. So just as a fun fact, Postgres actually has been a vector database since the get-go. The array data type was in the original, was originally in the Berkeley version of Postgres. Arrays were created to help with looking up access control lists within Postgres, so you didn't have to do a join out to be able to get those rules. They could stay, you could look at everything in one column. Now, the array data type is awesome. It's very versatile. It works with, a bunch of the data types already within Postgres. And, there's almost like no limits with it, as I say there. But it doesn't support distance operations. However, back in 2000 or 2001, the cube data type came there. And the cube data type was basically able to store larger vectors of data. Actually, you could index up to 100 using the built-in, and with the built-in gist index, you could do like exact nearest neighbor lookups very quickly. Just a side note, the gist index is what PostGIS, which is that geospatial capabilities for Postgres I mentioned, leverages to do very fast exact nearest neighbor searches. Now, cube is great, but it's limited to 100 dimensions. And again, like when I was studying machine learning, like 20 dimensions was a high amount of dimensions. So like I see like 1,536, it's like what is that? That's a lot of dimensions. But the fact is that we're limited because with the things built into Postgres, we're not able to handle these newer size vectors. So this brings us to PG vector. pgvector is an open source extension that gives you all the capabilities you need to be able to do vector search in Postgres. For one, it has a vector data type. It has a couple of indexing methods which we're going to go into. It supports exact nearest neighbor search, approximate nearest neighbor search, a bunch of different distance operations. And the best part of it is that you get Postgres. You can take your vector data and co-locate it with all the other data associated with your embeddings and have it all in one place. Now, I'm rushing over this slide because we're going to dive deep into like all these different things during the remainder of the talk, but this is pretty cool. And like this is the power of the Postgres extension framework, is that if there is a new kind of data pattern or some capabilities that are needed, you can build it in an extension. And also, as we learned at the AMA yesterday, if there's something that you can't do in an extension and you need to expose something in Postgres directly to enable it in an extension, that's a great topic of conversation with people who are contributing and hacking on Postgres. Now, one thing I do want to address real quick is just understanding pgvector performance. And there's a lot of different benchmarks out there. I could probably do a whole talk just on vector benchmarking. But one thing is that it is like relatively fast, particularly with some of the newer indexing methodologies out there. This was like one test I ran just to like look at throughput. And in this case, I was actually trying to compare different processors. But one of the powers of Postgres is that it can scale concurrently, and it can scale vertically pretty well. And like this does apply to vector data. That if I do throw more concurrent selects at the data, and I continue to vertically scale the hardware, that it can actually go pretty far. So that's one thing to consider. We're going to look at a little bit of some scaling techniques throughout the talk, but it does perform pretty well, particularly when you're looking over like a smaller space of your vector index. Now, as we're going to see throughout the talk, there is always going to be a tension between the speed of your queries and the recall in your queries. And there's a lot of things that factor into recall, but just keep in mind, when you're trying to decide what is your target recall, that is going to impact ultimately the speed of your vector queries. So I'm going to take a quick drink of water. Unfortunately, I have the handheld mic, so please bear with me a second. And now I've modeled how I can drink from a bottle of water. So distance. Distance is very important, because remember, the distance is the fundamental way that you're going to compare two vectors. pgvector offers three different types. There's Euclidean or L2 distance, which is line of sight. So think of that as like me looking at you, looking at me. You have cosine distance, which is angular distance, which is like, it's my angle. And then you have inner product, which kind of captures elements of both. All three are used. We've been seeing cosine distance has been more popular with some of the larger embedding models. It's one of those things where you do have to try it out. Now, all these have like different mathematical properties to them. I'm trying to make sure I can get to all my slides, so I didn't put a slide comparing all of it. But one key thing when you're designing a vector database or a vector indexing and search system is that you want to cheat wherever you can. And when I say cheat, you want to reduce the amount of compute wherever you can, because they're costly operations. And in particular, a lot of these operations have division, and division is like the worst of all the operations. That's still to this day the most one of the most expensive compute operations. And that's where there's this trick. There's something called the unit vector, which is basically if you take all your attributes and you find the magnitude of it, it comes out to 1. You might also hear it called as normalizing a vector. So when pgvector stores a vector, when it stores it in the vector column, that column is going to be stored as, it's going to store the vector, as you insert it. But when you add it to the index, it's going to normalize it or convert it to a unit vector. And the reason you're going to do that is it's going to let you cheat when you do some of the distance calculations, because you're going to be able to eliminate some of those divisions, and in some cases maybe some of the multiplication operations, which makes it a little bit faster. Because remember, like whenever we're doing these operations, like any place we can shave off CPU, the better. I mean, another note I'll just say right here is like one of the challenges with vectors too is that you kind of have to optimize like everything in your compute cycle. CPU, memory, I/O. I like to say it's just really a nasty data type, because there's so little shortcuts to be able to speed things up that like any shortcut that you can get, like just take it. And this is a popular technique, is storing the normalized version of the vector. The other nice thing about normalizing is that you don't lose information. But when you're looking, if you were to visualize the vectors in space, you could actually see them get like clumped a little bit too much together. And that becomes a little bit more of an issue when you're dealing with ANN indexing. Speaking of, pgvector provides two different ANN indexes, IVF flat and HNSW. So IVF flat is a cluster-based indexing method. We're going to look at both of these in depth throughout the rest of the talk. And what's nice about IVF flat is that it's relatively simple to understand. When you think about it, it's like, hey, I'm going to build clusters around a few lists. So like define like where my centers are, and then cluster my vectors around them. What's nice is that these indexes tend to be very quick to build, but they tend to be, you have to basically have all of your data preloaded up front in order to build them, in order to create the correct vectors. Okay, please hold your questions till the end of the talk. Thank you. So with HNSW is a graph-based method. So when you think about traditional database indexing, you store things in trees. Graphs are just a superset of trees. I like to call them like slightly more complex trees. And the way HNSW works is that it organizes vectors into neighborhoods. So the idea is that when I'm trying to place a vector in the index, I'm trying to find the vectors around me that are most similar, and I might say, like, find me the 16 most similar vectors. Once it does that, you create links to all those vectors around your neighborhood. And what happens is when you do the search, you trace these neighborhoods to be able to find these strong clusters, and more likely than not, you're going to find the vectors that you're most similar to. We're going to see a demo of how these work. What's nice about HNSW is that it's an iterative index where you don't need to have your data loaded all at once to use it. You can continue to insert it. But it does have a much higher build time than IVF flat. So I'll give the cliff notes, like which search method do you choose? It's a little bit complicated, but there's one simple one that if you need 100% recall, you got to do an exact nearest neighbor search. Don't choose an index, because you can't necessarily guarantee with any method you're going to get 100% recall. If you need fast indexing, you're going to choose IVF flat. And that's, if you know that you're going to need to rebuild your index constantly, you're adding data in such a way where, it makes more sense to just continue to rebuild and find the new centers, use IVF flat. The reason I put an asterisk is that the recent releases of pgvector have improved HNSW build performance significantly, where this is becoming slightly less true. It's still true, but with some of the HNSW properties, it makes more sense to use that. And just being ahead, from an active level standpoint, HNSW is a lot simpler to manage. It feels more like a, quote, traditional index. And it has, what's nice is that it gets this high performance recall ratio in the sense that you're able to very quickly find the vectors that you're most similar to, and more likely than not, they're the most relevant to your results. Most of the vector databases out there offer HNSW as the first index available. There are reasons to use both. This gets into a deeper discussion, and I've seen people implement IVF flat in their production systems, and they're very happy with the recall and performance. So in some ways, the answer is test and see which makes the most sense from you. I'd probably recommend starting with HNSW because it's a little bit easier. But again, you have choice. I think that definitely helps, particularly because there's a lot of other factors that go into recall beyond just what indexing strategy you use, such as your embedding model. So let's go into some strategies and best practices. And I divided them up into 5 sections: storage, the 2 indexing sections; filtering, which to us database folks is the where clause; and one that I actually worked on the airplane over here today, 2 days ago, which is distributed queries, which is kind of exciting and scary. So storage strategies. In order to understand storing vectors in Postgres, we need to understand toast. And I can make the toast joke like, no, it's not the thing that you put in your toaster, but in some ways it kind of is. So toast it's called the oversized attribute storage technique. And the reason why toast is important is that by default, Postgres stores 8 kilobytes of data within a page. The page is the atomic unit in Postgres that gets stored to disk, and that's one of the ways that we're able to implement all of the nice features around Postgres. But we have data that's larger than that, text being like the first example. And toast was designed to be able to store data that went beyond 8 kilobytes. I believe you can store up to 1 gigabyte of data in a single toast row. I think that's correct. If not, I apologize. But by default, if you have data over 2 kilobytes, Postgres toast it, which is going to happen quite frequently with these large vectors, that you have a 510-dimensional 4-byte float vector, it will be toasted, and anything beyond that. So let's understand like what happens when we toast it. Because again, for like a lot of us, like we've never considered toast, other than the fact that it just works up until this time, but it's going to impact us. So Postgres has 4 different column storage types which impact how it gets toasted. The first is plain, which basically says store the data in line. But keep in mind, if you use that, you're only allowed to store up to 8 kilobytes of data, which is roughly a 2,000 dimension vector. There's extended, where data is stored and compressed in your toast table. This was the default in pgvector before 060, but keep in mind, there's that magic word compressed. I thought we said we couldn't compress vector data, and that's correct. We're basically wasting time trying to compress it to figure out like, oh no, we can't compress it. In fact, it's actually going to generate something that's a little bit larger, and ergo, we're not going to compress it at all, which led to the adoption of external as the default storage type in the newer versions of pgvector, which you'll store it in the toast table, but it won't attempt to compress it. So we'll save some CPU cycles, because again, every bit of CPU we can save, we want to save. And finally, there's main, which just for completeness, it's here, not super relevant to vectors. Now, why am I spending so much time on toast? Because it can impact your performance. So here's Postgres has had query parallelism since version 9.6, and it's a wonderful feature, and particularly if you have to do a lot of these vector computations in an exact nearest neighbor scan, you're going to use it. So I had a data set, I think it's 1 million, I can't read, it's either 1 million or 10 million, I can't tell, I think it's 1 million, but it's like, hey, do an exact nearest neighbor scan on 1 million 120 dimension vectors. Cool, I'm gonna give you 6 parallel workers. So let's do the same thing on 1500 dimension vectors, and it says, cool, I'm gonna give you 4 parallel workers. That seems wrong, right? Like, wait a second, this is much smaller. Why am I getting only 4 parallel workers here? And that's kind of like a gotcha. Because these vectors are toasted, when Postgres is doing the query planning, it's basically seeing, the toast table is actually a separate table. So it does the query plan, it looks at the main table. It's like, there's not that much data here. Because like all the data is in like a different table, and it's not considering that in the query plan. So that's a gotcha. And like we need to make some plans around that, because one of the big differences between this and how toast was originally used is that the vector's in your hot path of your query. Like it's being used for serious workload. So there's some ways around this to make your life easier. One is use plain storage. If you know that your vector's not going beyond 2,000 dimensions, you can store it in line. Just make sure it makes sense with the rest of your queries, because that is a lot of data. The reason that we use toast is to speed up queries that are in your main table. So, but if your vector query is the raison d'etre, or the reason that you have that table, it may make sense to keep it in plain storage. Also right now, pgvector only supports up to indexing 2,000 dimensions, so plain storage may make sense for that. We'll talk a little bit about that other point later. Or there's this parameter called min parallel table scan size, which can help induce more parallel workers. So in that previous example, I kept my vectors toasted, and I set min parallel table scan size to 1. And look, 11 workers, a lot more, which is good because we can definitely benefit from a lot more workers in this case. So the reason why I spend so much time on toast is, going back to my roots as an app developer, this would not be something I would think about at all, because again, most things in Postgres, it's just like set and forget and it just works. But because this data is a little bit different, and because of like the size of this data, like it helps to understand these techniques to make sure that we're optimizing our performance. And there's probably a discussion of how do we make this simpler, and it is a fair point, and I think that's something I'm personally interested in helping out on. So let's get into HNSW. So HNSW stands for Hierarchical Navigable Small Worlds. Say that 10 times fast. And as I mentioned, the idea is that it's a graph, but a graph is just a specialized tree. Well, it's a superset of a tree. And the idea is that when we search through things, we're going to search through a vector space where we start with a very sparse. The way I could think of it, I thought about this the other day, is like think of it like a cake. We have a cake of vectors, but instead of vectors, we have sprinkles. And let's say I designed the cake where at the top of the cake, I have a few sprinkles. Going down, and and each layer I get more and more sprinkles till the bottom layer has like all the sprinkles. I'm basically tracing the sprinkles through the cake, that like I find like the sprinkle I'm closest to here, and I go down like, oh, maybe it's here, et cetera, et cetera, et cetera. And it was actually kind of a very interesting algorithm. It's been around for about 7 years, I think, because it did basically help put folks, or help put like query vectors into the right space. The key with HNSW is your build. How you select your build parameters will ultimately impact how you're able to search over them. There's 2 key build parameters here. The first is M, which is the maximum number of bidirectional links between index vectors. So, think of M as like, if I'm standing here, I'm being indexed, I'm going to build like links to like the 16 people closest to me in this room. EF construction is effectively your memory as you're going through and building the index, that you're keeping a list of all the vectors you're closest to, and ultimately you're going to choose your closest 16. Think of it as like your search radius. Like the larger the search radius that you have, the more likely you're going to pick the vectors that you're most similar to. Now, there's going to be, there's trade-offs to this. We're going to see, the different trade-offs in a few slides, but instead of me trying to visualize myself as like a 7-layer cake, let me show you, how an animated way of how building an HNSW index works. So let's say I have a bunch of vectors, and I have a vector I'm going to index that's in orange. What happens during HNSW is you first start at the top layer. You have something called an entry point, and then you find the vector that you're closest to. In this case, it's this one. What happens is then you go down to the next layer, and there's a few more vectors, and then you find ones that you're closest to, and you might build some links along the way as well, because that's going to ultimately help the search that happens. And then you get to the bottom layer, you might find a few more vectors that you're closest to as you build those links, and then there you go, you're indexed. So again, oversimplified example, but that's effectively how it works. And again, in order to do that, it might take some effort because you're maintaining a list of like vectors that you see in that EF parameter, but when you do that work up front, the payoff is in the query time. So when you query it, there's one parameter you need to be aware of, EF search. And EF search is, again, similar. It's like how many of those nearest vectors are you maintaining in a list? The more of those vectors you maintain, the more likely you're going to return a highly relevant search, but there's going to be a cost because you're maintaining a larger list that you have to look over. That value must be greater or equal to limit, by the way. So if you have like limit 50, EF search 40, you're only going to return 40 results. So you're not getting everything that you need to see in the limit. I think a newer version of pgvector put in like a check or a guard against it, but I don't remember off the top of my head. And search is very quick. The idea with the search is you start at the top layer, you find your entry vector, and then once you go in, you're going to find the vector that you're closest to in that layer. Go down to the next layer, same thing. I started there, I'm going to find the vector I'm closest to. Go down to the final layer, and then I'm going to traverse the graph, and I'm going to find the vector I'm closest to. Cool, very quick. Kind of feels like a B-tree search, and in many ways it is. A graph is just a larger tree. So there's a few best practices, and I'm going to say these keep evolving, and I think that's like one key point with vector searches is that this is like a very rapidly evolving field. Even like when I first wrote this talk, some of the guidance has changed, as you can see by the second and third bullet point. The nice thing, we did a lot of testing on the default values, and like the default values usually work, though we're going to see that based upon a recent pgvector release, we can probably crank up EF construction a bit. The other thing I just want to mention as well is that not all HNSW is equal. Different vector databases have different implementations of HNSW. Some might use a library like Feist to be able to perform the algorithm and store it to disk. pgvector actually implemented HNSW itself based upon the paper and actually chose a different version of the algorithm than some of the other implementations. This was actually in part to make sure we could optimize it for Postgres storage. Because what you'll see with like some of the query performance from HNSW, like it does depend on how many times you have to go to disk, how many times you have to go and retrieve pages from disk. The more that you have things clustered like on the same page, the faster it's going to be because that's going to be less work overall as you're searching the data. That doesn't mean like there aren't some other techniques we can do to help speed things up. Particularly with building indexes, with pgvector 051, you want to use this concurrent insert method where you'd start with an empty index and then either do concurrent inserts or copies because that was going to be way faster. pgvector 060 added the ability to do parallel builds. So you could preload your data and then do use parallel workers to build the index. And Based upon some early testing, that's looking to be a little bit faster than the concurrent insert method. I will note that there was a commit earlier this week that's targeted for pgvector 062. That's going to work much better for very large data sets. I was actually trying to build a billion data set with like 128 workers, and I was noticing like, oh gee, this is not going as fast as it could. So Andrew Kane, who's the primary maintainer of pgvector, within a few hours found a locking contention issue and solved it. By the way, Andrew Kane has done an incredible job with pgvector. I just want to note that for the record. But yeah, so I would say generally though the parallel build, if you're able to leverage parallel builds, it should be a little bit faster. Now this has also updated some guidance. So as mentioned, it's all for HNSW. It's all about your build parameters and what you choose. And before pgvector 060, I would say that, for instance, on this data set, it was like over 1,500 dimensional vectors. You start seeing diminishing returns on recall, as we cranked up EF construction. That one of the reasons why the default was good enough is like you're getting pretty good recall at that level. It's already 0.91. Like, do you really need to spend a lot more time building the index to get 0.93? I mean, this is a difference of hours here. But rerunning the same exact test, using 64 parallel build workers on pgvector, well, I think pgvector 0621 released, notice that we still kind of see the same degradation, right? Like, we're not getting, you're going from like maybe like 0.91 recall to 0.93, but the time axis changed significantly. Like, we're talking about minutes, not hours. And that's big, right? Because like, even if I'm still seeing the same performance degradation, but I can measure it in minutes, not hours, that's an argument to say like, hey, like, let me use EF construction 256 instead of 64, because I will get slightly better recall, and the cost of getting that recall is not that bad. So that's why I will say like this is a rapidly evolving area, but we're definitely seeing performance gains, and it is helping us to update guidance. And just in general, if you can build more accurate, I use the term accurate, machine learning folks don't like when I use accurate here. If you can build more accurate indexes though, it makes more sense. And again, M is a parameter that helps with that as well, that we can see, this was the GIST 960 data set, which tends to be, most approximate nearest neighbor indexes don't do well with it, but the parameter M, which is the bidirectional links, can help increase recall. But notice like the time penalty you pay. Again, like we're talking about hours. So you have to decide what's most important to you when you're building this. That are you looking for better recall and you're willing to pay the upfront cost of building the index? Or do you want the index to get built quickly and deal with the fact that you might not necessarily get the most relevant queries? Though, again, relevancy may make sense for you. So that's it in a nutshell for HNSW. You have a few levers. Building's the most important thing. You can always increase HNSW EF search, increase recall, but there's going to be intention. It's going to decrease the performance of your queries. And the more of your data you can fit into memory, the more that you're able to, the more that speeds up queries, right? Like the less trips to disk, generally, the faster things are. So at least you want to be able to keep your index in memory. Ideally, if you can keep your index and table in memory, that'll be the fastest. But at a minimum, you want to target the index, particularly because that's going to be the fast path. So I'm going to go through IVA flat real quick. So IVA flat, as mentioned, is a clustering algorithm. It's basically decided based upon the number, they call it list, other people call it centers, you can call it buckets, but the idea is that you already have loaded your data set, and you're going to find list of vectors that you're going to group everything around. So for example, let's say I have a bunch of vectors in space, similar to the previous example. And I say, I want list 3, so I'm going to find the centers, and I'm going to assign vectors to the lists. Then when you search over it, you have this value called probes. So if you set IVA flat probes to 1, that basically means that you're going to search one center. And in this case, I want to find the 3 closest vectors to me. So if I search just one center, these are my 3 closest vectors. But if you eyeball this, you're going to say, like, wait a second, like, those aren't actually the 3 closest vectors. Like, these are the 3 closest vectors. That's correct. And what you have to do is, to get a more relevant search, you have to increase the number of probes. In that case, when you increase the number of probes, you actually do find your 3 closest vectors. Now, that's the trick with the IVA flat, is that you often have to increase your probe value to be able to get the results that you want, but it's going to come at a cost. And from what we've observed, it tends to be more linear. versus more of like a gradual, like logarithmic linear, which you might see in a HNSW. So there are some performance strategies, which is, if you want to increase recall, increase IVA flat probes, but it does decrease performance. And I think that's been the general complaint with IVA flat, that often, based upon how things get clustered, that you do need to increase probes and impacts performance. But it's kind of like, you can actually have an IVA flat index outperform an HNSW index, because if you're able to get your list small enough and you actually get, the most relevant clusters, you're going to outperform HNSW because it's going to just be like very, very quick queries. But again, I think the trade-off becomes like, do you want to spend all your days, tuning vector indexes, or do you want to build your application? So it depends where you want to spend your time. You can also induce indexing queries by lowering random page cost. Again, as an app developer, like I had rarely looked at costing parameters in Postgres until I started looking at vector indexes. And finally, you can set shared buffer, oh sorry, not finally, but you can set shared buffers, again, to keep as much in memory as possible. And if you're looking over a lot of lists, you might want to increase the work memory parameter on a per query basis. So work memory is basically how much of your working set you're going to keep in memory before it spills to disk. Because if you spill to disk, there's going to be a penalty to that because you're pulling things in and out of disk to be able to perform operations. So let's say like you have 10,000 lists and you set probes to 1,000. You might exceed Postgres default working memory, and then you're dealing with that swap going between memory and disk. So best practices. So a lot of these I took actually from the PG Vector repo in terms of how you choose the value of lists. There's an art and a science to it. The thing to keep in mind with IVA flat is that as you add and remove vectors from your data set, that could end up skewing your centers, which means that you have to rebuild it to get queries that have the highest amount of relevancy. But you can use parallelism to accelerate build times. And just real quick, the way that it originally worked in PG Vector was that when you were doing the list assignment, you would do a sequential scan on the table, basically read every single vector one by one. So imagine you have 1 million, 10 million, 100 million. That's going to take a while. With parallelism, you can basically break that up and have a bunch of parallel workers do the list assignment, which in this experiment, I saw a 2x improvement. It was 1,768 dimensional vectors. And sometimes I saw up to a 4x improvement. So again, speed is good. If you can build your indexes more quickly, generally that's a good thing. Filtering. Filtering, I think, has been the hot topic for the past, let's say, 3 to 6 months in general for vector databases. And I kind of chuckle again as with my database hat on, because this is what Postgres does. You put a where clause on something. You filter everything out. But it gets a little bit weird with vector queries. Like everything with vector queries, it gets a little bit weird. So if I add a where clause, the first thing that might happen is Postgres chooses not to use the index, and it's like, fine, I'm going to do sequential scan. So suddenly, when you thought you had a query that was returning in milliseconds, you have it returning in seconds because it scans the entire table and then does well, maybe it filters everything out, and then it you get the result of your query. It might then end up using a vector index, but you might not get enough results because your index might be on your entire data set, not on the filter, and it's doing the search based upon what vectors are you're closest to, but those vectors might not have the filtered attribute on them. If your back in this example, if your category ID is 7, and I return a bunch of vectors where category ID is 6, all those are going to get filtered out, and I'm not going to get the results that I want. Or the filtering might occur after using the index. There's actually one more thing that I need to add in here, is that you might end up using a different index to do the filtering, like a B tree on category ID, and then do the exact nearest neighbor search after, which actually might be totally fine, because if you get, say, like 100 results back, just do the exact nearest neighbor search. That's going to be super fast, and you're going to get the relevant results that you want. And I think that's what it is. I guess I got ahead. The first point is that a B tree might be the way to go here. You might not need an ANN index, and frankly, if you can use a B tree, that's much simpler. You also need to consider how many rows the filter would remove. Is that if you have, let's say your filter leaves you with 50,000 rows, and you need to do 50,000 index comparisons. At that point, you probably want to be able to do that approximate nearest neighbor search. And of course, it always goes back to, do you want exact results or approximate results? And that's on you to decide for what you want with your application. So there's 2 filtering strategies to consider today. There's the partial index, another great Postgres invention, where basically you can index over a subset of your data. and that will give you, that effective pre-filter where I'm looking at all of the rows that are assigned to category ID equals 7, and I can get the approximate nearest neighbor search and make sure I'm seeing all the relevant results that I want to see. Or I can partition my data if you have a clear partitioning strategy, but just be careful how you partition your data and do an approximate nearest neighbor search. Because if you have multiple values that match your filter within the same partition, you'll run back into the same problem we mentioned before, because you're searching over all the vectors in that index, and if you filter out too many that have the partition attribute, you might not actually get the rows that you want. There is a patch, actually there's several patches proposed for pgvector right now to do the equivalent of multi-column indexing, which is another kind of pre-filtering, which might simplify this from an app developer standpoint. Not committed yet, we'll talk about that in a second, but there's definitely more work on this. I'd say this is still one of the areas that is being rapidly innovated on, just on vector databases in general. It's not just pgvector. So last but not least, I'm actually going to call this looking ahead a little bit, distributed pgvector queries. So I'm of the personal opinion that this is still scaling pretty well vertically on Postgres, but there may come a day where we need to be able to do distributed queries, where effectively, if you don't have enough memory on a single instance to be able to efficiently do your vector searches, you might want to be able to push that down to other instances and then do a final aggregate on a single instance. Now, when you get to that point, there's a few things to consider, right? Like one, like that memory issue I'm discussing, but also your network overhead must be acceptable because you are going to pay some latency here. Finally, you have to be able to manage a multi-node system. Like that's not trivial. Especially in production, you need to worry about availability, backups, monitoring, software upgrades, et cetera. And there's definitely a multitude of ways to do that, but as I like to say, more databases, more problems. Now, Postgres does make it possible to do this out of the box using something called foreign data wrappers. So here's an example where I do the setup for a foreign data wrapper to be able to query against multiple vector databases. Sorry, multiple instances that contain vectors in them. There's a whole discussion on security here, which is probably a talk in itself. In fact, I gave a talk on that probably like 10 years ago. So skipping that here. And then you have to set up what's called a foreign table, which is a reference to your remote table. Now, what I did not show you was that I actually set up these tables on the different instances, and each of them had like 2.5 million vectors in them. So there's an additional step here, but I kind of want to show the layout here because, sorry, I should have gone back here. There's two key things to add when you're setting up the foreign server, which is you're saying like, hey, like these foreign Postgres instances have the pgvector extension loaded, and they're capable of asynchronous queries. Because you don't necessarily want to be able to query each database one by one. You want to query them all at once and be able to get the result back. So I did that, and you can see like, hey, I'm actually able to do the foreign scan. But actually, I'd say this is hot off the presses because I'm still tracing it down. I wasn't doing asynchronous foreign scans. You can see, based upon the timing, that it was cumulative when I did the final search. The other thing I'm testing right now, which actually is looking very positive, is like, this is impact recall, and the answer so far seems to be no. You're able to do this and still be able to maintain your recall targets, but ask me later in the year, possibly in May, at pgconf.dev 2024. So the thing I'm tracing down is like, can we do the async foreign scan? It might have to do with an append node versus a merge append node, but to be determined. So looking ahead, what's on the roadmap for pgvector? Well, as I mentioned, performance improvements for massively parallel HNSW builds. That has been committed. Very much looking forward to that. So this is the efficient pre-filtering. To be determined what method is used. There's a patch for HQANN to be determined, again, if that ends up going in. But again, pre-filtering is the hot topic right now. Allowing more data types per dimension. 2-byte floats, 1-byte unsigned integers. And what's cool is that there's proposals for how to do this right now in pgvector, and this allows you to do something called scalar quantization with expression indexes, where you can have your full vector stored in your table vector column, and then do a cast to like a 2-byte float in your vector index. And the powerful thing about that is that that lets us expand the amount of dimensions that we can index with pgvector. That's pretty cool. Excited for that. Another technique that I'll expand upon that as well is product quantization, again, being explored. What we found with PG Vector was, again, things were kept scaling vertically fairly well that it didn't make sense to add necessarily the quantization techniques, based upon the performance numbers we saw and, frankly, the comparable performance numbers we saw. And being able to add parallel query. The nice thing about HNSW is that we really don't need parallel query. IVFI could benefit from parallel query. HNSW, to be determined, particularly as you expand your EF search, parallel query could have some benefits, but we haven't really seen much there yet. So, in conclusion, like JSON, a vector is just a data type. And there's all sorts of different storage and search techniques to consider around it, but fundamentally it's a data type, and traditional databases like Postgres are very good at doing these things with these data types. As you add vectors into your application, should you so choose, there's always going to be a design decision between your query performance and recall. And actually, I probably should add your index build time. All those are going to be in tension, and you're going to have to choose what your trade-offs are. As far as I know, you're not going to be able to get everything. You can try, and maybe your data set's small enough where you do get everything, but as your data sets grow, you will have to make trade-offs. And you have to decide, what do you want to invest in? Is it going to be at your storage layer? Do you need super fast storage, or do you want something that's a little bit slower, based upon just the pure size and volume of your data set? Do you want to get the largest compute instance to be able to run super fast, massively parallel queries and index builds? Or are you going to keep something that's a little bit smaller, and you might have to deal with the fact that you do need to make fetches to disk? And then you have to pick your indexing strategy. What makes the most sense? It tends to be, right now, HSW is seemingly the default that people are choosing, but you have to decide what makes the most sense for you. And finally, this is rapidly evolving, that you have to plan for today and tomorrow. PG Vector is pretty mature. I've already seen plenty of production deployments. I've also seen a lot of kicking the tires, which is completely fine, because I think people are kicking the tires on generative AI in general. But you do need to plan for the fact that it's rapidly evolving. I think the foundational performance features are on PG Vector minus 1 or 2. And then from there, it really is off to the races. I think we're going to see even further innovations from that. So thank you, and we have a few minutes for questions.
Any questions?
Are there significant differences between Postgres as opposed to Chroma or Pinecone that are worth mentioning?
So I'm not trying to do this one. I'm not going to try to do an apples to apples or apples to oranges comparison between the different databases, but I'd say with Postgres, Postgres just has 40-year development, almost 40-year development history. Really, first starting with how do I store the data, making sure that I can store it safely, it's ACID compliant. And there's a whole tooling, there's a lot of tools already built up around Postgres. And the other thing is you just get everything else with Postgres. I mean, if you want to build a geospatial time series vector database all in one, that's something you can do just based upon all the Postgres extensions that are out there.
Hello. Can you please give an example of how to convert attributes, let's say in an e-commerce site, of a product into the dimensions? And also, do all of the vectors need to be the same size, the dimensions the same order? What happens if some attributes are missing from certain records?
Yeah, so I didn't understand the first part of the question, but for the second part, when you build an index, all the vectors within the index have to be the same, have the same dimensionality. You can store mixed vector types within a Postgres database, even within the same column. But then when you build the index, you have to make sure all those vectors are of the same dimension.
So the first one was, you showed in the example how you have dimensions of 0.5, 0.5, 0.5.
Yes.
How do you get to those numbers from the actual record that you're trying to compare?
So is it if I want to introspect those numbers directly? Or is it how did I make up those numbers?
Yeah,
Oh, so that was just an example I contrived. What's happening with the generative AI models that I have some text, vectors are the new JSON, and I take that, put it into the embedding model, and it's going to generate the attributes. But that's basically about how the embedding model is defined and how it's able to do that. That's on it.
Just final question.
Yeah. And I can answer questions outside after.
Yeah. Thank you.
I was just wondering, with your RAG diagram, when someone queried the database, in the diagram, it also inserted back into the database. I was wondering, when you insert new data, do they have to rebuild everything for the vector, or?
So no. So even with both IVA flat and HNSW, you don't need to rebuild everything when you insert it. And in fact, with Postgres, it's an online insert. So as soon as you insert the record into the table, it's automatically going to get inserted into the index. Now, IVA flat and HNSW have different properties around the insert. Because HNSW is iterative, it's kind of like building a traditional B-tree index where you insert it and you're going to put the vector in its highest probability space of where it occurs. With IVA flat, because it's cluster-based, what happens is that you will insert it into a cluster, but over time, your centers are going to skew. So the centers you have represented are not necessarily the true centers anymore. In that case, you might want to rebuild in order to get better results.
Thank you.
Thank you.
Thank you, everyone.
So the next talk is about Postgres 17 in this room in 15 minutes. quickly. Away from your mouth. You may need to use a hand mic, like Jonathan did.
Yeah, we'll try it, but we'll see.
Speak.
Yeah, is it on? Yes. But, yeah. Are you gonna stand there and hold it? Or you can stand there and hold it?
Sure, you'll be standing anyway, so but we need the tape.
Okay, I think it's time to start. Okay, thank you, I'm done. Well, at least this microphone works. As those who saw the previous talk as well, there are some challenges with the other one, but you know, there should be some technology challenges. So I'm expecting my slides to give up about halfway through. You know, just because they can, just because, you know, the possibility exists. Well, welcome here to all of you. My name is Magnus Hagander. I work for a company called Red Bull Linpro. We're an open source company in Scandinavia. I'm based in Stockholm in Sweden. Myself, I'm part of the Postgres core team. I am one of the committers who, we'll see. I don't think I have a feature of my own in Postgres 17 yet, but you know, it's not too late. And I currently serve as the president of the board of Postgres Europe. But we're here to talk about Postgres 17, right? Who's already using Postgres 17? Okay, good. Who's using it in production? Very good. How's it working out for you? Perfect. So yeah, Postgres 17 is at this point still the upcoming version of Postgres, right? The current latest and greatest that is supposed to be used in production is Postgres 16. Who's on Postgres 16 in production? Okay, let's see. 15? 14? See, so far the numbers are going down. I'm worried when this trend is going to change. 13? 12? 11? Okay, now we're getting into troublesome area. 10? Earlier than 10. Okay, well, I don't need to tell you that you should fix that. You probably know that already. And if it was easy, you would have done it. But yeah, as of today, the latest supported version of Postgres is 12. And the newest supported version of Postgres is 16. 17 is not yet supported, but 17 is the upcoming version, right? And the way that we work in Postgres when we build is that we actually started Postgres 17 in June of last year by branching Postgres 16. Because the way the development works within Postgres is we do all the new feature development against the master branch, and then when we feel it's nice and ready and stable and the new one, we create a branch. In this case, we call it release 16 stable, and that's how you magically make your software stable. Just create a branch name with a stable in its name, and you should be good to go. But jokes aside, what that means is the moment. So in June 2023, we created the branch called release 16 stable, and what that really means is you're not allowed to put any new features onto that branch anymore. It's now bug fixes and maintenance only, and the master branch, the main development branch, gets opened up for building new features and then starting adding the features that will eventually bring us to Postgres 17. Then in Postgres, we work with something that we call commit fests. It's really just our way of doing iterative developments. You can call it whatever you want, but we chose the name commit fests because nobody else had used it, and of course we wanted our own name. But the idea is we spend 1 month building and contributing features to Postgres, then we spend 1 month reviewing and committing them onto the main branch. So the idea here is the first commit fest for Postgres 17 was in July. That would then, in theory, be things built in June, and if it worked all the way through. Then we had another one in September, we had another one in November, we had one in January, and we are currently in the middle of the 5th commit fest, which is for March, which will be the last one. So the way we do it, these 2-month cycles until March, and then we just stop. So at the end of this commit fest 5, which is currently in progress, when that one finishes, that's the feature freeze for version 17. It's a very long commit fest. We're going to get so many features in. Yeah, I probably did. Because I kind of copied that and added 1 to everything. So no, it is March 2024, yes. And I think we're typically setting about a week to 10 days into April is when the official feature freeze for 17 is. building on that, we'll stabilize that and eventually get to a beta version, usually around May-ish. We'll see how many beta versions there will be. We'll see when we get to release candidate. But the general target is to try to get a release out in the September to October timeframe, as usual. As you know, if you've been around Postgres for a while, that's when we usually try to get the new major versions out. But that also means that, as a disclaimer, where we are now today may be completely different from where we are 3 weeks from now. We know that nothing will get added that nobody has submitted yet, but there are hundreds of things in the queue that we don't know which of them are going to make it in. So this will be a preview. And the same thing, of course, right up until release, any of these features can be removed. If it's determined that it's not good enough, it runs into a corner case that cannot reasonably be fixed within the time frame of the release. This has happened a few times around. It happened in the last version that some things were removed after the beta version was out, and then they got removed again. And some of them are back now in 4.17. So the almost current status that we're at, because I think this number is from yesterday, and for some reason there's not a freeze around when I do these presentations, so it's hard to keep up. And I updated this sometime last night, not this morning. But at that point we were looking at, in this case, as you can see, as we all know, these are the best ways to measure developer productivity. We were at 1,600 commits with about 150,000 lines of new code, and about half as much deleted. So what is this then? What kind of features are we? What are we looking for? For those of you who've seen my presentations before, you see I usually divide them into a couple of sections just to have a little areas. We got DBA and admin, we got SQL and developer, backup and replication, and then we'll finish off about talking a little bit about performance, because everybody loves performance. And there, of course, every Postgres version has some interesting stuff. But let's start with breaking changes. Right? What are we breaking for you? Hopefully not that much, but probably something. Actually, I'm willing to say hopefully something. Because if you're not affected by any of this, then you are not doing the things that you should be doing. But probably not the first ones, which is, for example, we have a different way of building Windows builds now. You can no longer use our manual, really ugly, hacked up scripts. You have to use Meson. That's a good thing. We dropped AIX support. Who uses Postgres on AIX? Who has ever used Postgres on AIX? Who has ever used AIX? Okay, there we go. At least something, right? And we've also removed, this is one of those double negations, we've removed the ability to remove thread safety. I don't think anyone turned off thread safety for many, many years. So these things should hopefully not mean that much to you. A couple of other things that you may have been using. The admin pack contrib module is gone. All the functionality in that module already exists in Postgres core. But if you had code or if you had modules that were using it, you just have to change them to use the functionality that's already in Postgres core. Has anyone ever used DB user namespace? It's a configuration parameter that you can turn on. Okay, I'm glad. Basically, the idea behind this one was you could have different users in different databases in the same instance. The minor drawback was you could no longer have encrypted passwords at all. Everything was clear text. So I'm glad you didn't use this. And this is why it has been removed. Did anyone use the Postgres snapshot to old feature? Did you have a good experience with it? Yeah, it had far too many quirks and it didn't really work very well, and it was getting basically unmaintained. So it's gone. Okay, these are things that I was hoping you weren't using. Has anyone ever read from pgstat writer? I hope all of you have done that. Maybe not directly, but maybe with your monitoring tool. So a few things are gone. The columns for checkpoints time, checkpoints requested, write time, sync time, buffers checkpoint backend, buffers backend and backend fsync are all gone from this view. So all your monitoring software will break. Sorry. What it's going to mean, of course, is that you need to upgrade your monitoring software to a version that supports version 17. But most monitoring software will be reading from this view. And it's vastly different in this version. The other thing that I hope is not going to break for you, but it might, is that the search path variable in Postgres is now by default secured in all functions called in maintenance operations. What the hell does that mean? Well, the basic idea is, there are a few other covers, but the simple case is if you have an expression index, right? You have an index on the result of a function. When that function, by default now, when that function is executed, Postgres will reset the search path variable to just contain PG catalog. If you need that function to be able to call other functions that are not in PG catalog, you have to explicitly set the search path on the function. Otherwise, it will stop working, right? Because it will not find the functions. Previous versions of Postgres would use whatever search path you were in, at which point the maintenance operation could become it's very easy to build yourself a security footgun, where you could basically allow code execution as other users by placing things in different schemas and stuff. So the hard code thing here is if you don't do anything, everything will become secure because it will restrict it to PG catalog, and regular user can never put functions in PG catalog. But it also means that if you are using expression index on your own functions that are calling out, you will need to go and explicitly set the search path for them. Hopefully, you were already doing that. In reality, you probably weren't. And now you will. So if you are using, again, expression index on custom functions that call out to other functions, they will likely break. You just need to investigate it. Unless you're doing something really dumb, which you shouldn't be doing, then all you need to do is to do the alter function set search path, and it will work again. But you've just changed what the hard coding value is. So these are basically the breaking changes I've found so far. Let's talk about the new stuff instead, right? You didn't all just come here to, you don't upgrade to 17 just to get things broken, right? A little bit. I mean, some things are actually good. Some of these breaking things are good, but in general, no. So let's start talking about the area of DBA and administration. We'll start with a small one that I think people who are using it are going to like it a lot. Who's using, well, let's start by who's using PSQL. Surprisingly few, actually. Do you know that in PSQL you can do this /watch, which is the same as watch in Unix, like run this query over and over again and show me the result? The new thing here is you can just give it a parameter that says stop when it drops below. So if you run your query and you do this, /watch m equals 2, it'll run until the number of rows returned is less than 2, and then it'll stop. So it's kind of neat if you're polling some sort of a background job. Who's ever done that? Polling, PG stat progress vacuum, put it on the /watch. Vacuum finishes, and then the interesting data starts scrolling off the screen and out of your scroll back buffer before you notice. I've certainly done that. So small things, very useful. Other things that I think are going to be quite useful but are fairly small is there is yet another timeout. We've had many, many timeouts in Postgres. You have statement timeouts and session timeouts and idle in transaction timeout, and now we have a transaction timeout. It's really what it says. If you set transaction timeout to 1 minute, no transaction is allowed to run for more than 1 minute, regardless of what it's doing. Right? A statement timeout applies to the individual query. But this one you can say, 1 minute for a transaction, whether it's 1 million queries or one query, we don't care, stop after 1 minute. The typical user or a typical use case for this can be if you have, you have a classic web app, you got a web request coming in, you're going to time out that web request at some point anyway. And then the queries are going to keep running. But setting a statement timeout for that is really hard because you might have multiple queries, right? Now you can just match up this timeout to set it to, a second or two longer than your web server timeout, and then it'll just clean up the old queries when there is not going to be anyone listening for the result anyway. Right. Excuse me, can you define this on a per user basis? Yes. It's like the other timeout sessions. Yes. Can you change it per session? Yes. You can change it pretty much everywhere. In the same places as the statement timeout. Who's using event triggers in Postgres? Okay, no, not too many. So event triggers are, the triggers that, normal triggers trigger based on data. Event triggers based on, events. But you can have them fire on things like create table. You can have them fire on DDL and log it or prevent it and things. And at the simplest, you can now also, you can create a trigger whenever reindex runs and make things happen. And the more debated one is you can also have a login event trigger, which means you can now get a trigger that runs when a user logins to the system. Or, as we like to call it, a footgun extraordinaire. You need to be very careful if you write one of these, because if your event trigger crashes, for example, nobody can log into your database, including you. So you can no longer fix your event trigger. So yeah, I mean, actually you can, because you can also now, there is a global parameter where you can just globally turn off all event triggers so that you can get in and fix your login event trigger. But yeah, it is. You can do classic things like if the event trigger writes anything, nobody will ever be able to log into one of your standbys again. Because the event trigger runs, it tries to write. You can't write anything on a standby, so it crashes. So you can do very good things with login event triggers, and you can do very bad things. It is a big foot gun, but if it's used right, it can be very powerful. You can get connection auditing at a level that the built-in one isn't enough. You can add policies of who can do what, who can log into what, assigning roles at login. There's a whole bunch of things you can do, but be very, very careful. Because again, something goes wrong, and it goes wrong for real. And you're stuck. Hopefully everybody by now has learned the idea of wait events. If you went to Jeremy's talk yesterday, he did a good example of why you should be looking at your wait events. They've been around in Postgres since version 10. We renamed all of them a couple of versions ago just to confuse you. And now, we renamed them then, but only now did we actually create a new view called PG wait events that will actually tell you what they are. So when we rename them the next time, you can find them. But no, so basically you now have a view that's called PG wait event. It really is the event type, the name, and a small description so that you can find it obviously for the version that you're in. And one other important reason for this one is that wait events can now also get custom wait events for extensions. Previously, there was a single wait event for extensions that just said it's waiting on an extension. But as of 17, an extension can register their own wait events, which will then show up in this PG wait events, so that you can see what it's waiting for inside of the extension as well. Another thing that I always like about Postgres, we had someone mentioned, was it in the AMA yesterday, that the statistics features, always good new statistics features in Postgres. We try to bring them to every version. We have new interesting parts to the statistics system in version 17 as well. Well, I'll just bring this one right back. We also broke this, as I just mentioned, right? We removed a whole bunch of columns from PGStat BG writer. When you think about it, none of these statistics are actually about the background writer, and that's why they were removed. Instead, we have a PGStat checkpointer and we put them back. So it's not that we took the numbers away, we just moved them so you can't find them. But the other more important part is, as you can see in this example here, you've got these numbers of times and requested and your times, and you see restart points now get separate statistics. Restart points, in simplified, being the checkpoints that run on a standby or the checkpoint that run during startup. How many of those are happening, and splitting those apart into different values. So the old value is BG writer. Background writer statistics are still in the BG writer view, and checkpointer statistics have basically been moved over to PGStat checkpointer. So again, if you have monitoring tools that are using these, then that's the way to go. Most of the other things that were removed here, these buffers, are moved into the PGStat IO view, where they were added in 16, but they were just not removed from the BG writer view at the time. We have some additions to PGStat statements, which I'm hoping you're all using PGStat statements or have a really good reason not to. One of them is that you can get the local block IO statistics per query, so the local cache in the backend, like temp tables and stuff. We didn't have the I/O timing for it. Well, now you have those, local block read time and write time. And you get the entry time when a query was first recorded by PGStat statements in its current entry. So the first time will go in the stats since. Now this can be a query, as you know, PGStat statement tracks a certain amount of statements, or a certain number of statements. and a query might leave the statistics and come back, right? Because it's no longer in the top 5,000 or whatever you have, and it will have the same query ID, but it will then get a new statistics since at that point the statistics are lost. There is also a min-max stats since that's related to the fact that you can now choose to reset all the statistics for a query except for the minimum and maximum times. So you keep the minimum and maximum times separate from the other statistics, and at that point these two numbers can go to different values. If you're not explicitly doing this reset yourself at different times, they will always end up showing the same thing. The query jumbling, as it's called in pgstat statements, now properly normalizes call. So if you're using actual stored procedures in previous versions, if you called in this, you can see I didn't have a stored procedure in my test database, so it's just dummy. But basically now it can identify that the parameters are actually parameters and normalize them to $1, $2. Whereas in previous versions, it would see every call statement as a different statement when it had different parameters. Which can be very annoying because it can rapidly explode and be like half of your pgstat statements are just different versions of a call statement. Pgstat vacuum progress now shows index progresses. So when you are vacuuming a table, it will not tell you within the individual index how far along it is, but it will tell you, so in this case here I have 5 indexes, 3 are done. So it basically takes the phase of vacuuming indexes and gives us some more detail as it's running to give you a little bit of a clue how much longer you're going to have to wait. Because usually when you're at the point of looking into this, you are waiting, right? It was slow enough that you felt the need to look at it. So that can be a nice further input into that one. Okay, leaving statistics. Let's talk about copy. Who's ever seen an error somewhat like this? It goes off, but I copied my little dummy table from a test file in CSV, and it goes down and it's like, boom, invalid input syntax for integer. Now, usually it's not on line 2, right? Usually you've loaded a few million lines and then it happens. So copy in version 17 has gained the ability to direct and act on errors. What you can say here is you can say, see here, copy dummy from format CSV on error ignore. And as I copy it now, it just says 1 row was skipped due to data type incompatibility, for example. Now in 17, the only on error operation supported is ignore. But the idea in the future is to be able to do on error log or on error write it to a different table that where every column might be text or like to allow you to proceed through it. In this version, all we can do is just ignore it, but depending on what your data is, that's a good start. But the goal coming, hopefully then in Postgres 18, is to be able to actually send the incompatible data somewhere. Sorry? Sorry, it will be? Any error, yes. Yes, or any error that's based on the source data. If you run out of disk space, it's you're screwed. But like wrong number of columns or batting, yeah, all error or of that type, it will be able to ignore. Yes, Jamie. If one line breaks the rest of the file, I think that that is in the end going to end up how it breaks it. Like if you get like a runaway quoted string or something, all bets are off. Then you're probably just going to fall into a different error later, and yeah. So it'll depend on exactly how. If it's single line CSV, one line tends to not break the next one, except possibly for the quoting errors, and yeah, they're going to go weird whatever we do. Yes. No indication of which line, no. Because the idea would be, then you'd have to log like every one of them, and there might be millions of entries. That would be in this upcoming ability to say for each line log, which we don't have at this point. Okay, speaking of things that were in Postgres 16 and then they were not in Postgres 16 and now they're back. A new permission that is called the maintenance permission. You can grant this to allow somebody who's not the table owner to be able to do things like vacuum, analyze cluster, reindex, refresh materialize view, unlock table. Why was this removed in Postgres 16? It was removed because we did not have this feature to secure the search path for expressional indexes. And in that case, this could have been used to gain higher privileges in the database and to be exploited as a security issue. Therefore, it was removed, the search path lock-in was properly put in, and then it was put back in now that it can be done in a safe way. And this one works similar, like you can grant maintain on a table to a user, then they will get this permission on the individual table, or you can grant this new role called PG maintain to a user, and then they will get the maintenance permission on every table. So you can create a special user that can run all those lovely vacuums for you. Who loves dealing with locales? Okay, cool. Let's add another one. It's not actually another one, but Postgres 17 will come with a built-in locale provider. So you know, previous versions of Postgres for a few years at least have had the libc provider and the ICU provider, and now we have a built-in one. So you get a little bit more to choose from. This is only for the C locale for now, so Postgres will just bring its own version of handling the C locale. It is faster than using ICU, it is faster than using glibc. The most important part is that it is stable, or at least if it's broken, then we broke it. And then we can fix it within Postgres. It does not, for those of you who don't know, the C locale is the one that basically is not a locale, right? It doesn't sort things correct, but it does sort things consistently. And a lot of the time that's enough, right? If you're just indexing and text string and you're looking it up by equals lookups, it doesn't matter which order it's in the index as long as it's consistent. And that's exactly the problem with particular glibc locales, is that they're not necessarily consistent. Who has been hit by the locale problems in the glibc upgrades? I feel your pain, I've done it too. Who has never heard of the locale issues around glibc upgrades? That's very few people who haven't heard about it. Who thinks they're not affected by these? Okay, it's almost a trick question. If you think you're not affected by them, or if you've never heard of them, you should really go to Joe Conway's talk that's right after lunch here. He will talk about the problems in detail that these hold. The built-in locale provider is not a fix, like a perfect fix for this. It's a step on the way. It's infrastructure, but it can be used already right now. Okay, let's move on, take a look at some of the more SQL exposed things and maybe a little bit more developer oriented. The things that everyone's always been waiting for, right? You can now actually convert things to binary and octal. Sweet, isn't it? I think it was 16 that we added the ability to actually specify literals in binary and octal, but there was no way to go the other way. Well, now there is. Very simple, but still useful. If you are dealing with timestamps and intervals, we can now have infinite intervals. This was a little bit weird because we could have infinite timestamps, but not infinite differences between two timestamps. So if you were to compare two timestamps and one was infinite, you would get an error. Now, if you do that, like if you did this, infinity minus now, you now actually get infinity. That's, you know, it's kind of obvious and it's kind of annoying if it crashes when you do that. So simple addition that just plugs a bunch of holes where previously you had to manually do a case when x is equals infinity, then return this, else return that. If you're using partition tables, identity columns now work properly, as we'll say. It has to do with like when you attach and detach tables, you could get into some weird positions with identity columns that you don't anymore. Postgres 17 will support what is officially known as temporal primary keys and unique constraints. This is again one of those things that doesn't technically add any new features to Postgres, but this is part of the SQL standard, and it's a way to deal with, and in the SQL standard it's called temporal keys. Basically it allows you in this case to create a primary key which has to have an first a column that is not temporal, and then you can say valid without overlaps, where valid is a range type. Now in the SQL standard, they talk about periods, which is basically a range type for time, or timestamps, and they don't support the other kind of range types. In Postgres, this will support all of our range types, but you still have to have one column that is not a range type in it. And under the hood, this will create an exclusion constraint. Right? And Postgres had exclusion constraints for ranges for a long time, but we couldn't use them as an official primary key, and we couldn't declare them as a unique constraint because they would be an exclusion constraint. So this is sort of a subset of exclusion constraints that can be declared as this, which will be SQL standard compatible, and therefore it'll work in like when you're populating IDEs and data types and things in applications out of it. Yes? Oh, I didn't do this. Somebody else will do this. Yep, we'll see. We're slowly moving towards this, so piece by piece. Yes? So yeah, so this part only gives us the key, the ability to use this as a primary and unique key. The SQL standard also has the ability we can say, select this as of a certain time. We don't have that syntax yet. So today, if you just query it by ID today, you will get all the rows back and look at it. So in reality, you need to also do the where clause on the validity time. How many cookies are needed to fix this? Yeah. Yeah. So yeah. It is progress is ongoing. There are patches out there for the actual code to do as of time. They're not done yet. But 18 or 19, hopefully they're actively being developed. Yes. Time travel was in Postgres and we took it out. The problem with that was that time travel in Postgres was not optional and it was ridiculously slow. But yes, some of the things that you are doing in these temporal parts of SQL really, they're solving the same problem that Postgres and Illustra did back in those days, yes. Okay, moving on. There is now a new function in libpq called pq change password. I bet most of you aren't really using libpq, but again, this becomes infrastructure that can be used by most other drivers that are sitting on top of it. This functionality used to be in PSQL. In PSQL in the client, it's now moved into the driver, which will then hopefully make it available to the other ones. What it will do is it will make you stop putting alter user set password or create user password and put the password that will then drop out in log files and things like that. This is the equivalent of the \password function in PSQL, which will encrypt the passwords properly, and so that what goes in your log files is not a clear text password. So again, we'll have to wait a little bit to see this bubble up into the next layer drivers, but at least now they're available to do that and avoid leaking too much of the passwords into the log files. Now, obviously, leaking the passwords into the log files is only a small part of the problem. You still need to treat your Postgres log files as security-sensitive data, because there can be a lot of other security-sensitive stuff that ends up in the log file at some point. Certainly at the application level, security-sensitive stuff. The JSON path support in Postgres has been substantial. I'll temporarily use this one. There we go. So yeah, JSON path has gained a whole bunch of new operators, which mostly are, I say converting between and then put data types within double quotes, because really JSON doesn't really have data types. You can convert between timestamps and things inside of JSON path. Like you can convert to strings, you can turn a string into a Boolean and things to be used in the JSON path query language inside of it as well. So again, there is no sort of really revolutionary JSON path functionality. It's just chipping away at the small missing parts to gain full compatibility and to give you the full power of the JSON path language. Okay, that's me. Oh, well, it was someone. Okay. Let's talk backup and replication. Well, everybody loves replication, everybody hates backups, right? I think that's the usual. We've got a fair amount of good stuff in both of these cases that I think are quite exciting. First of all, I start with pgdump because it's neither backups nor replication. But it is dumps and they're still useful. Right? The new thing in pgdump is you can now specify a list of what you want to do in a file instead of in a massively long command line. So in this example here, I say, include table foo, include table bar, include with a wildcard in a schema, but exclude the data for this particular table, making it just a schema dump. Like, you could do all of this on the pgdump command line before, but once you start adding a few number of tables here, that becomes very, very unmaintainable. So it's useful in that way, and you just add filter. Okay, I'm going to switch back to the other microphone. There we go. Yes, still works. New batteries, we're back at it. It's like one of those, the Formula One pit stops, right? It's about the same thing. So as I said, pgdump, great tool, not backups. What is a good backup tool? PG-based backup is a pretty good backup tool, right? At least if you can live with the limitations that it has. One of the limitations it's had is that it can only do full backups. Well, no more. PG-based backup in 17 can do incremental based backups. Yes? So I agree wholeheartedly that our documentation should not say that pgdump is a backup tool, but I will continue to fight this windmill. It's a hard fight. Everyone don't agree. They're wrong. So PG-based backup now can do incremental backup. What does this mean? Well, it will back up, compared to the previous backup, only those disk blocks that are changed. Which hopefully means that your backups will be much smaller. I mean, that's the idea. If the entirety of your database gets changed between two backups, there is no point in using an incremental backup. Then you should just use a regular full backup. Now, the way that this works in PG-based backups, you've already known, if anyone in here is using PG Backrest, you've been able to do incremental backups in PG Backrest for many years. And they were used to be at the granularity of a gigabyte file. And then they added block level incremental backups a couple of years back. But still, the PG Backrest way of doing it is it reads the whole files and basically compares the checksums to figure out what has changed. PG-based backup has a new process in Postgres called a WAL summarizer, which you have to turn on. You say summarize WAL equals on. It'll start another background process that basically listens to the transaction log, the WAL process, and picks out of it and say, oh, this block has changed, oh, this block has changed, oh, this block has changed, and generates summarizer files that PG-based backup can then use and say, okay, well, from this to this, here is a list of all the blocks that have changed, because you can get that information from the WAL, and then it will back up those specific blocks. So the difference can be said that when you run the actual incremental backup with PG-based backup, it's faster, it uses a lot less power of your machine because it doesn't have to read all the data. Instead, you have this WAL summarizer that runs all the time that costs you a little bit of performance all the time versus more performance at the one time. Which one's going to be the best? I have no idea. We need a lot of more real-world experience before we can figure out exactly which one's going to be right and wrong. I'm pretty sure it's going to depend on the scenario, right? In some scenarios, the backrest method's going to be faster. In some scenarios, this one's going to be faster. Then you can set a parameter called WAL summary keep time, which tells basically this WAL summary, so how much data should I keep around? Default is 10 days. That means you can do incremental backups going back for 10 days. So for example, if you do a full backup once a day, you can do incremental every day, and you're fine with 10 days. But if you do a full backup every 2 weeks, you don't leave this at 10 days or you will have no backups. Yes? Yes, yes. PG-based backup is always a binary backup. And that's one of the reasons, like you couldn't do this on a logical dump. It has to be on the binary backups. And the idea here, of course, when you then, so you run your first backup, you just run a regular base backup, PG-based backup, give a directory. When you then run your second one, you run PG-based backup, and you say -- incremental equals, and you point to the backup manifest of your previous backup. So if you point it back to the full backup, it will back up all the differences since the full backup. You can also point it to your previous incremental backup, at which point you'll get a chain of incremental backups that will work. And then in the rest, you just tell it to, okay, write this one over here, and it will read the manifest, get the wall data out of that, go talk to the wall summarizer, and figure out which blocks have been changed in between them. Now to restore this, when you restore a general PG-based backup, right, it's very easy, you just copy the files back and you're done. That obviously doesn't work when you're doing them incremental. So for this, there's a new tool called PG Combine Backup, where you just say, you know, PG Combine Backup into this directory, use the full backup and then the incremental backup. Then what goes here in the combined will be exactly what it would have looked like if the incremental backup had been a full one. Like it'll put them all together. And if you have multiple ones, you can just add them, like a whole bunch of, you can have a long chain of things. If you had incremental every day, you want to back up to Thursday, well, you start from the full and then Monday incremental, Tuesday incremental, and etc. And it will go through them all and generate one output that is then the one that you just restore as you did a full backup directly. Yes. Yes. Can you restore them directly? Yes, you can point PG, like you can combine the, this /backup/combine could be, you know, your var-lib PGSQL data, if you have cleaned it out first, or if you're restoring it to a brand new somewhere. Yes. So if a block has been, like if the block is in both the full and both of the incrementals, for example, will it be written more than once? I don't know. I would guess it's probably written more than once. But so I think what it is, if it's, so in this while summarizer, it will get written, it'll get written multiple times, but it generates basically a bitmap where it's only listed once. Because, so it's only listed once there, but if it's in, I don't think the combined backup tool is smart enough, because it would potentially need a very large amount of memory to keep track of that. So I think this one will just write it multiple times. But I am not certain. So, yes. Yep. So yeah, so the wall summarizer is only needed to take the incremental backup, not to restore it. So when you're running this backup command, if I'm pointing this to the full backup, then I need the wall summarizer to cover the time back there. But if I had this scenario, then when I took this incremental backup, that would point to the full backup. But this incremental backup points to this backup. So at that point, when this one is taken, the wall summarizer only needs to have the data back to here. And then it will follow the chain across in the restore. Yes? To start from a new full backup, I believe you need a new base backup to like start a new, completely new chain. But you can have you know, there's no limit on how long your chain can be. Only, of course, it will take longer to restore the more you have changes in there. Yes. Yeah, exactly. I think also the question was, can you use the combined as a full backup? I don't think you can, but again, I'm not sure. It might be possible, but I don't think you can at this point. Okay, so let's leave backups. This is, I mean, pgdump is not backups, some people think it is. Replication is definitely not that. What about upgrades? They're somewhere in between, but there are some interesting things. Postgres 17 will be able to preserve subscriptions fully across upgrades. So when you PG upgrade today, all your logical replication subscriptions go boom, and you have to start over. You will no longer have to do that. You will be able to upgrade without rebuilding your subscribers. That's kind of neat, right? Of course, you will only be able to upgrade from version 17 because it's required on that side as well. But we like to prepare for the future. For now, you're still in the you need a new node that runs version 17 and logically replicate into this node. But this is one of those things. Another classic issue with the logical replication is when you're combining logical and physical replication, right? You have a high availability cluster for something that publishes logical replication, it fails over and now everything breaks. To do that, Postgres 17 adds replication slot synchronization between the nodes. It basically means between physical replicas, you can synchronize your logical replication slots. So today, your the source of your replication publication really is an individual node. But with this, you can conceptually make it your HA cluster can be. Now, to do that, you need multiple different things. You need to enable something called failover on each replication slot. That's either done when you're manually doing pgcreate logical replication slot, if you might be using this for something that is not Postgres on the receiver side, or when you say create subscription, you just give it the flag failover on. Then you need to enable sync replication slots on all of your standbys so that they will be receiving this data. And then you need to configure standby slot names on the system as well, because that's for Postgres to know that it has to wait for these synchronous workers that run on the standbys to get the data before it's allowed to invalidate the data out of the slot. Otherwise, the problem would be if your logical replication runs faster than your physical replication, and then you failed over, you would be broken again. Now, usually logical replication does not run faster than physical replication, but you could have a temporary hiccup on the network to one of your standbys or something. So you do need to set all of these, and what will happen in practice is that this, the sync replication slots, when you turn this on, it'll start an extra background worker that will just periodically synchronize the state of these so that when you do a failover, your subscribers can just connect to the new primary, and what data they needed will still be there. Okay, let's talk a little bit about performance. We all love performance. Postgres is almost always faster in the newer version. You will always be able to find something that's slower. But as a general rule, there are a lot of infrastructure features that are really interesting to Postgres hackers, giving access to new types of structures for arranging tables internally in memory and things like that. We don't necessarily care about those as an end user. To an end user, to us, it just looks like things are running faster. And that's great. We love it. Singling out a couple of specific ones, copy can be made significantly faster. I think the numbers, so one interesting one is specifically if you're copying data out, there's a function called UUID out that's called every time you write a UUID out as string. And if you have the specific case of a single table with just an UUID column and everything's in cache and you copy it out, it's now 60% faster. Like that's a non-trivial speed up. And obviously you don't have quite that ideal case in reality, but it will be much faster. And also simple things like if you're actually using copy2, Postgres would actually convert the encoding from itself to itself. If the codings were the same, it didn't realize that they were different. It does now. So copy2 in encoding cases will also just simply be faster. Some of the more advanced things that are getting in there is something called self-join removal, which basically means if you run a query where you join a table to itself on, say, the primary key in the simplest case, and you just query one column from each of those two tables, that join is completely unnecessary, right? Because you can just read both columns without joining in the table. And Postgres will now detect a lot of cases where this happens and just remove the join and get the column from the one scan of the table instead. This is, I mean, you can look at it and go like, the answer for a long time has been, well, just fix your query. Like, don't do that stupid join, right? But a lot of us are stuck in cases where we have automatically generated queries. They are ORM queries or reporting system-generated queries. And now Postgres will just detect this, remove the join, and it'll run faster. Another thing that I think, and I was looking, I was even surprised myself. I was going through the commit messages, and I read this, and I found what I think is the best part of this feature in like the 4th paragraph in the commit message, sort of a side note thing. And this is, Postgres will now deal with redundant not null calls, as it's called, much more efficiently. So just setting the stage here, if I create a table here, I have a single column, it's not null, I insert 1,000 values, right? Whichever I do there. If I run this query on that in Postgres 16, explain select star from foo where A is null, right? Oh, sorry, where A is not null. That's kind of we know that A is not null. It's defined, right? Here's how Postgres 16 will run this query. And I also realized this is a different test data because that was 1,000 rows and this was run with 10,000 rows, but it works the same way. Now, if I run this one on Postgres 17, it runs like that. That's a pretty simple thing, right? We no longer need this filter. No, it's gone. We can just scan the table. We know that every row will match. Now, this is not actually the part of this one that I find cool, but this is the part that's, the headline feature for this. What if we run the query like this? Select star from foo where A is null. There is a not null constraint on this table. How does Postgres run this in Postgres version 16? Well, it runs a sequential scan across the table, filter A is null. How does Postgres 17 run this query? One-time filter false result. Again, auto-generated queries often don't realize this. In fairness, my queries might also very well include things like this every now and then. But I've seen it many times coming out of systems that are auto-generated queries of an ORM system where it literally does an is-null query where we know that can't happen. And now we'll just detect it and not run it. So I actually think this is the more important part than this. But, they're both good, obviously, and avoiding any work that we can avoid based on the fact that we have declarative constraints. And again, this is yet another reason that you should remember to put those pesky not null constraints on your columns. Not only because once you get nulls in there, everything bugs out when you didn't expect it, it will also run faster. That's an easier sell. Most versions of Postgres include some enhancements to the parallelism. It's not too much around the parallelism in 17, but you can now create index can now be parallelized for Brin indexes. Previously, if you were creating in a Brin index, it would only use one CPU. Now it works the same way as B-tree, where it'll use maximum parallel maintenance workers, number of workers, to create Brin indexes as well. The SLRU caches, does anyone know what SLRU caches are in Postgres? Okay, a couple of people, pretty much all of them are Postgres hackers. And you know what they are? Do you also know what they mean? It's actually, that part is much simpler. It simply means simple LRU, so simple least recently used cache. They're just like separated special caches. The thing is, there's been like one, and now they're all divided up into separate cache banks. That's not supposed to be an either. They're just divide cache in banks with separate lockings, and you can now configure each one of these separate SLRU caches to a different size, if you need to. And these are things like multi-exacs in Postgres, transaction ID caches. These like very low-level caches can be configured individually. This is the same. We already had something called pgstat SLRU, which will tell you things like the cache hit ratio across the different parts of it, but you couldn't actually control it before. And now in 17, you will be able to override the defaults for these cache sizes and control them specifically. Now, obviously, like most of those things, most of you are probably not going to have to do that, but particularly on like really heavily loaded system with high concurrencies, increasing some of these caches is going to make potentially a substantial difference around the things we're doing. So that's the list of things that I am planning to go through. There's obviously always more, and specifically now that we're only about halfway through the final commit fest, There will be more things. There are more things already now that I just decided not to include because, again, what was it, 16, thousands of commits. There will definitely be more. There are many, many smaller things. There are performance improvements all over the place. There's no way to go through them all. But this is also the perfect time for you to help out. Right? We haven't released it yet. We haven't even put the beta out there yet. But you can actually get both RPM and YUM and apt packages of the snapshot versions. You can put them on your systems and you can run them. Maybe not in production. I mean, you can. I wouldn't recommend it. But like, if you have testing systems, if you have automated tests, please throw Postgres 17 at them and see what happens. Let us know if something broke. Do you have performance tests for your applications? Run them against Postgres 17. Hopefully everything will be faster. Maybe it won't. If you can let us know that now rather than after the release, the likelihood of this getting fixed before the release increases drastically. So please do download these, help us run these tests. Let us know how it works out. Yes? Yes, I believe these packages are assert enabled. Devrim says yes for the RPMs. Do you know if that's true for the Debian packages as well? Okay. It's difficult to compare performance straight up between them in that case, yes. That is true. But yeah, and you can compare plans, and you can certainly compare the fact that things work, that your data comes back the right way. But yes, that is a very good point, that from a performance perspective, they're not compiled with exactly the same switches as the production builds. So you can't do a direct comparison between those. So yeah, please do grab us those, help us out with the testing, help us out reporting what works and what doesn't work. You are the ones who have the real world applications. Our tests are mostly done on synthetic workloads. We need to see this with real workloads. And once you've done that, hopefully we will have a Postgres 17 ready for you after summer. With that, I thank you very much. I think we're all running out. We're all running out to get to lunch. I guess I have about 2 more minutes if we have any questions for now. And if not, you can always catch me in the hallways later. Anyone? Okay, then off to lunch it is. Thank you.
Okay, testing, 1, 2, 3. My name is Joe. I'm here to give a talk. Hope you guys like it. I don't know what else to say. You like tune this like to adjust it for the timbre of my voice? Is that?
Thank you. Test 1, 2, test 1, 2. That's a little bit on the quiet side, so I'm going to bump it up just a touch more.
All right, testing, 1, 2. Testing, 1, 2. Should someone go to the back of the room and see? Testing, 1, 2, testing. Hello, hello. I mean, I can bring the mic closer, but it's more comfortable right about here. Yeah, so you want to hold it straight on from like that. Okay, testing, 1, 2. Testing, 1, 2. All right. Yeah.
Test 1, 2, test 1, 2. Yeah, this sounds about right. So.
I mean, I can talk loud. I could probably talk to this room without the mic, except I know you're recording.
I would go ahead and talk like that with the mic, because that'll come in about perfect, because that's what I'm doing.
Okay. All right, testing, 1, 2. My name is Joe, and I'm here to talk. Yeah, that's not bad.
Cool. Let's do the other microphone real quick.
You want me to turn this one off?
All right. How does this sound? I'm not really coming through the audio, but I can crank this one up a bit too. And let's see, where are we at? This one's at 0 dB, so I want to go up by maybe test 1, 2. There we go. That should be about right. Can y'all hear me? Yeah, I can hear that just slight echo in the room, which tells me I've got a good level. Because when you pack people in here, they'll deaden some of the sound. Sound good? Cool. All right. Say again?
Now you can just warm the temperature up. It's free. I wasn't here yesterday. I was shivering.
Is that feedback? No, that was just me futzing with the bone. The hiss is in the back of the room. That hiss is not the.
Another one gone, another one gone, another one bites the dust. Boom, boom, boom. Another one bites the dust.
too many people just. I know, I got a full hour in this talk. I normally can finish in about 15 minutes.
Let's suggest 2 minutes for you. Okay. Okay.
So if you are seeing the back, I would urge you to come forward because the fonts are small in the presentation, so you can see. I mean, the more you are close to the phone, it's going to be really clear. And I won't bite, I promise. We're going to wait a couple extra minutes for people to show up after lunch, hopefully. We get a few more. Devram, can you hear me back there? Is it all right? Is it kind of low? I have to hold this closer? Yeah, I'll talk louder. We're just giving people another couple of minutes to get back from lunch. At least I remembered my jacket. Otherwise, you'd hear my teeth clinking as I was talking. All right, you want me to talk louder, I know. Just give me a sign, Devram. All right? All right, I guess we're going to get started. So I'm Joe Conway. I've been around the Postgres community since the late 1990s. I've been a committer since like 2003. If you've ever used set returning functions, that was a feature I added long, long ago. I wrote dblink, a bunch of other stuff. Most of the big stuff I did was years ago. Mostly these days, I kind of manage people, so I do less coding. But I still fix bugs here and there and do a feature here and there. I am also on the sysadmin team for the project and the security team for the project and the team that recognizes contributors, among other things. And I am, as I mentioned, I'm a manager at Amazon. I run the team that does the upstream Postgres contribution. So our team is all about contributing to the project. And this is where you can get a hold of me. I'll have that on the last slide as well, and I'll make the slides available somewhere. I'm not sure how SCaLE does it. I can't remember. Okay, so we're here to talk about the problem with glibc collations. How many people are aware of the fact that there's a problem? Wow, I expected like all of you since you're here, but I'm gonna show you some examples about that make it obvious that this is a problem. I think it's a bigger problem than most people recognize. I'm gonna show you, if you run into it, what you would have to do to fix it. And then at the end of the talk, I'm gonna talk about an alternative approach that I developed, and it's been in use now for well over a year. I can't say exactly how many instances it's running on, but it's on quite a few. Okay, so we'll start out if you're on a RHEL 7 system, right? And I mean, is everyone here familiar with the basic syntax of setting up a Postgres database, initdb, and then PG control start, right? And then I'm into Postgres. So that's all I did was just build a new database on a RHEL 7 machine. And this query here is going to just show us information about the encoding that the database is using. The encoding and the collation, I should say. And so you can see that the collation it's using on a RHEL 7 machine is 2.17, and that's because on a RHEL 7 machine, glibc is 2.17-326. At least the last time I checked, it was 326. Might be something newer now. And if you do the same thing, excuse me, on a RHEL 9 machine, you'll see that you've got glibc 2.34. So you say, oh, no problem, that's just like a minor version change, right? Well, no, actually, the way that glibc does their versioning, each of 2.17, 2.18, 2.19, each one of those would be a major version change. And typically for a given distribution, they'll freeze that major version. So that's why RHEL 7.9 still has 2.17, but the -326 means like 326 versions of that package have been released. I'm going to get into that later on, why that's important, but suffice it to say, as you change your OS version, you're going to get a new glibc version, major version. All right, so this is what I call the in-your-face slide. For anyone who wasn't aware there wasn't a problem, or anyone who thought, well, maybe there's a problem, but I probably won't be affected because I don't do anything fancy, right? Well, you can't get much simpler than this, right? We've got 3 values, 1-A, 1A, and 1-AA. And on a RHEL 7 machine, if you sort those, you're going to get this order: 1A, 1-A, 1-AA. On a RHEL 9 machine, you're going to get this order: 1-A, 1A, 1-AA. Okay, so if you thought this was like an esoteric problem that you probably won't run into because you just do simple stuff, you may not be simple enough. Maybe you are, but maybe not. You can be just using the ASCII characters and run into this problem. And remember, I just basically built the database with all the defaults, right, when I did initdb. So I got EN, US, UTF-8 because that's what my system is, and that's what Postgres will pick up. All right, so we're going to drill in a little bit deeper now. Is there any question about that before I go on? Okay. Hopefully I've got you beginning to get scared. All right, so we're going to start out by creating a table on RHEL 7. And so it's, one column table with a text column. I'm going to make it a primary key. That's important for the purposes of this demonstration. I'm going to insert those 3 same values into that, and then I just do a select order by from that table, and I get that same order we just saw, right? No big surprise there. So now if I take that machine and upgrade it to RHEL 9 underneath my database, now this could happen in a number of ways, right? But you may not, as the person responsible for the database, you may not even have a choice, right? Someone else may decide that for you. One of the things you should notice, though, is when I first start up the database, if I immediately do that same select order by, I get the same order. So you look at that and you say, well, what's wrong? This is working perfectly. There's nothing wrong with my database. And so now the next thing you do is you go insert another row. Except, remember, I had a primary key on this column, and I'm inserting another row with the same value that I already had. That should be an error. But guess what? It succeeds. So now, not only am I getting sorting in the wrong order, but I have a corrupted table. And if I try and re-index that table to fix this problem, That's going to fail now because I'm trying to re-index a unique index with my primary key. So that's not going to work. So this is just the very simplest scenario, and already you can see how it can bite you. So I'm going to go back to this query that we used earlier, and you can see this part here where it does PG database collation actual version. This function will actually look, basically it uses the libc call to say what version am I, right? And it shows you that. And so you can see that, you know, we were built on 2.17. What's on the system now is 2.34. That kind of explains why we're in this hot water now. All right, so what if I got to get out of this mess? Well, first thing I'm going to do is actually drop my primary key. And then how many people are familiar with the CTID column? Just a few? So the CTID is a system column. It's not normally shown if you do select star from some table, but it's basically a physical row identifier. And what I'm going to do is use that to show me, to disambiguate these two rows so I can pick one to delete. Now, had this been a more complicated table with more columns, and if one of the columns was different across those two row versions, you got to figure out which one to keep. So you're still, you know, it's not clean. You're going to have a problem. So the lesson here is one of the things you got to be careful about is not only these glibc versions, but if you're going to rebuild all your indexes, which is what we're going to do to get ourselves out of this, you really have to do that before you let anyone into your database after the OS upgrade. You cannot let anyone insert, update, or delete before you rebuild those indexes, or you're going to wind up with a problem. Or I shouldn't say you will, but I should say you very well might. So you can see here I deleted the second one just because CTID larger indicates it's probably the newer one, that it was inserted in error. Although if you're familiar with the term wraparound in Postgres, if Postgres wraps around the transactions wraparound, if you've heard of that, it's possible that the newer CTID could actually be the older row. So you can't necessarily count on that either. But in any case, you'll have to figure out one of them and get rid of it if you want to rebuild that. You want to rebuild that, re-add the primary key, which will rebuild that unique index. And then if you do this alter database, refresh collation version, what that will do is it'll go update the system catalog to say, all right, now we recognize that we're running with the newer version of glibc. It actually, that doesn't fix anything for you. It just like updates the catalog to say that's what I'm doing. So in fact, you could run this and still have corrupt indexes, and it would look like, you know, you're using the newer version of glibc, but you wouldn't actually have fixed anything yet. So now once I've done all that, if I run my order by, select order by again, now I'm finally seeing the order that I would have expected on rel 9 for those three values. And if I go back to my query to look at the system table, I can see that my dat call version matches whatever the actual on the system, now that I've done the refresh. Okay, so now we're going to take it up a notch. This is something I call the collation torture test. Jeremy Schneider, who's back here, created a GitHub repo which produces, so let's see, I've got this right here. Oops, sorry. Did it again. This repository that he created basically generates roughly 26 million strings that are in the like 1 to 5 or 6 character length, but they're all like these crazy Unicode characters. And he built that, as I understand it. Jeremy has got a lot of experience dealing with customers who have done strange things. So he's seen a lot. And so he's got some good intuition as to what sorts of things might cause problems with these collations changing from version to version of glibc. And so he kind of built this test. There's no way to exhaustively test every possibility, but this tests a lot of stuff, right? And this test is not a database test. It just produces basically a file of strings, and he did a bunch of across different OSs, and you can look through his README, and it's got some interesting data in and of itself. But what I did was I took that, the data from that, and I just used a little Python magic to properly double up the double quotes that were in those strings, and then put double quotes around them so it was easy to suck it into a Postgres table. And so, getting back to the slides, if I create this table, unsorted table, just one column again, and I'm going to bulk copy that formatted Unicode text, which is his output with my quotes. And then I do a vacuum freeze. Whenever you bulk load, you really should vacuum freeze afterwards for a lot of good reasons, but that's like unrelated to this talk. And now this query here, which I'll use repeatedly, is basically doing an order by all of the strings in that table, and then doing a string ag with no delimiter, so it basically just jams them all together into one long string, and then calculates an MD5 over it. So you can consider that like a signature or a fingerprint for our sort, right? So if that value is the same, we know that the sorting is the same of these 26 million crazy strings. Now, keep in mind as we go through the talk, this 7E130, that's the kind of the signature we're looking for. And I also want you to notice this timing here. This was about 3 minutes to do this sort. In a few slides, you're going to see why I wanted to point that out. And I'll talk about that in a little bit more depth later on. But there's links in here for Jeremy's GitHub, as well as the formatted text that I pulled into my table is available online as well if you wanted to play with this. Okay, so now I'm going to build an indexed version of that table. So basically I'm just doing an insert into a new table from the unsorted table, and I'm going to create an index on it. And you can see when I do that same select, again, I get the 7E130, so it's the same order. And you can see now it's like 3 seconds. So really fast, it used the index. And by now, everything was cached. Okay, there's an extension that comes with Postgres called amcheck. One of the functions available in amcheck will let you check the validity of an index at a very low level. I think that some of those functions were written by Peter Gagan, I think, for the index checking part of it. Most of them, yeah. So Peter Gagan is also on our team at Amazon. Spends a lot of time with his head like way down deep in the index code. So when you run those checks against both the primary key on our little table and on the index table, it comes back with nothing, which basically means there was no error. So those indexes are currently good. So now I'm going to upgrade this same machine again. So I'm kind of flipping back and forth between RHEL 7 and RHEL 9. I've now taken that same table that was built on RHEL 7 onto a RHEL, I've upgraded the OS to RHEL 9. And now, when I do that select order by from the unsorted table, you notice my signature has changed because I'm getting a different order. You also notice it now takes almost an hour. Now, like I said, I'm going to talk about this a little bit later, but the short thing to catch there is this is a later version of glibc. So like I said, there's a performance regression that may or may not affect you, but if you've got a lot of multi-byte, Unicode strings that are being sorted, it may matter a lot. Now, the other thing you can see here, and this shouldn't be a surprise at this point, but if I select from that index table, I'm still getting the same signature. But remember, we're on rel 9. This is actually a corrupt index. It's not producing the correct result. If it was the correct result, it should match that now. Right? And it still takes about 3 seconds. And now when I use my AmCheck on the rel 9 machine after the upgrade, you'll see I get errors. So I get this item order invariant violated. So this means basically you've got a corrupt index. So both the little table and the big table have corrupt indexes now. So this time I was smart enough not to let anyone go in and do any updates or deletes to my big table, fortunately, right? So at this point, all I really need to do is reindex. So when I reindex, you'll see now I get the expected order for a rel 9 machine, and I no longer get an error from AmCheck. Okay, so that's kind of the end of that part of the scare tactics. Any questions about all of that? Yeah, go ahead. This behavior is what you'll get if you started out on, say, a rel 7 machine with Postgres, and then you upgraded the OS without rebuilding your indexes. If it's clean install, then right out of the gate, you're just going to get the rel 9 sorting semantics, so there won't be a problem. But eventually, when you upgrade rel 9 to rel 10 or whatever, you're going to have a problem. Well, yeah, I'm going to get into this in a minute, but yeah. So Devram's point is actually covered on the next slide, which is anytime you have a distributed cluster, you have to worry about the OSs not matching. Right. Go ahead, Jonathan. Oh, I see. Jonathan is feeding me a leading question. Yes, actually, that's a good point. There have been spotted in the wild cases where minor versions of glibc changing has caused changes, unintentional changes in collation. So indexes have been broken by what should have been a minor version change of glibc. And by the way, it's also been spotted in the wild where there was a minor version of ICU that broke collation. So, I mean, it's not just glibc. ICU has had this problem. One of the things, and again, I'll talk about this a little bit more with the alternate solution, but one of the things you find out when you really start digging into this is glibc uses some data files and it uses some shared object libraries that it pulls in order to do all this locale magic. And so it's dependent on data and code. And you can change collation unintentionally with either. If the data changes, you could change collation, but if the code changes, you can definitely have changes in collation occur. Michael? So this was Susie? So SUSE actually did a major version in a service pack. Wow. I didn't know that one. Okay, that's good to know. Go ahead. Oh, so you've basically facilitated database loading in the GitHub repo. So Jeremy has made his stuff more convenient to use if you want to test a database. Awesome. All right, so this is a different example. This is the distributed cluster example. So in this case, I'm on a RHEL 9 machine, and I'm creating the Postgres foreign data wrapper, right? And then I create a foreign server that points back at a RHEL 7 machine. And I'm still using that little 3-row table, right? And so I create a mapping for a user, and then I create a foreign table that points to that 3-row table on the RHEL 7 machine from the RHEL 9 machine. Is that all clear as mud? Now, you notice one of the things I did here with these options, I wanted to force a certain plan in order to facilitate what I'm trying to show here. But, you know, suffice it to say that you could run into this in the wild in real life use cases. So once I've done that, now I'm going to do this join of a local table on the RHEL 9 machine to my foreign table that's mapped to the RHEL 7 machine. I'm just trying to join on that column, right? And those 3 rows should be the same in both tables, and it should just work, right? But instead, I get this error. Merge join input data is out of order. And why is that? Because a merge join assumes that the data is sorted consistently on both sides of the join. And because one of them is sorted differently on RHEL 7 than RHEL 9, it detects that it doesn't know what to do. Postgres doesn't know how to handle that, right? So it throws an error. And you can see here in the explain plan, you can see this is one of the things Postgres will do is try and push down the order by if it can, right? And so by forcing this plan where it pushed down the order by, on the RHEL 7 machine, I got its order, and I tried to join on the RHEL 9 machine with its order, and that's why this didn't work. Okay, so here's a third type of problem. And I'm not going to say by any means these are the only 3 types of problems you might run into. I just, you know, really couldn't get any more slides into this talk and thought this was enough to convince people they need to be worried about it. But this is another kind of legitimate thing that you might run into. If you've got partition tables and you partition on a range, so you can see here I've created a partition by range, and then part 1 is from min to 1-A, and part 2 is from 1-A to max, right? And so when you do this, it's basically inclusive on this side and exclusive on that side, right? So this takes everything up to but not including 1A, and this takes 1A and everything greater, right? And so on the RHEL 7 machine, when I do an insert of 1A, that value ends up in the first partition. But now on a RHEL 9 machine, if I insert that same value, it's going to go to the second partition. So if you were depending on, you know, with partition tables, you really can't have a primary key that spans the partitions, right? So if you're depending on the partitioning scheme to maintain uniqueness, you just failed. And if you're looking for your 1A value on your RHEL 9 machine, it may not be in the partition where you expect it. So again, this is just a third type of problem. All right, so I'm just going to summarize everything I just talked about. Your collation was almost certainly provided by glibc if you're on Postgres 15 or earlier. On 16, there were some changes made that made it more reasonable to have ICU sort of database-wide. I don't think many people use ICU database-wide, however. So probably all of you are using glibc for all of your collations. So it most likely affects you. Sort order relies on collation. Indexes persist sort order. Constraints may depend on order. I mean, that's another thing I didn't really show, but you could have like a check constraint that depends on ordering. Partitioning depends on ordering. Merge, join, and other operations may depend on ordering. Distributed clusters might depend on ordering being the same. And by the way, this is not necessarily just Postgres, right? There are lots of distributed systems out there today, and to the extent that they depend on glibc or even ICU for their ordering, you could be getting incorrect results as things get merged together. I don't know how Hadoop works, but that type of use case comes to mind. So here's the other half of why it's important. Actually, in my slide until this morning, I thought RHEL 7 was end of life in 2026. And I think maybe a year ago when I first built these slides it was, and I think they may have pulled the date in, but it now very clearly says that the end of June in 2024 is end of life for RHEL 7. And I'm willing to bet a lot of RHEL 7 machines are still out there. And Debian also end of June, and Ubuntu 14.04, which is one of their long-term support versions, is end of life in April. Uh-oh, why is that not working? Maybe my battery finally died. Wasn't doing that before. Okay, so all right. So the problems we need to tackle are broken indexes. You know, again, don't rebuild your index. Don't allow any DML to occur in your database before you rebuild the indexes if you've done an OS upgrade. Otherwise, you'll have a bigger mess to solve. Distributed systems, you have to pay attention. Replicas can have problems. Foreign servers can have problems. All right, so now I'm going to get into the third part of the talk, which is the solution that I worked on for this problem. Does anyone have questions about any of the preceding stuff before I move on? How am I doing time-wise, Devram? How much? 25 minutes? Oh, I got plenty of time. Okay, good. All right, go ahead. '28 was the huge change. Well, I think Jeremy's conclusion, I think, has been that every major version of glibc has some changes. 2.28 was like a huge change. So that one was like the obvious one, but every major version has potentially some changes somewhere. No? There have been some where nothing changed? Right. Yeah, it doesn't mean that just because you're past 2.28 doesn't mean like you'll never have a problem. And you know, to some extent, some of this depends on what Unicode does too, right? But I mean, I think some of the problems that people run into are when they have data in the database that's at an unassigned code point. So it's an unassigned Unicode code point, right? So some data gets in there through some user form or whatever, right? It's it's really not an assigned character. And then some later version of Unicode comes out and it like assigns it. And then it needs to put it in proper sort order. And so that character is suddenly going to start sorting differently. Right? I think I got that right. So you didn't see any changes between 8 and 9, or? Okay, so the solution I worked on, we called it lib-compat collation after lots of discussion. You know, one of the hardest problems in computer science is naming things, right? What it is a method to build an extracted, the locale functionality extracted out of glibc by itself, standalone, kind of in a nutshell. And that is done in a way that makes it portable, at least in theory. I mean, and in practice, I mean, I've tested that across several major versions, and it does work. Can't promise it'll work everywhere for everything, but for the things that we've needed it for, it's worked great. It allows you to basically pin to a specific collation semantic based on a very specific glibc. And you know, we've tested this both for x86, 64, as well as ARch64, so it works with ARM. And you can either link Postgres to this library and use those versions of the locale functions, or you can use LD preload, either one that you prefer. Now this is available in on GitHub. Oh, I was going to talk about this. I think actually I talk about this later. So this is the location on GitHub, and one of the things to note here, because I've gotten this question a few times, if you come into this repository and you just look at the main, there's like nothing there. It looks like there's nothing there, and it's an odd way to handle the repository, but after a lot of discussion about the details of how this stuff works, we decided it made sense. So I'm sorry if you don't like it, but this is the way it is. So you'll see there are two branches here, 217, 326 EL7, and 22659 Amazon 2. So basically what we've done is we've created this based on very specific RPM package versions, one of which was from RHEL 7, and one of which was from AL2. And the reason that these are so specific is because, as we talked about, even on a minor version change, you can get subtle changes in behavior. So how would you, if you wanted to use this, you would clone the GitHub repository. You check out one of those two branches, right? And then you just basically run glibc compat collation build, and then install the RPM. And that RPM has no dependencies. You build it on a RHEL 7 machine, you should be able to install it on your RHEL 9 machine. And I've taken the binaries out of that RPM and installed them on my Linux Mint desktop, and they work just fine. Okay, so, you know, again, the way this is built is, if you go back and look at this repository, you'll see that it's built on top of specific glibc sources, including, basically what happens is if you did an RPM source install, let's say for glibc 2.17, you would get a sources directory and a spec directory, right? And in the sources directory, you see this? I'm just going to scroll this really quick. See all these? Those are all patches that get applied by the RPM maintainer. So whenever you install RPMs on a Linux system, the maintainer of those RPMs are applying patches to the upstream tarball, which may or may not change the behavior of collation, right? So in the spirit of, like, I don't know if you've ever heard of Intel copy exact, but the idea here is we want copy exact. We want exactly the same, you could call it bug compatible, whatever you want to call it. We want exactly the same behavior as we get from one very specific RPM version of glibc. And so that's what this is built on top of, is it basically, we do an RPM source install and apply our patches on top of it, and that's what's in this repository. There are two distinct types of changes. There's a few small changes to the glibc source code itself, and then there's some somewhat larger changes that are required to actually get it to build. The goal was to minimize the changes because, again, we want to make sure that it was easy to reason about the changes, especially the ones to glibc itself, to make sure that we weren't going to inadvertently change collation. And they kind of fit into four categories. glibc has a lot of kind of hard-coded assumptions about file paths. So like I said earlier, glibc locale functionality depends on libraries that it loads, as well as data files that it loads. And those are in a very specific path on your system, typically something like user lib locale or something like that, right? Well, those are hard-coded at build time for glibc, and we want to have our own set in parallel with the system glibc. So we had to modify those paths so we could have a path that we could control what's in it. We also wanted to have, glibc is kind of very cross-linked in that, you know, since virtually everything that you build on a Linux system is coming from libc, right? All the basic functionality, right? If you want to allocate memory, that's going to come from libc, right? So these things are all tightly cross-linked, and what we wanted to do is just extract just the stuff that was needed for locale. But in order to make this portable, we wanted it to be able to run on a system with a different version of libc. So we didn't want to pull out the functionality that wasn't specifically related to the locale. And then kind of related to that, glibc exhaustively kind of versions its symbols. And I'm not sure, how many people here are familiar with symbol versioning in libraries, kind of, sort of? So like if I've got a function call, string call in glibc, under the covers it's really string call glibc dash 2 dot whatever, right? And that will indicate which version of glibc that particular version of that function comes from. And when you link that into your program, that's what your program is going to look for. So we wanted to replace those with the versions from this compatibility library so that when you inspect the binary, it was really clear which of the function calls were actually coming from libc versus which were coming from the compatibility library. As I alluded to, you can preload. In that case, you have to build slightly differently, which I'll show in a couple of slides. And when you do that, it will actually preserve the original glibc symbols. And then some really minor changes to the functionality. Really, I think mostly just that one function that reports the version of glibc. Instead of reporting 2.17, it's now going to report 2.17-326.el7, so that it very specifically tells us what this came from. So for the package building code, we had to touch the spec file, basically get it to build what we wanted and not build all the stuff, all the other glibc stuff that we didn't care about. The custom build support, there's three main files. This build files.txt, basically in glibc, every function that you would call from libc, like, again, memcopy or something, has its own C file in glibc tree. And so this build files text basically shows you all of the functions that were extracted out of libc in order to build this collation library. The libcompat collation map is the symbol map. So for all of the symbols that we wanted to remap to our own symbol names, that control is controlled by that. And then there's the build scripts themselves. And then as I talked about, if you did wanted to use this and you wanted to preload and not specifically build Postgres against the compatibility library, you would just have to tweak this one setting in the build file. Okay, so I just want to go through some lessons learned that I had as I was developing this thing. As I talked about, when you build glibc, there's all this functionality that we didn't want, and much of that functionality actually is intimately tied to another library in your system, which is called ld.so. LD is the dynamic loader. So when you load a shared object library, when Postgres starts and it loads all these shared objects for extensions and whatnot, LD is what loads them. LD has some data structures, specifically this, 10 minutes, okay, RT LD.global and the read-only version of that keep track of things like about your CPU and other locks and stuff that it's holding. And those structs, as you can imagine, change from one version of glibc to another. And so you didn't want anything left in the compatibility library that referenced one of these structs. And at first, it took a while to figure out where all those were and get them out of there. But that was fixed pretty early on. Again, that rel 9 timing that I talked about, there's actually a commit. This is the commit in 2014. I don't know if you can read that. It says improved performance by removing a cache. Now, to the author's credit, he goes through he has some data here that he apparently tested something and proved to himself that this was faster in most cases, the way people use glibc. I haven't really looked at it that closely, but I have to assume he certainly didn't use Jeremy's 26 million string torture test, because this commit is what took us from 3 minutes to 60 minutes for that sort. So one of the benefits that you get out of this, if you were to stick with this library from 2.17, is you get the old faster version on the newer system. But by the way, I ran the same test with ICU and they were about the same speed as the faster earlier version of glibc. Yeah. It changed sort order, yes. That's an example of C code only changes that affected sort order. Okay, so next thing, I ran into an issue with C-type init. This was a threads thing. Didn't get picked up initially because Postgres is not multi-threaded. So didn't run into the problem. But it turns out things like pgbench, pgdump can run multi-threaded. And what happens is the C-type init is needed to initiate some structures that are used for the C-type calls, which are things like upper and lower and what type of character is this? And those happen to be thread local variables. And so when libc does this, it runs this at startup. So when the libc loads, it runs this, but then it reruns it every time it starts a thread. Well, the problem is since that's running in libc, not in the compatibility library, it wasn't reinitializing these variables in the threads. And so that was causing problems, but that's been fixed as well. And then there were some cases. PSQL was probably the best case. It was linked both to the compatibility library, but also to libpq. libpq, the client-side libpq, was not getting the compatibility library linked because of a filter in the make file. So actually, if you want to fix that, I have a patch which is linked somewhere on one of my slides that will just, it's like a really simple patch to some make files in the Postgres tree, which get them to actually use libcompat_call for some of the tools. But because of that, setLocale was actually getting called in one place in the compatibility library, and in another place it was getting called in libc, and of course that didn't work very well. And then the final problem I ran into is that the difference when you build with optimization or not. When you build a binary on a Linux system with GCC, you typically say -02 means optimization level 2. So that kicks in certain things like inline functions. But if you build with -00, which is as a developer you often will do because you don't want the optimizations because it makes it harder to debug. So I was building with 00. I wasn't seeing this problem. We had the real builds with 02, and suddenly it was like, well, why is this breaking? And that's because there were some things missing from the exported symbol map. All right, so real quick, I think I have 5 minutes. Is that allowing for questions? I get until 3:30. All right, I got 10 minutes. All right, thank you. It's like daylight savings time. I just got more time. All right, so I'm on a RHEL 9 system. I install the RPM for my 2.17 RPM for the compat call. And then when I configure, now this is a source build of Postgres. I assume if you're going to get into this, you're at least comfortable with this sort of thing. When you run configure, you have to have libs and then include that on there. And the way GCC will build, if you build with a library specifically on the link line, it's linked before libc. And therefore, if the symbol names are the same, your version will get used instead of the libc version. Oh, and this is, I referenced that patch earlier. So if you really want to capture all of the tools, you have to fix those make files. That's what this patch does. It's maybe something I should get upstreamed. I haven't really tried too hard, though. All right, so you test it out. So you remember we're on a RHEL 9 system, but now we're seeing the same sorting that we would see if we were on a RHEL 7 system. And if we try and insert a duplicate value into that table, we're going to get an error, which we'd expect. It doesn't go in there and corrupt the index. And now if we run that same query again, the actual collation is showing up. This is that change I was talking about in the glibc version function. It now shows the specific version that we're running at. And so when we do our string test again, now you're getting back to that signature that we expect from a RHEL 7 machine, but it's on the RHEL 9 machine, and the timing is back to our 3 minutes. And of course, our indexed version is also getting the right answer. And AmCheck shows no problems with our indexes. Okay, so just a couple more slides. This is really just if you're interested in all that, all of this topic, if you wanted to play with this, this is one way that you can examine your Postgres binary and see which symbols have been linked to the compatibility library versus which symbols were linked to glibc itself. And so if you see something like setLocale is linked to libc, then something went wrong. And then this is sort of the same kind of thing. This script will go through your entire build tree and make sure all the binary objects in the build tree have been built. All the symbols that are in the map file are actually linked against the compatibility library and not libc. So these are just some helper things that I developed along the way to kind of validate that everything was working. So in summary, glibc collations can be hazardous. I kind of covered it in some ways that you could fix that or at least deal with it. And I showed an alternative approach. So I think I'm got a few minutes left for any additional questions. 5 minutes? Yeah, go ahead. So the question was, is Devrim going to include that in the RPMs? And Devrim gave an emphatic no. Jonathan? Right, so Jonathan's question is, what do we need to do upstream to make this better? Part of that answer, I actually meant to talk about this. Yesterday, Jeff Davis, who's also on our team at Amazon, while I was working on this kind of how do we deal with the legacy stuff, I asked Jeff, why don't you please look at fixing this going forward? And so Jeff has actually gotten the very first commit that provides a built-in collation provider. I think it's not complete yet. I understand from him he's hoping to get everything in there so it's 17 at least has an option for a built-in collation, which then means this stuff is all in the hands of the Postgres developers and we're not dependent, dependent on what's going on in the system. So that's part of what needs to happen, I think. It doesn't solve all problems, but for a lot of use cases, this is just perfect because you're really depending on your indexes to do lookups fast and joins fast, and there's only some cases where you care about, does 1A sort before 1-A or not, right? And in those cases, you can actually put a collate clause on your SQL and get it to use a different collation. So, and this will be a lot faster even than the 217 glibc to boot, and it'll be faster than ICU because it's just basically doing binary compares. So that's part of it. The other part of it, I think, is something that's come up. Thomas Monroe posted like a proof of concept. It's been, I guess, a year or two ago now. But he posted a proof of concept for a way to load multiple collation libraries simultaneously into Postgres. And really, ultimately, we need that so that when you go to the new OS, we still need Devrim to support old versions of ICU, right? So when you go to the new OS, you have to have the old ICU and the new ICU, and then your indexes will still work off the old ICU, but then you have a migration path online to start building indexes concurrently that use the new ICU, and so that you can kind of in a controlled way cut yourself over from the older to the newer. So that's ultimately, I think, what we're going to need to get to. That's not going to happen in 17. Maybe that'll happen in Postgres 18. We can cross our fingers. Well, unless you build it with the preload option so that it can only be used preloaded. So if you do that, then basically they just have to install the RPM and set up LD preload. I mean, the reason we didn't default to using preload is because it's a little bit harder to verify that you're actually getting the symbols pulled out of the right library when you're preloading. And if someone messes with your preloading settings and all of a sudden you go from using the compatibility library to using libc, that would basically break your indexes. So I think preloading is a little bit more fragile, but it would be easier because then you don't have to rebuild all the Postgres binaries. It would just work. Michael, did you have another? I think we got one. Absolutely, it's an open source project. So if you wanted to, we needed the AL2 version. I did the Red Hat 7 version because I figured that covers a lot of people, right? But if you had another version and I'll be happy to, I'll be happy to help you get through doing that. It's not, when I originally developed this for AL2 and when I did the RHEL 7 version, I think it took me like a day and a half of hacking to get it to work. So it wasn't like a moon launch, but it wasn't like trivial. Well, yeah, that's true. If it's Debian, I'm happy to work with you to try and make it work even on Debian. It's just that would be a heavier lift. All right, I think that's all the time we've got. So thank you very much. If you've got any other questions, I'll be around in the booth on the weekend. Come visit us.
Hello, hello. Is this thing on? It's not on. Test, 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 test. Oh, wow. So it, let's see what we can do. Thank you. Yeah, so I was in Brussels and I did this presentation and, you know, so super quick. You got to get in and out. And I thought I took it. I got home. I'm like, oh, I left my clicker. Because I have a real night, like a spotlight. I left in Brussels. I emailed odds. I was like, oh my goodness, I really like that clicker. A month I've been searching. I was like, whatever. So I go to pack and I pull something out of my bag. Like I had been through the whole bag. I pulled it out and it drops. I was like, there it is. And I forgot it at my table. I was like, you got me, did it. It was in my bag the whole time. And then I left it sitting on the table. Like an idiot. What's that? I have no idea. All right. So is this actually coming through out there at all? Yeah, yeah, yeah. Okay. Hello, hello? Yeah, it's not. It's the same thing was happening. I mean, if I hold it really close, but they had adjusted it yesterday for some reason, and it seems like it's who can we? I actually am going to type at the end, so I want both hands free. I guess I could put that on.
Check.
I could put that on the stand, I guess. Transforming data with the power post. It's really quiet, right? All right. Hello, hello. So that's better, but it's still. I have a loud voice, and that's not really loud. Oh well. Is it okay? All right. It's mostly for the recording. I wouldn't need this otherwise, but.
Other than I'm going to snap a photo of whoever's in the other room and then come back. But I'll play room host, which basically means I'll sit in the front, and then if you are you going to do it questions at the end? Okay. Can help watch time.
So we'll say it's not nearly as cold up here as it is in the back of the room. That's kind of up. It is freezing back there. I told them like 2 hours ago, and I felt like it was starting to get warmer. I was like, oh, they got it. No. Yeah, the vents are, there's just like there's one, there's no vents up here. All right, we're going to give it another minute or two. It's just cold in here. I'm sorry about that. I wish I could fix it. I've tried like 3 times to ask them, and nothing's changed. It's slightly warmer up front. All my fonts hopefully are big, but maybe you'll see better if you come up. How many folks are regular Postgres users? How many of you are regular Postgres users? All right. But not everyone. These speakers really are not loud. Like, I am eating this thing, and it's really not. You can hear me just fine? No, you're close. Can you hear okay back there? Yeah? Okay. I feel like I just want to shout. I just got to be recorded. So anyway, I'll do this. But that's great. A lot of people have done a lot of stuff, yeah. There are so many possibilities at this point, for sure. All right, I'm going to go ahead and get started. It is 3:46. We'll definitely have time at the end for questions. The title of this talk has changed like 3 times as I give it. I changed a little bit and realized like, okay, got to figure out a better way to identify exactly what we're trying to go through here. So for me, I'm going to talk about really taking raw data, transforming it into something that hopefully is usable for doing, whether it be analytics, or some kind of transformation, which we may have done previously outside of the database, but there's a lot of power in Postgres to help us do that internally. So this is me, Ryan Booz. I currently work at Redgate. Redgate is a database tooling software company based in England. They've primarily, for 25 years, been in the SQL Server and Microsoft platform space. They acquired Flyway. We acquired Flyway, which a lot of you probably have heard of. It's a migration tool for doing database migrations as you upgrade and change your schema. Acquired it in 2019 and been putting a lot of energy into it. There's still an open source version of it. And we now support, even that open source version supports upwards of like 60-some database connections to do migrations to, Snowflake and all the others. So I am Ryan Booz just about everywhere. So, LinkedIn, wherever you have, you can come find me. I love to chat. Don't be afraid to reach out. I'll leave this here for a second, and it's also at the end. So I had this conversation on Twitter yesterday. You're welcome to take as many pictures as you want, but I just want you to know that this deck is already up there. You could download it right now and follow along if you want. But it is there. It's a PDF, and it looks like this. Whoops, wrong. Hopefully it doesn't look like that, huh? So this is the repo. I have a presentations folder, and all my presentations are there. I try and get everything, anytime I do a talk a second time or a third time, it's always updated. So this will take you to that. It has a SQL script I'm going to show you at the end, and the actual PDF of the talk. Oh, sure. Yes, you can. You can post a picture. I totally get that. You're right. All right. And I also, so videos like this, if something's recorded and it's public, I just link it to playlists for each year. So my playlists are here. If the talk is helpful and you want to go back and watch it, I'll make sure it gets linked here once it's public. So, all right. So YouTube again at Ryan Booz. You'll find the stuff there. All right. So here's the talk. Right. 5 basic sections, and we'll do a little demo at the end. We're going to talk about ELT versus ETL. All right, or actually ETL versus ELT. And then talking about how we can use various features of Postgres to set the building blocks to then go even deeper once you've learned the building blocks. All right, and what I've come to learn about myself, and as I go to conferences and talk to people, is sometimes it's easy to assume that everyone understands exactly how recursive CTE works, or what function in Postgres allows you to split strings in a specific way to get values out and this, this, that, and the other thing. Because it feels like once you've done it for a year or two, like, oh, everyone must know this, and realize that it's not the case. So when I first did this talk, it was this monstrosity of all the fun puzzles I had done with advent of code and all the fun things I did to solve all those puzzles. And after about 50 minutes, I'd gotten through 3 puzzles. I was like, okay, I have to rethink this. And the reality is, I realized that most of the folks that were coming didn't fully understand just some of the building blocks that would help them do these kinds of things in their environments. So that's what the majority of this is. I also, if you go to that GitHub repo, you will find some of the puzzles I've solved over the last 2 years with advent of code using SQL. And that was a challenge by the Postgres community. It was fun. I love solving puzzles. I've learned a ton about how to better use Postgres and SQL. So advent of code, a lot of this has been, I kind of really got into this a couple years ago, trying to better understand how to take what seems like non-relational data and making it relational with Wordle. Back in 2021, I guess, I was trying to do a sample of, I wanted to take those emoticons, or the emojis, sorry, those little squares, and turn them into data I can analyze. And sure, I could do it in 100 other ways. I could do it in Python. I could do whatever language, this and that. But I thought, what if I could just take the, in this case, the tweet, the text of the whatever we call them now, shove it into a database, and then with SQL alone, transform it into a table of data that I could actually analyze. And in learning how to do that, I discovered new things about Postgres I had no idea about. I didn't understand what was going on, and that opened up the opportunities. So both of these were kind of the on-ramp for me, and that's why I'm going to use them as some examples today. Most everything you'll see here is available in Postgres 9.6 forward. There are 1 or 2 functions that I will show you or in the SQL that are only in Postgres 14 plus, all right? I'll point out the one I think that's in here. There are a couple others. So when we get to the samples, some of the SQL I'll show you in slides, and then when I do the demo, I'm primarily using these 2 puzzles. So you can go to advent of code, you can go look at the content, the puzzles, what you're supposed to solve, almost, I think for any of the years they've done it. This has been on for, I don't know, does anyone know, 12, 13 years, something like that? So I picked day 7 for both years. It was totally a coincidence. I actually didn't realize that until I put the slide together. So day 7, December 7th puzzle for 2023 is really simple. And it's a very simple kind of input, and it allows me to show a lot of this. And then last year's day 7. So basically, the 2023 puzzle is just a simple line. It represents a hand of 5 playing cards, and then a value. And the puzzle was to split all these things out, understand the cards, and then you do some addition and multiplication based on a bunch of other things. But you got to take that string and do something with it. And so that, it just allows me to show you something pretty easily. And then the order of the cards in the hand, left to right, 1, 2, 3, 4, 5, is important to later solving the problem in the puzzle. Last year's day 7 is going to be familiar to a lot of us. And that's one of the reasons we use things like recursive CTEs. It was basically about moving up and down through a folder system on a computer. And so we can take the input, the command CD and up, down, whatever, and find where all the files are within the folder structure. And again, the puzzle was basically to find, I think, the folders that had the least amount of data to delete that folder because you needed to add a file. You needed to free up space. But again, it's moving up and down through a file system, which all of us have done at some point. So let's talk about ETL versus ELT. So who has heard of ETL? Most of us have. Who has heard of ELT? A little fewer of us. So the whole point of ETL is to take non-relational data and convert it into something that's relational so that we can use the power of SQL to analyze that data. Now the data can be a text file. The data can be a grouping of a text file and connecting to another system like Snowflake and bringing that together. Connecting to a Parquet file with a text file, with whatever the sources are. It could be many different sources, but you're trying to get that, relate it, turn it into something that you can get into a database and do analytics on. The differences are really minor, but really, powerful depending on which way you want to handle this data, right? Extract, transform, and load is primarily external. There are tools that have been built over the last 25 and 30 years to do this for you, right? They're specialized tools, and they can do all kinds of transformations, but they're special, they cost money, and it's outside of the thing you're ultimately going to use, which is the database. Extract, load, transform is just that small difference. We're still extracting, we're getting the data from wherever it's at, but then we're going to load it into the database first, and then use the power of SQL, Postgres, and the things we can do there to transform it. So why would we do one over the other? Well, let's talk about ETL briefly. Why has it been so popular? And it has been popular for a long time. This is the primary way that we take all this disparate data and turn it into something we can query. It's been popular for a couple reasons. It's not reliant on a specific database, right? It's an often external tool that can pull all these things together, often kind of in a pipeline. You chain events together to process data in some form that eventually gets it into a table-like thing that you insert into a database, and then you move forward. Databases, the other, probably the primary reason is as the web grew, most of the databases we use, at least until the last couple of years, did not speak the language of the web very well, right? So it used to be XML a long time ago, and then the last 15 plus years, we've been using JSON for everything, and most databases didn't have a way to store JSON efficiently and to query it well, right? So we had to have something else to transform that thing to get it into the database so we could do it. Well, that's changed, or is starting to change pretty dramatically. Then honestly, one of the other reasons it still exists and still popular is it developed an entirely new class of jobs. And so people have learned and they become experts in these tools. The tools often cost a lot of money for the licenses. You might only have a team of 2 or 3 people, but they're really valuable. And it's hard to want to get rid of that special team if you're not sure that you can do everything you need to otherwise, all right? One of the problems, at least in my experience, has been, though, with ETL is because it's external, iterating when new things happen can be really slow. Because you're relying on an external tool, you're relying on people, you usually have to have these different requests, you have to then decide as a DBA or developer, okay, what's that mean to my schema? What do I need to change? If I add the columns I need and I give that request forward, are they going to understand it? And am I going to actually get the data I need? So there's a lot of iteration that's outside of the database, and it slows things down. You can't kind of go as quickly as you'd like. Now, if you can keep that processing in the database, closer to the database at least, you get a lot more control over those iterations. Right? You have things like temporary tables. You can try something without actually impacting your schema yet, see if it's going to work and move forward. You don't need to rely on someone else to do it. And that's really then where I started to learn more about this concept of ELT. Now, I actually, in my career, I'm 22 or 23 years into this whole tech thing. I did a lot of ETL a couple jobs ago. We had thousands of client databases. We would pull stuff together to have metrics and to pull, is this client, is there kind of data for building data similar to the other clients within this group, this region, what have you. But as I started to realize that I had all of this information now with APIs that I could grab, and I could start to do this in the database, this concept of ELT became really important to me, or really interesting at the very least. So a couple of benefits. Number one, it retains the whole transactional nature, right? One of the problems with an external tool is you don't have that control. It's going to process what it's going to process, but if it fails in some way, if you were inserting that data into the database, you would know the rows that got committed, right? And so you lose some of that because it usually ends up being a batch process, and some things, you might lose some of the nature of the data. And Postgres has added over many releases a plethora of functions that can do all kinds of transformations with a lot of data types, whether it's JSON, whether it's text, whether it's array data. There's a lot that you can do. And honestly, for me, one of the things that was most helpful or interesting as a developer, my kind of developer experience coming to the foreground, is just something simple like arrays. When I understood years ago that Postgres had an array type, that was mind-blowing to me. And then to recognize a lot of these functions end up using or exporting array types, and there's a lot that you can do with that. So this all works together to say I can get some data, And then with a few functions, all of a sudden, it's a whole new thing that I can start to analyze. All right, so ETL versus ELT. One is external, insert the final result. ELT is insert as much as you can, as raw as you can, and then transform it. I want to talk about inserting data because obviously you need to get started. If you're going to load this data, and you have to worry about this with ETL as well, but when you're trying to get this raw stuff in as quickly as possible, you just need to know how to do it. A couple quick slides. A couple things I would say is if you're going to try and work through something like ELT, you want to do your best to get the simplest form of data, simplest schema that you're going to add it to first, right? So if I have a text file and maybe it's a CSV, maybe I don't know what columns I want, maybe I don't even want to split it apart yet because I don't know. You could just save rows of the CSV to a table. JSON, just save the JSON document, pull out what you want, but keep it simple. Don't get too complex initially. And then post-process all the stuff that's in there, right? So I just have the staging table with all the rows and chunks of data, and then I can figure out later how to start to do that. That saves you that step of a lot of time up front. What do I do with this thing first? Well, if I just have access to it, I can go ahead and just start trying, testing, playing with it. If you're going to copy it in, just a couple quick things. Use copy if it's something like a file. It's probably the easiest thing. Now, supported by, is the most important method for getting data in. I'm going to talk to it on the next slide. Typically CSV. There are other things you can do. You can name your own delimiters if you have custom formats, but it's a good way to get data in. And then I'll just say this. I worked at TimeScale for a couple years, and most of my history is about time series data. And when you get lots of data coming in quickly, you learn that it's best to work in batches. And so if you're going to start to ingest a lot of data with Postgres, and you're using some kind of, you've developed something, Python, Go, whatever it is, don't insert one row at a time. Batch up 10, batch up 50, and then do an insert, and you'll see the performance go up pretty dramatically just by doing that. Go to 500, go to 1,000, test it, see how fast you can get some data into your database. Now, 2 words about copy, and I just put this here because, again, you're going to walk away. If you haven't used copy much, you go to play with it. I just want to get this stuff in front of you. So copy is a SQL command in Postgres, but it's a Postgres command. It is not in the SQL standard. It actually is predates Postgres as we know it. It was in the older version of Postgres, and it's one of the things that came over. And it requires a file. So if you use the SQL command copy, it's looking locally to the server, the file system of the Postgres server. Now, most of us in a production system don't have access to that. Now, there are ways you use a hosted solution like Amazon. There are ways you can use copy to access like S3 and so forth, whether it be in Redshift and some other ways. But you're looking local. Well, most of us don't have that access. Honestly, even if you're using Docker locally, you probably aren't putting your files in the Docker container, right? So they're just on your file system. So what you usually then do is use the pSQL meta command copy. So the / commands, we call them meta commands. And so it's a meta command called copy. And what that does is it reads the file off your local system. It simply streams it in the copy format into standard in on the server. So you're getting the same benefit, but you don't have to be local to the server. Now, the only thing you have to know about copy there are a couple quick gotchas. Number one, it requires things to be in order. If you're doing a CSV, you can't just name various columns. You can exclude columns, but you have to know the order of the columns going in. The types have to match. So if you're trying to insert into an integer column and it's text, it's not going to work. I have no idea what this is behind me, but I kind of want to listen. Anyway, and there's no data conversion. So if you have a date format and the string is different than what Postgres expects, it's just going to fail. And the problem is any failure is an error. It stops. And any work that's been done is actually in the database, but it's not visible. And so it's taken space, and it won't go away until you vacuum sometime later. You could have inserted 3 million rows of data, and 3,000,001 fails, and you lost 3 million rows of data, right? You got to start over again. So that's one of the problems with copy. The larger, the more data you insert. However, there are other tools. So PG Loader is one that I refer people to. If this is a process you're going to do, it's a tool written a number of years ago, started by Dimitri Fontaine. A number of people contributed to it. And it basically takes the file. It allows you to specify various transformations if you want. So it can identify that the date format is wrong, and it will transform it before it does the copy for that row. And then if there's an error, it can basically save that row out ahead of time and then just keep going. So that's one tool. There are some others similar to it. If you, again, this is in that playlist I shared earlier, but this is a talk I've given a few times. And that's just 4+. There are a whole bunch more that you can play with, but a lot of these same principles just to go through. Any questions right now? Yes? That's correct. So it is textual data with some kind of delimiter. It can't handle JSON, doesn't handle XML, things like that. Yep. It's not helpful for things like that. So that's where often, great question. So the question was, I should have said that earlier, I apologize. Does copy handle something other than just kind of textual data, whether it be CSV or some other delimiter? It's not set up to do that, right? So it won't handle copying JSON in. Now, if delimited correctly and there's a column that's JSON, there are ways to actually get that in and it will work, and sometimes it gets a little bit wonky and people have trouble, but just inserting it directly and trying to transform it in some way wouldn't work. That's where you have to use probably a programming language because you are interfacing with an API and you're getting data out. Well, then just use that, whatever language you're using to save into the table, and then you can go about your business, all right? So when you're doing something like ELT, what I've learned over 4 or 5 years of just playing with this stuff and helping some clients do things because they're trying to iterate quickly is just keep it simple. Back in my older days of ETL, we'd spend a lot of time thinking about the schema we wanted so that we could transform this data, and it was a really long process. But if I'm going to do it in the database, I can just get the data in there. And so keep the initial table simple. The only thing I will say is if when you're inserting data, you're going to see me do this in a little bit, generate an ID column for every row that gets inserted. You don't know when that might be helpful for you later, right? So just so you have the order that things are brought in, that might not exist in the data itself. So just create an identity column. You'll be surprised. It might be helpful at some point. If it's time series data, maybe put the time series, the timestamp of when it was inserted, right? So you have a time order in some way. That might be something you need. Now there's probably a timestamp of that thing, a metric, a reading, whatever, but it might be helpful for you to know it was read 5 minutes ago, but it was inserted right now in the rows that were inserted in the batches and so forth. Again, I've found that to be helpful when it's time series like data. And then again, just pre-process what makes sense. And I'm going to show you an example in a second. Don't go overboard. Don't try and pull every single piece of information out and get it into a table because in 2 weeks you're going to change that and you're going to go back, and I'll show you why in just a second. Just do as little as possible initially and then get into the database and do your work. So this is an example that you'll see a little bit later. So this is that December 7th puzzle. It's just rows of text. So I didn't do anything with the text externally. I simply said, I'm going to copy the data in, and notice I generated an ID column, right? It wasn't part of the file, but that way I have that number in case I need a reference order in some way. Maybe I need to do a window function, and I need to look back to some number of rows in some way on some ID. You have no idea when that's going to be helpful. Now, Wordle, this is an example, this is a portion of the JSON from the Twitter API a couple years ago. I was reading in a couple million Wordle tweets over the span of a couple weeks, and this was a chunk of what the JSON looked like. I didn't need all of this. So initially, I just wanted to make sure I was saving them. I didn't want anything to error. I just wanted to get the data in. So my initial table was just this. I was pulling out the timestamp I was saving it. I was pulling out the tweet ID so I could reference it later if needed. And then I just saved the raw JSON. And I just let that thing go. Then I knew I was getting the data and I could work separately on transforming it. This became a part of what I did then as I transformed the data. Now I kept a separate table. of the raw JSON. And why I did that is this wasn't my initial go-around. I thought, oh, I only need the author handle and the tweet text and something else. And then I would iterate a little bit more and said, oh, you know what? I do want to know the location because maybe I could start to correlate tweets of where people were at. And so I could change the schema, go back to I could link on the ID of the tweet, and I could just update this data because I had access to it. Now, if you're storing all that data a second time, yeah, it's going to cost, right? You're going to have to store that somewhere. Now, in most cases, if you're in a hosted solution, you'd have some kind of time. I'm not going to store it forever. I'll archive it or I'll delete it. But in Postgres, you could save it to a table space that's really cheap storage. Like if you're in the cloud, that table could be stored out to S3 in some way, right? Or some kind of object. So it's really cheap. You have access to it if you need it. It might be slow to get it back later, but you still have it. All right? Does that make sense? Get the raw stuff in as quickly as you can. And this table went through 2 or 3 iterations before I got to this, because I just wasn't sure what I would need from that other data. I want to quickly show you this as just an idea. So everything I just talked about was taking your data and putting it into a simple table first. Now, what I have learned to do, particularly with the advent of code puzzles, is, has anyone done the advent of code? Any of those puzzles? Okay, a couple of you have. So the way they're set up is each day a puzzle gets revealed, and there are 2 puzzles for one set of input data. It's always about Christmas, and usually about elves doing something. And it's always funny and complex and weird, but it is what it is. And I would realize in every puzzle, you get a little chunk of sample data, right? The actual input is a larger file, but in the descriptions, they give you, 5, 10, 15 rows. And it was just easier for me to do a derived table often to start. I didn't want to deal with schema. I didn't want to create tables. I didn't want to download the file and import it yet, because the sample data, they give you what the solution should be for that sample data. And so I could work on my solution without importing data, creating tables or anything. So in this case, it was 5 rows of playing cards, 5 playing cards, space, and then the number is a bid. It's a value you do something with later. And so I just copy those into this regex split to table. So I essentially got rows of data, and I could just then start iterating through ideas of how I was going to process this. And then when it worked, I could create the table, import the main thing, and get my solution. So you'll see me do this sometimes, and honestly, think about it. Like, think about it as an option. If you have a new puzzle, something you're trying to solve, grab a couple rows of sample data or sample text or whatever it is, sample CSV lines. Throw it in something like this. You can get rows and see how you're going to transform it. I'll show you a little bit later. If it doesn't quite make sense to you, I'll show it to you in the demo. You'll understand a little bit more. Now, normally what I will do, because it's really hard, this is what we call a derived table, right? Well, this isn't quite a derived table, but this is the output from a function. I would have to put this in a subselect if I was not going to use a CTE. We're going to talk about CTEs in a minute. And so normally what I do is I grab my text, I throw it in a CTE so it looks like the table I'm probably going to do later. And the other reason I do it this way is, again, I don't have to iterate any schema. I'm simply changing this. There's no table action yet going on. It's just function output. If I end up with more columns, it just is here. I can iterate, and then I can create the table that I am ultimately going to want for the final solution. Now, I want to quickly point this out. Who knows about dollar quoting? Who's used it in Postgres? All right. Super helpful. There's a lot of ways you can go about it. So there's a couple places you have probably used this if you have programmed within Postgres. That is when you do like a function. You have to do dollar quotes around the function because there's text inside, or you have to do an anonymous function, right? So something that's just you're creating on the fly. It basically creates a block of code. In this case, dollar quoting is really about the text. This becomes a string literal, and I don't have to worry about escaping characters and escaping carriage returns. It's just helpful. I use it often in formatting. So rather than doing a single quote and putting the stuff in and doing backslash or whatever, I'll just do $2 signs, encase the string, and then I have a literal string to start to work with, all right? So that's what I'm doing here. I'm taking the literal 5 lines out of the text file. I don't have to worry about the carriage returns or anything else, and then I'm feeding it into a function in some way. Just a helpful hint. Hopefully you've already caught 1 or 2 things that you didn't know about. All right, so let's run through this. Basic building blocks. So I have data. I figured out some way to quickly start to get to it and iterate it. And I have lines. I have table rows coming out somehow. But now I've got to take that data and do something with it. So there are a couple functions that I think have, maybe you're doing it and you don't fully understand what's happening. So that's what I want to go through. The first is cross-joining. We've probably heard about cross-join. Cross-joining is when you take 2 tables or more than 2 tables and you join them with what we call cross-join. And it basically says for every row in the table on the left of that join, iterate every row in the table on the right. The output is a product of both tables. You know, if there's 10 rows in one table and 10 rows in another table, you're going to get 100 rows. We can demonstrate this really easily with something like generate series, right? I'm saying generate a series from 1 to 2, cross-join it with another series from 1 to 4, and you'll notice that I get 8 rows. So 1 iterated through each of the other rows, 2 iterated through each of the other rows. Why do I care about cross-joins? Well, we get to cross-join laterals. And this is so tremendously helpful for taking data and iterating and processing it through a SQL query. Here's what this means. When you cross-join, when the right-hand table of a cross-join is a function, is a set returning function. I gave you an example earlier, like the regexp split to table. I think that's what it was. It is actually considered, it is implicitly what we call lateral join. And that means the table on the right can reference any output from the table or function on the left. And all of that output from all of those tables or functions gets fed back up to the select, and it can be referenced. Well, this becomes kind of cool, which hopefully you'll see in a minute. So again, functions can, anything on the left, and then I call it kind of the reach back because later in the query, I can pick and choose from any of those outputs, however they were processed, to make my final query in some way. One quick helper, in all of my demos, I don't actually say cross-join lateral. It's just a lot of typing. I don't care. The comma means cross-join. And again, because in this case, the right-hand table, which is actually the second generate series, they're both set returning functions, but in this case, it's on the right. That comma implicitly means cross-join lateral, all right? That's just how Postgres works. It's in the documentation, you can read it. I don't have to say cross-join lateral, it's implicit. When it's a set returning function on the right. And so this is kind of what you can look at it as. Like on the, I have a select statement. I'm selecting from table T, and then I have a comma, and I'm feeding some kind of function in here. In this case, it's string to table, right? So I have string to table as my comma, right? It's a function, and I'm referencing table T, column A. And whatever that is, I'm basically saying split on nothing, and it's going to iterate the rows. You'll see examples of this in a minute. Now I do another comma, and because the second thing is also a set returning function, it can refer to any of the output above it, or on the left, as it were. And then all of this stuff gets piped back up to the top, and notice in my select statement, I can reference all of those things as tables and any columns that come out of those functions. It's a lot of back and forth. Why would you do it? You'll see a couple of examples later. It's just a really fun way and really useful way to process complex data as we're trying to transform it. So it also can simplify SQL higher up, and there's some fun ways. If you go and look at some of the advent of code solutions, you can actually then use something like values, which you can kind of reiterate and reform some of the data. A lot of things you can do with it. But then I threw this in the middle. Now that we have a function in the from clause, this is going to become really valuable. We can, any function that is a set returning function in the from clause, so it's a table, right? It's returning a set of data. Postgres has this unique thing called with ordinality. Now that means not only do I get the output of that function, but it will simply add an ordinal value with every single row as a new column. I don't have to do order bys, row numbers, higher in the query, anything like that. It's much faster, and you'll see why this becomes very helpful. Again, when you need to know the order of things coming out of that function, this is the best way to do it. Anything else here? Yeah, it retains the order of the rows coming out, so you wouldn't have to necessarily do something later to order it to get the row number. What that means is you can take something like this, which is, again, that CTE with the function inside. So I'm saying, hey, add the row number from regex split to table, and it's going to get me these 5 lines. It works. Now, in a much larger file, the biggest problem with row number as a window function is it must scan the entire data set to add the row number, right? It has to do the order by, everything has to be done first, and then it iterates the entire data set again to add the row number. So you're adding overhead. I could instead take the output of that function and simply say with ordinality, and then I'm going to get the output of the function, that's in this case lines, and then the ID. You can call it whatever you want. I'm giving it an alias of ID, and I get the exact same thing. Check out with ordinality. I'm going to show you a couple of examples, and hopefully a little light bulb will go off, and you'll see how it can be useful in what you're doing. And then the other thing I said, so we have with ordinality. I wanted to make sure I covered that so this wasn't just thrown out of nowhere. One of the other reasons that I've found to start to use these functions and cross-join laterals really becomes about what happens up top. So this select statement, I'm starting to transform it, right? I'm now taking, I need to get those cards, and I want to get each individual card out. Okay, so I'm going to move that to the from clause. I can take any row, so let me see, this is not my, yeah, I do have it. This is not my clicker. So this is the lines column out of December 7, right? So this is splitting it apart, so I'm getting the cards, and then I'm splitting the 5 values right there. In the first row, it's 3, 2, T, 3K, and I'm splitting them out into 3, 2, T, 3K individual rows because I need to know the hand it was played in and the order of the cards in that hand. But it's still kind of messy, and so actually I could take that split part, put it in the from as another returning function so that my query up top just looks nicer. I see a lot of people do that. Like again, it might be valuable and helpful to just clean things up a little bit. And then you can iterate down below if you want to change lines or something gets more complex. I just throw it out there because I've seen a lot of people do it. I'm like, you know what, I kind of like that. I can hide a lot of things. Here's an example that I actually had to get some help on this one. This is from last year, Advent of Code. This is about a really complex thing. You're removing 2 ends of a rope throughout a whole grid, and you got to track the position of every end of the rope, blah, 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 blah. So there's an H and a Y and an X and a this. And so notice the select query eventually became pretty simple, right? I had the ends of the rope and the H and the Y, the head and the tail of the rope. That looked really nice. And I could hide all the calculations down below in some cross joins, right? So I'm just transforming all this data, and what I'm getting out with a couple aliases right here made it much easier to just work on it down below, and the query up top was a whole lot easier to work with than comma and doing all the stuff up there. Any questions on cross-join lateral? Sweet. All right, common table expressions. Now, most of us have used common table expressions, I'm sure, but I just want to make sure that we understand a couple points so we can get to recursives. They're often called with queries, depending on the database you come from, because they start with the keyword with. Most of us do CTEs because they are more readable. That's kind of the thing that everyone talks about, right? And so, you're naming a query. It's a virtual table, essentially, with a name that you can reference throughout your query. Just note, prior to Postgres 12, they were what we called materialized. So kind of the query would be run, it would be stored in memory, memoized in some way, so that anytime you reference that table, it wasn't queried again. Now in Postgres 12 and above, it ended up becoming inlined, is what we call it. We try to inline it, which can help the query plan actually be better. But that also impacted some people's CTEs, so you can add the materialize keyword to have it take the old effect of materializing it first. You can chain multiple of these together. You're going to see that. And again, one of the things that some people don't know is you can actually name the output columns at the CTE. So it doesn't matter what the columns are named in your query. If you want to make sure they have a specific name, you can do that above. So this is what they look like, right? We have with, I name this query CTE1. Now the next query has access to any CTE above it, right? So I can name any table or CTE above it. And so this query currently only has access to the first CTE. Now if I add a third CTE, it technically has access, it can reference either of the other two. Whatever you want to do, one, both, none, doesn't matter. And then eventually you have to have a final query that at least references one of these CTEs to get an output. Pretty simple, right? And one of the reasons we do this is, again, looking back, this is a little bit further down the road for this puzzle that I was trying to solve with the positions and the card numbers and other things. This is a little bit further into the puzzle. And if you don't use CTEs, you probably do two subselects in some way to join it together because you're iterating. That's just ugly. Like, it's hard to read. And then you, like, the select is actually way up top, but you're doing all these named alias functions. It's just as annoying. And so we switch this around a little bit. We make two CTEs, and now notice how much simpler the query is below. This is why most of us do it. It makes the query itself a lot easier to rationalize about. However, readability is one of the primary reasons we cite. It doesn't mean that it's more performant, right? So CTEs can become less performant, particularly the more complex they get. Because you're asking the planner to basically plan a bunch of separate things and then, you know, put them together, and you're not going to get the right row estimations all the time out of each CTE. It just becomes annoying. And so it's not always going to be performant. Honestly, it might be less a lot of the time, but it's probably worth a hit for a number of the things you're trying to do. All right, so CTE is great, so we can see examples, but then there's recursive CTEs. Who loves recursive CTEs? I love when hands go up. Who has never used a recursive CTE? All right, it's there. They feel hard, right? But hopefully they won't seem that way in a second. So the SQL language is declarative, and it's basically batch-based, right? Which means there's no way to iterate the query as we go. You get the output, and yes, you might iterate it through, like a cross-join seems that way, right? Where for every row here, we're iterating here, but it's not the same kind of thing as looping over a data set. That's where recursive CTEs come in. Before we had recursive CTEs, SQL was not a Turing-complete language. But with recursive CTEs, we can now do complex calculations, which is kind of the marker for a Turing-complete language. And so when recursive CTEs were added, we're marked as a Turing-complete language. Kind of cool. And it really doesn't look, it's a CTE, right? We just did two things. We added with recursive, so we had to add the recursive keyword, and that simply tells the planner one or more of the CTEs in this chain of a query is going to theoretically refer back to itself. And that becomes the looping mechanism. So in this case, CTE2, I'm referencing both CTE1 in my select statement. I didn't want to take too much space, and I'm referencing myself as the CTE2 CTE. And this is going to cause this CTE to first iterate and loop over the process that you set up, the output of which goes on to the rest of what's happening. We often will hear these called hierarchical recursive or CTEs because this is where they're most useful. I want to recurse through something like a folder structure, which we've all done, we've all seen. And so you'll hear this called hierarchy, right? Whether it's buildings, and I used to work in utility data, so we'd have buildings, meters, divisions, all these things related, and we need to correlate them up to some kind of tree that we were going to work through. So here's how CTEs work, recursive CTEs. There's two parts to it. And this is where I always have gotten messed up until I start using them more. The first is what we call the initial query. It is a static query. It only gets run once. And it's the setup for the rest of the recursive CTE. The output of this query will determine the data types and the columns for this, the output. So in this case, I had this simple folder. Let's just assume this is a table in my database. I have 3 columns. I selected out the name, the parent folder, and the size. Where parent folder is null. I only had 1 parent folder, so I get 1 row. And I see that the name is folder A. That output becomes the input to the next iteration, which I can then join on. So when I refer to, that's the files on disk, is the table, files on disk, and I'm joining to myself. I called the CTE files. I'm joining the output of the previous iteration, 1 or many rows. In this case, I'm joining it on the parent folder on the table to the name of the output from the previous iteration. And that's how we start to recurse. And so the output of this is what the second iteration would look like at this point. I'm sorry. And then we union them all together, right? So we have to union, that's a requirement for the recursive CTE. So we take the first one, it never gets run again, and every iteration takes the output and runs it through the second query. And so iteration 1, I got the first row. Iteration 2, I got 5 rows because all of them had folder A as my parent. All right. I'll show you how this completes in the demo. Now recursion, this is a caution, right? Recursion continues until it finishes, until there's no output. Or you put a limit on it. Well, if you don't put a limit on it and you don't know when it's going to end, you end up in an infinite loop. So you got to know that you're going to have an output, or your CPU is going to go bzzz, and everyone's unhappy. So just make sure there's an endpoint, or add one arbitrarily. A where clause that you know is going to end the thing in some way, or a limit, whatever that might be. And then this is my caution. I have like 4 or 5 talks. Like, I love arrays. I love range types. And I find for myself, every time I learn something fun and new, all of a sudden it becomes, have you ever heard the saying, when all you have is a hammer, everything looks like a nail? That becomes these tools for me. I'm like, oh, I love recursive CTEs now. Every puzzle, I'm going to find a way to use recursive CTEs. And then it's like the stupidest thing. And I just needed a window function, and it would have been solved. So just be cautious. Once you get used to them, you're like, this is really fun. Don't use it for everything. So, all right, let's get to a demo. This is mostly for the recording. Because I have a pretty loud voice, I don't need this thing. So I'm going to hopefully see if I can put this here. It will at least get recorded so I can show you a couple of these things. So I just want to run through top to bottom. We have 15 minutes. This will take about 10. I'll have time for a few questions. I can increase the font just a little bit more. So I'm going to create this table. This is puzzle 1. 5 cards, space, and a bid, right? So I just want you to see it in action. Now in this case, I'm creating the table. I'm cheating here. I'm not using copy because I just want to get it done quickly. I didn't want to have to go out to a terminal for you, whatever. I'm just doing a multi-line value insert. I get those 5 sample rows in. Great. And this is all it looks like. All right? Now, I told you about dollar quoting. This just means it's a literal, right? So I'm just selecting the text inside of it, whatever that string literal is. The other cool thing you might not know about is this just can be, they just have to match. So you can do something like that, and it will still work. So you can identify your beginning and ending, right? So that it's the 2 dollar signs, but you can actually put a word in the middle as some kind of tag. Kind of cool, right? I don't know why I'm taking this out, because it's taking time. And then again, I often use this in procedures and functions when I need to do a long format of some sort. Like if I'm generating a query inside of a function in some way, that gets hard. I want it to be, I write my query and then I want to replace the various things. This becomes really helpful. I put 2 dollar signs around my string, and then I can just keep it mentally, it works for me, and I'm just formatting the literal. All right, so this is what I was saying. You know, I get the output, whether I often start like this. I take a select statement, run it through something like split to table, so I get rows of data I can work with. Now, to use that, I either have to put it in a CTE or I start to do a bunch of subselects, and that's annoying and no one wants to do that. So I often just put it in a CTE so that I can start to look at this. Like everything below the CTE is where I'm starting to think about how I'm going to transform this data, right? This is just my sample data. It was a one-off. I don't have to create any schema. And now I'm like, okay, if this was a real table, I'd say select star from that table. It looks exactly the same. Sorry, I'm using dbeaver, if you know the tool, and I just have to hit Control-Enter, so I'm not hitting buttons. That will execute the query that I'm in. I forgot to say that. Now, I showed you earlier we could do something like this, right? I could do subselect to get the row number, and that works. I get the row number, but if I do, sorry, this is in the CTE. Who cares about that? But I can do the same thing with that ordinality. And I still get the same thing out. Lots of ways to deal with it. I'm using that sample data, and then I can start to iterate below. So in this case, we're just going to do the first part. Right? I now have this fake table of data called December7_DT. I'm calling it derived table, even though it kind of isn't. And I need to get the parts out. Right? I need the ID that I created. That's the hand. Right? So each hand of cards. And then I'm taking the first one. I'm calling it the cards. I'm taking the second one, calling it the bid. And now I have 3 columns. I took that string, used a couple functions, and I split it apart. Cool. Now, if I have the data internally, which I do, I can now say, oh, well, that just would have been the exact same thing, but I'm selecting from the table itself. Right? So you can see that I took the sample data, I got maybe the initial query, and now I could import the data, do the select, and it just works. Because I know my sample matches the other input. So now I have December 7th. I'm not going to keep using the temporary stuff. And in this case, we need to do a second part. So now I don't need to just know the hand of cards. Later in the puzzle, I actually need to know the order of the cards. So how do I turn a string into something tabular? I pivot it, right? I just break each of those things apart, and I pivot it so I can identify each individual card within the hand. So I'm going to have 2 IDs in some way. So the first one is the ID from my table that indicates the hand from all of these plays. And then I have the card that comes from my split to table down here. So I'm saying of the string, split it into 2 parts, take the first part. That's my 5 characters for the hand. I'm adding with ordinality because I'm splitting it to a table. So look at what happens. So first, you see I have hand 1, 2, 3, 4, 5 down below. Look at hand 1. When I take this and I split it a second time, and I add ordinality to it. Right? So I'm starting to chain these things together. And I can do that because I cross-joined that string to table. It can reference stuff from the actual table of data. Oops, not that. I had that highlighted. My apologies. So now I have the first hand. Notice I kept that ID column. And then I have the 5 individual cards in that hand, numbered 1 to 5. And this is just building on top of each other. Kind of cool, right? And then you can just keep iterating through this. Now, again, what I showed you earlier is I can clean up that top query a little bit. I can just move more functions if they're set returning into the from clause. Is this the most performant thing to do? No, probably not. But it might help you, come to the solution, understand the way these things are working together. And so I just simply moved this split part down below, and now I just reference it up top. And again, I am hitting Control-Enter. It's the exact same data set that comes out. Does that make sense? All right. Let me show you one really fun thing. This is the Wordle thing really quickly. The exact same principle. We have guesses, right? You can do up to 5 guesses in a Wordle puzzle. 1, 2, 3, 4, 5. And then I need to know each individual letter within the guess. So here's what the string looked like. So again, I'm taking an example, making a string literal out of it. And I'm using a different function here. It's called regex matches. That's going to get out the data as an array. So notice the guess is an array, and I kept with ordinality the number of guesses. In this case, they gave 3 guesses. Now I can take that output, I put it in a CTE, just to make it simpler. But now I can take that CTE, called Wordle score, I can cross-join it to another regex matches, so the output of the CTE goes into the next function, and there I say, hey, the first item of the array, which there is only one item in the array, and now I'm going to look for any existence of one of these emojis and split it apart and do with ordinality. So now I have each guess, each letter in the guess, the order they were. Okay, that's cool. So I'm turning this stuff into tabular data. And then to finish it all out, I can now take that tabular data in my select query, and I went from emojis to, with each guess, how many correct letters there were, how many partial guesses were correct, and how many incorrect. And I get down to, by the third guess, this person had guessed everything correctly. Do that across lots of queries, and I have this really cool tabular data. I can, with millions of Wordle stuff, is pretty fun. All right, so I just want to show this part, and then I'll stop here. All of this stuff is there. I try and do my best at putting a lot of comments so you know what's happening if you were to take this example. And I show you where to get the data, all of that stuff. I just want to quickly go over recursive queries again so that you can see it, and I'll have 1 or 2 minutes for some questions. And always feel free to reach out to me. So this is the most simple example, right? I set up the initial iteration by saying select 1. That's going to be the input to the next iteration. So value was 1 plus 1. That's going to get me 2. I'm going to keep doing that. Now the next input is going to say 2 plus 1 is 3. And I'm going to do that until value is less than 10. Because if I put 10 in, it's going to do one more iteration and get me 11. I don't want that. You do it all kinds of ways. And I keep highlighting stuff. My apologies. And we just counted 1 to 10. That's cool. I'm not going to, you can see it down here. Now you can do it with something like the Fibonacci sequence. This is another one I like to show, right? We all do that. We all learned it with Agile, right? And hey, what is Fibonacci to five rows? So I started with, this is my initial query. This is what it started as, right? The 0 was the start. The first value is eventually going to be the current number is 1. And you go by saying, hey, wherever the, we call this thing level, iterate it by 1. You add the two things together. And so after 5 iterations, you get 8, right? So the 5th iteration. What is it to 10? And again, this is where if I didn't have this where clause, what would happen? Well, you just get an out of memory error because eventually the number is going to get so big, it doesn't exist for a big int. So I can say, hey, what is it to 50? It's really big, right? That is the Fibonacci sequence at 50, the 50th position. And the file's on disk. It's the one I showed you in slides, right? So I have this table. It's already there. Great. And so that's what it looks like. You're going to say something? Sure I could, and I have done that actually. And so this is what the table looks like. Again, the initial query looked like this, right? I got that first row out, folder A. That's the input to the next one. We're joining name to parent folder right here. And if you remember, this is what the parent folder looked like, right? Folder A, folder A, folder A, and so forth. And there are 2 folder Bs in there. So the second output would be those 5 rows. And now I'm going to iterate all 5 rows, name, 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 name. A couple of them I'm going to hit when I get to folder B. So the final output is all the way down to folder B. Now because I can connect to it though, I can do things like join parts from the previous query. So pretty quickly I can get to something that looks more like a path. Because I'm taking output from the previous query and concatenating it with output or something from this iteration of the query. That's where recursive CTEs get really powerful and you can do a lot of fun things with it. In this case, I'm not going to go through it. Here's what it looked like in that puzzle. A lot of commands going, listing it, directory, file names, and you could iterate all those. I'll just show you one quick output of it because it is kind of cool. Let's do this. Yes, I know it's going to drop. Yes, I'm going to create that. And here I'm going to insert this stuff. Now, this is what it looks like, right? Bunch of rows. And then I can use something cool like regex matches. And so I'm taking it twice. I'm going to find anything that's a CD and anything that's a file. And I'm using regex to identify those positions. And I go space by space, and I can get those rows out. And then it continues on. If you pull this file down, you can do the whole example, get to the final result, and see what it works. We are almost at the end. I will show you the other reason that I forgot to put in the slides, and I will go back and do that. One of the other reasons I love iterating these processes with CTEs, even if it's not performant, is at any level of the CTE, I can put a select statement in. I can check my progress at that point. If something's failing, I can go back and say, what did I do wrong? When I then create the next step of walking the file tree, I can put a select statement there and see what the output is. And as I add the next CTE, if something doesn't work, I can go back and comment it, see what the output is, rethink it. It's one of the other reasons I love using it, because it really allows me to debug as I go. That's basically the end. I'll simply show you this. There's all kinds of other stuff. Go look at some of the advent of code. There are so many functions you can use. Once you start to split this data apart and transform it, you can go crazy and it's fun. Communities where you can help. All of these people and many more helped me learn a lot of this stuff over the last 4, 5, 6 years. Right? So get in the community if you're not there, and you're going to learn a ton. That's it. We are out of time, but I'm happy to stick around for a couple questions. I apologize. And there's the talk again. Yeah, I don't see Tatiana here yet. So, hey, let's take a question or two, if you have them. If you don't, that's fine too. All right. Going once, going twice. Have a great day. Thanks for coming. I'll leave this up for a second, in case you want to go scan it.
Okay. Okay, it's even better. Thank you. But do they have a pointer? They don't. I got my own. Oh, wow. Okay, nice. No problem. One? Oh. Okay, not a lot of us today. Hi, everyone. Nice to see all of you. And I think that it's already 5 p.m. and we are ready to start. So I know that it's the last talk of the day and you can be a bit tired already. So I'll try to entertain you as much as possible and not make you sleep. So, but if so, just let me know and I'll try to make it faster. So let's start, and our today talk is even children can work with Postgres. And you know, firstly, I need to say a bit about myself. My name is Tatiana, and I'm a CEO of dbeaver. dbeaver is UI tool for working with databases, and it was created and born as an open source tool in 2011. It was like a lot of years ago. Now we have like 8 million users, and you can find them in every country of the world. So what we do is database management and database administrative tools where people can work with any kind of database. So why I'm talking about that? Because the biggest, and I mean not the biggest, but very big part of our community is the people who work with dbeaver and with Postgres. And they write queries, they do different administrative stuff and so on. And what is even more interesting here, that these people are not necessary to be technical guys. We have more than like 35% of users who are not really know what is SQL language. They consider a database as the collection of the tables, and they live quite happily with that. And the question here is how can we help them? Because no one really wants to write the queries or scripts for someone else. We want to make these people independent. We want these people to create this by themselves. And it's where actually last year appeared the very great thing, because OpenAI appeared. And you know, I think that you heard about OpenAI a lot during the last year. Like everyone at all conferences had a talk, and maybe 10 talks, or maybe all talks only about AI and different language models, because it affects everything. And like people started to think that they can do with AI any stuff. They can write articles, they can create images, they can write reviews, they can do their job just with creating right prompt with AI. So today we will look at how good is AI actually for creating the queries. So, and firstly, the simple stuff that we can do is to try ChatGPT. Everyone knows what is ChatGPT, to create a query. So I did it for you, this experiment for you. I opened ChatGPT and write a request like, please write a SQL statement to show all invoices from Postgres. Literally, I didn't write please, but anyway. So as you can see, it helped me. And it created even 2 options. One of them is with select asterisk from invoices, and another one with a list of some columns. Good result. Most likely, these kind of select statements will work. But, you know, when we think about how to work with AI, in most cases, we don't want to create the request like that. We don't want to create the request in a way, write a SQL statement to show all invoices. We want something like this, like show invoices, and it shows you invoices. Nice, nice. So I did it. I write show invoices, and unfortunately it's too small because right now ChatGPT is very talkative. It gave you a lot of, it gives you a lot of comments, but you can see that actually the queries are the same. Even if we add the, if we switch to the like list of columns, we can see that for the second case, it added to us invoice date and total amount. Really nice. Our job is done. ChatGPT can create queries for you. Thank you, guys. My talk is ended. Okay, not now, not so fast. Because if we open the fresh conversation with ChatGPT and send something like this, like show all invoices, you can see the result. Again, a lot of words there, but the conclusion is, no, I cannot show. I don't understand what you are asking me about. Why so? What is the difference? Actually, the difference is in context. Because context for the AI is a key. So what did we do at the first time? We firstly said, write a SQL statement to show all invoices from Postgres. And now AI knows that we want to get SQL statements. Not something, not some invoices. We want to have a SQL statement, and we want to have it for Postgres, not for something else. And right now, if you open ChatGPT, they don't have this screen with the capabilities. But in the past, they had. And they had this notice that remember that ChatGPT remembers what user said. So that's how context was created. So it remembered our first request, and when we, after that, asked to show all invoices, it showed us the same select statement. So in this case, most likely, now we know how to work with that. We can do this by ourselves. The only thing is if we want to get the right select statement, if we want to have a complicated select statement with join different tables and so on, we need to provide the right context. So what is a context for the SQL query? A lot of stuff. I mean, it's not only the database type like Postgres or MySQL or SQL Server or something like that. It's also a lot of additional metadata like database name, schema, tables, constraints, names of columns, and so on. And then more complex our query, then more metadata we need. So, because no one wants to have some abstract query. Most of people wants to have the query that they can just apply and get the result. And for all of this, we need all of this metadata. So, are you ready to describe all of this stuff in the ChatGPT to get your query? I don't think so. Yes, it's just impossible. It's much easier to learn the SQL language and write query by yourself than trying to explain it for the ChatGPT. So, okay, now we are ready to end the talk. Unfortunately, ChatGPT cannot help us with our mission. Okay, again, it's not so simple. Let's move forward. What can help us? Here, I took the example with OpenAI, but actually it's applicable to almost all publicly available language models. So we have OpenAI as a model in the center, but every model has different kind of interfaces. For OpenAI, it's a Bing, ChatGPT, and OpenAI API. So Bing is a browser solution, ChatGPT is also like a special website where you can ask your questions, but OpenAI is a special thing that you can integrate to your applications if you want. And comparing with Bing and ChatGPT, OpenAI is only one that is paid. But with OpenAI, you can achieve exactly what you need. So you can help your users. In our case, in dbeaver, we use OpenAI API to close, like hide all of this stuff related to creation, the context. Sending all of this information. So users don't need to care about that at all. They care only about the query. And currently, in dbeaver, we have integration with 3 different AI engines. It's OpenAI, Azure OpenAI, that actually almost the same as an OpenAI, but in Azure Cloud. And we also have a fresh, brand new Google Gemini. So they work, if we are looking at them from the technical perspective. Of course, they're a bit different, but they work very similar, especially for users. And even the result that they provide, it's mostly I cannot say that it's the same. You can experiment with different ones, but the general process for all of them is very similar. So how they work? If you want to ask something from an AI engine, you firstly need to determine context, then write request, form prompt, and get response to show the results. Just 5 simple steps that will give you something in the end, or not. Why? Let's look at them a bit more closer. And we'll start from the context. The main thing that you have to remember about the context is that more information is better than less information. Then more information you will send to OpenAI, then better result you will get. Because not all the data will be used for the final query, but sometimes it's hard to predict what will be useful and what not. And actually, the context is determined by the number of tokens that you can send to the AI model. And what is tokens? Tokens is just a set of symbols. If we'll just calculate it, in average, 1,000 words give us 750 tokens. Of course, it depends on words. If it's just like article, you can put more than 1 or 2 to 1 token. If it's very long word with the 34 letters, then most likely it will be 2 or even 3 different tokens. And here is important, because as you can see, different models suggest us different options for the number of tokens. And classical OpenAI GPT models 3.5 and 4.0 give us 16 and 32 tokens, so 1,000 of tokens. Just to give you some understanding of the numbers, I could say that the middle size Postgres database, not the enterprise level, you can send the whole schema with all constraints in 20,000 of tokens. So what it means that when you work with, for example, with Azure GPT 35 Turbo, most likely we will be out of tokens. What does it mean? So it means that when you will send it, and if you'll try to send more tokens that it can apply, it will say, I'm out of token, and won't return to you anything. So you have to be careful with that. And actually, in the beginning, like a year ago, when people just started experiment with AI model, it was very often error that people received, that you are out of token, because models were small, they accepted a small number of tokens, but now look at the freshly announced Google Gemini, 1 million. I cannot even imagine the size of the database that can fit to this number. Sorry? Yes, exactly. So now when we know, determine our context, we can move forward. And we can move to the very nice part about writing the request. Actually, it's exactly what our users see. Because user doesn't know anything about the context. He or she just creates the beautiful query. And what is the great thing about AI is that you can create very humanably readable queries. I mean that you don't need to talk with AI like you talk with robots. I mean, we're not talking with robots every day, but anyway. So you're just trying to talk with AI in the same way as you talk with your friend and with colleagues, or, I don't know, with some teacher. You don't need to formulate it 100% correctly. You don't need to be grammatically correct. You can write it in any language. And actually, it's very, very useful, especially if you work like in international company, when some of your department is in, I don't know, in China and another part in Mexico. So they can create the queries on what's like Chinese and get the same result that you will get. And it's really cool. So moreover, you can help AI to create the query that will work. Because as we will see further, it's not always that so that AI works nice and gives us 100% correct answer. So you can help. You can say, use this table, or give me the data from this source, or use joins if you know what joins are. And actually, if you played with, for example, AI for picture drawing, you have some idea how to create the query. And it's very, very similar to how you create the query for SQL scripts. Because if you create the query for picture drawing, like draw the beaver sitting in Mercedes, and it's a sunset, and high resolution picture, and give me a best result from the France coast, or something like that. You will get a very strange picture in the end, because it will try to cut your sentence in parts, and each part will be drawn in some way. So don't do this. Do something like, please draw me the beaver sitting in Mercedes on sunset on France coast. Like you give the full picture, the full sentence that describe what you want to get in the end. And that's exactly that you write about the query. I mean that if you need to get the report, or like, I want to combine the data about my customers and their purchases for the last year, that's exactly what kind of request is expected by AI. Not something like, give me all customers, join them with the tables, with the accounts, and their purchases and something else. No, don't do this. Try to talk with AI in the same way as you talk with the people. That's it. So, and actually that's where the people work ends. And now it's more kind of automatic work, because here we form prompt. And I could say that AI currently has two types of API. One of them is for single prompt, and another one for the chat mode. In the Beaver, we have both of them, so I can show you the differences. In a single simple prompt, we form prompt through from 4 parts. It's firstly context, all database metadata that we send, and I could say that to mitigate the risk with this too many tokens that I described, dbeaver just cut the metadata. So if we like too close to the limit of tokens, we just remove all other parts. Always suggest choosing the part of the database that will be used for the creation of the query. So after that, we send a human readable request and give AI a task. In our case, it will be create SQL statement, quite obvious. What else can we ask? Yes, create SQL statement. And because for single query API work like it's complete the sentence, we need to give a beginning of the sentence. In our case, it will be start from the word select. So now our AI model has a understandable prompt to work with. But if we work with the chat mode, it's a bit different. Because in the chat mode, first of all, we send the same context that we do for the single query. But the next stage is a bit different. At the first time, we also send a human readable request. But on the next stages, we send the whole conversation. Because unfortunately, we cannot trust AI memory. Sometimes it's remember. Sometimes it doesn't. You never know. So, and that's because why even for single queries, we always send the context again, even if we are trying to request the same database again and again. Because after like third or fourth attempt, AI can forget some parts for no reason. So it's better to send everything. And in case of chat, we send everything, like the previous request and the previous response that we got from the AI. And we actually even mark, like, hey, it was the previous request, and this part was your response last time, and now it's a new request, and so on. That helped AI to understand what we want from them. Then we again gave the task, like create SQL statement, and comparing with the single query, we don't need to give the first word. We can just say, like, add comment, because we are trying to talk with AI, and we are waiting for some comments from that side if we formulated something not well. So, and after we did all of that, we get response. Sometimes it's good, sometimes it's not. And why we can get the negative response? Actually, there are a list of different reasons. And I really like this. I was wondering how I can get rid of this error. Actually, this is a screenshot from dbeaver GitHub ticket when we just firstly implemented that. So yes, sometimes people just don't understand what happened and why it didn't work. And you know, there is a list of different reasons on the slide. Like, and the first one is like, you do not have internet access. And if you think that it's a stupid reason, actually it was a reason of this error on the slide. And it's not because the person was stupid. It was because he was in a closed corporate environment. And the access to the OpenAI API was just closed. It was impossible to connect, and it was impossible to get the result. So it could be obvious, but it wouldn't. So the next thing these days is not so popular because AI engines became stronger, but it still be that if you're trying to get some results from AI in the middle of working day on Wednesday, you will need to wait. So, and the next couple of things is about your responsibility. You have to be sure that token that you use is correct and that you paid for access to AI model. We have some free models for now, at least. For example, Google Gemini right now is free. You can use it as much as you want. I don't know how long it will stay in this, but right now it's free. But OpenAI API is not free. It has some trial, like big enough to play with the technology, but not big to use it like regularly every day. And yes, you can choose the wrong model what does it mean? It's that, for example, OpenAI suggests you very different models, and not all of them can return you the SQL query. And in this case, the model just returns you, I don't know, I cannot do anything. And again, you send too many tokens. We actually defeated this problem in dbeaver just cutting the context. But if you use, like you create your own application that will work with AI API, remember that it makes sense. So let's move on. Even if everything is good and you received the right query, it doesn't guarantee anything. Because sometimes, even if you send the correct data, OpenAI using some, I don't know, knowledge, internal knowledge, it tries to create something beautiful. And like in this case, you can see that in the script that AI created, we have like red highlighted word description because this column doesn't exist. Why OpenAI decided that it has to be there? No one knows. Because, you know, we sent the whole metadata, information about all columns, everything. But for some reason, if you have the table with the films, you have to have description for this film. No any choices. So, yes. And here is maybe the most philosophical thing in this talk. Please be concentrated. So, yes. It's a very, very well-known citation from the ancient time, but you know, I don't have author here because I don't know who was that. If we believe the internet, every big person in history talks something like that. And it's 100% correct when you work with AI. You need to ask the right question. You need to formulate it in the best way as possible to get the good results. And then, ta-da! Yes, you will get the result. It will show you the data, and you actually don't need to do anything. You just created this the query like me, like show me all films released, like rented on March 25, and it returned me the results. So it looks like everything is good, but before we'll go further, a couple of important things. First of all, about the unobvious limitations. And one of them is related to the number of tokens. That huge schemas with hundreds and thousands of tables, actually enterprises love this kind of databases. And also the companies who prefer to not like create the database schema by themselves, but use some third-party tools for that. They also have the same issue when the names of tables generated automatically, and they can contain like sentences, hundreds of letters. And when both of these numbers are too big, you will be out of tokens very quickly. The second point is about analytical databases, because you know, if we'll take some classical analytical database, because of the structure of the data, it can be the table with hundreds or thousands of columns. And it will be the same story, like you will be out of tokens very quickly, just because your database or your table is too big. And of course, you know, AI works really well with Postgres, for example, because Postgres exists forever. almost forever, from 95, I think. But anyway, there are a lot of documentations about that, and there are a lot of understanding, like knowledge about how to create the queries, so AI knows it very well. But if you work with brand new database, maybe it's even fork of the Postgres, most likely AI knows nothing about this database, and it can be hard, especially if they have a special language. Good example of that, Mongo, not a brand new database, but very specific, has a very specific language, script language for querying. A year ago, I had this point in the presentation, so NoSQL databases, not for AI. Now they are much better with NoSQL databases as well, because someone trained them on that. But, you know, Mongo is quite popular. If you use something very rare, I have some doubts that they will support it so quickly. So, a couple of words about the differences between single request vs chat. First of all, first thing that you have to remember about single request, that every request is brand new. Like, you cannot trust memory of AI, so AI consider it like a fresh request. So it means that if you formulated it not in a good way, you cannot just add some details. You will need to rewrite it completely, or just trying to create the query by yourself in a better way. But at the same time, the query structure is fixed, because you remember, it works like completing the beginning. Like we started from start query from the word select. It means that if someone will try to generate, for example, delete statement, it will be impossible, because delete statement cannot start from the word select. So it won't work. It's less flexible, but more safe if you want to give it to some unexperienced users, for example. At the same time, chat mode is more flexible. You can really talk with AI. You can say that, hey, you can try this, please add that, and so on. And it will just collect all this data and trying to apply it, summarize everything to the final statement. And the benefit of the chat mode is also that you can create any kind of queries. Insert statements, delete statements, anything that you need. It's not so safe, so be sure that you gave users the right permissions on the database level to avoid any kind of issues. And I can try to show you really quickly how it works. I mean, the differences between single request and chat. If it won't work, I'm sorry in advance, but at least I'll try. So we have Postgres. We have some database, and we will create this new editor and try to create the first statement. So, oops, no connection. Okay, let's try to reconnect. Now I believe we have a connection. So, yes. So let's look at the settings of AI first. You can see that we have some API talking, and I use GPT 3.5 16K for that. And I have a checkbox to execute SCaLE immediately, just to not spend too much time on that. So, and here I will ask to show all films rented on May 25, as I had in my presentation. So we'll wait for that. And yes, you know, we have some comment. It's my request, show all files rented on May. Then we have some comment from AI, like, we need to retrieve all films that were rented on May 25. To do this, blah, blah, blah. It tries to explain you everything that he did and how he created this query. And as you can see, we have this issue with the description that doesn't exist. So, because of that, we said, okay, don't show description. Stupid way to avoid this error. Nice. Wait for that. And so, ta-da! We have a result. It worked. But, you know what? We don't have actual rental date. We cannot check. Is it May 25 or not? Why? I don't know. Let's try to fix it. Okay, we'll go here and say, like, I don't know, include rental date. So, ta-da! I'm not sure that it's what we expected, because now we have like just 2 columns, not like all of them that we wanted to have. So we can try to play further with that and try to formulate the right description to get the right result. Okay, let's try to do this in a chat. So we said like, show all films released on May 25, 2005. So it didn't work because the date is incorrect. Yes. So how can we fix it? We're trying to add some additional clues for him. We can say that release. So what I say, I could add something like, release year 2005. No, doesn't work. Okay, so let's try to reformulate the whole sentence. Like, show all films set okay. Okay, show, let's start from something like that. Show all films. Not a lot. Not a lot. Yeah. Yes. we can calculate how many rows we have here. Just 1,000, not a lot. So, yes. Yes, yes, he did. Everything is correct. And now we say that okay, only include. Only include the films released on May 25. No, it doesn't work. So, and actually it's different, because when we're trying to add some points, we need to understand what kind of points we want to add to get the right result. Sometimes it works nice, sometimes it works like this. So I don't try to defend some AI model, but I can say that sometimes you can get it very easily. Sometimes a chart mode is more convenient, sometimes it's less. It depends. Let's return to our talk. And a couple more words that I wanted to add here. So, where else can AI help? Actually, not a lot of areas, but they exist. It can get you a general overview of the existing database schema, especially in a database, in a chat mode. You can say something like, could you explain me this schema? And it will try to tell you like what tables you can find there, how they connect with each other. And so on. Sometimes, especially if you are not very experienced user or you need the additional information, you can use that. And the same stuff about the particular object. So it could say with which other tables your table is connected, or maybe from where you received this view, and so on. So, for some people it can be useful. Yes. And the next point is about optimizing the queries. It's I could say here that it's a dream to send your query that runs with error to some magic tool, magic box, and the magic box returns you something beautiful. AI won't help you much, but sometimes it can give you like a good advice about what happens. And the last point is generate mock data through the insert statements. Actually, it's not like, please generate me some data with insert statements. No, you said like, could you add this to my table? And it will generate you, or even, could you add 20 rows to my table? Yes. Yes. But again, it depends on the database and depends on complexity of your database. So sometimes works, sometimes not. But the worst thing here that you saw the speed of the AI response. So if you need to generate like hundreds of rows, you will firstly need to wait for the generating the script for that and then run it, and it will be like inserted one by one because it will be single inserts for each row. So for some cases, for test data, it can work. For some, not. But yes, you can try to do that. So maybe the last important point here is about security. We need to talk about that. And in the Beaver, especially for that, we showed this message like, in order to perform completion, the Beaver will send your metadata to API. Is it safe? Actually, it's a question, because, if you work with, if you are learning SQL and you have a Pagila database, every model knew Pagila database better than else. And there is nothing dangerous in sending this kind of metadata. Moreover, if we look at the OpenAI privacy policy, they said that they never ever send our data anywhere, and they don't use it for like learning for their models. But for OpenAI, Azure OpenAI, the privacy policy is even stronger. And actually, they even provide you the private instance cloud where you can find your model, and no one actually has access to this space. And that's why a lot of enterprises prefer to have Azure OpenAI instead of just general OpenAI, because they trust Microsoft more than OpenAI. At the same time, Google Gemini honestly tells us that please do not submit sensitive, confidential, or personal information, because your data can be used for learning technologies in Google's enterprise features, products, and services. Maybe it's like your payment for this free model. 1 million of tokens, you remember? No any other models will give you this opportunity. But yes, please do not show the sensitive, confidential, or personal data. But at the same time, if we look at this problem from the other side, we don't send any kind of data. I mean, the data itself are private. The only thing that we send is the structure of the database. So it's your choice. You can choose, do you trust them or you not, and how valuable is your database schema if you want to share that with someone or you don't. So what else do we have? I listed here a few other models. Currently, we don't support them in dbeaver. It's a GitHub Copilot and AWS Code Whisperer. And for these two, the reason why we don't support them, because they don't have public API. And they are integrated in VS Code, and I believe in JetBrains IDEA. But if you want to make your own product or use it somehow independently, it's impossible. I asked GitHub team on AWS conference about that, why they don't have a public API. And they answered something like, oh, we don't trust it for now, so we want to spend some time. But, again, it's up to you. You can trust this answer, or you can believe or not. But my goal here is to say that, unfortunately, they don't have, at least for now, they don't have public API. The interesting thing about Llama 2. Llama 2 is an open source model from Meta. And it means that actually you cannot just work with that. I mean, you cannot work it in the same way as you work with Google Gemini. You can take it, you can train it, and after that you can use it. And currently there are, I don't know how many new startups that use Llama 2 as a basement for their models and for their tools. So actually the first maybe and the most popular for now language model is a Llama 2. And Claude 3, actually I believe no one knows who are they. And I put it here because just a couple days ago I read in some article that comparing with OpenAI models, they give much better result for SQL queries. Because, currently, unfortunately, there are no good model for SQL. They write more or less okay, like other programming languages, like Java, or maybe, I don't know, C# or others, but no SQL. Yes. So, and, but they said that Claude 3 does this work for us for SQL. So who knows? And the last question is, how good is AI? Can AI replace all of us in the near future? Can AI create for us all like queries, and we will need to just leave and keep it for the robots? I took the article, actually it's a joint article of American and Chinese scientists. They also tried to create some model, but the most important thing here is the last row, because they compare models with the human performance. And as you can see, the difference for now is huge. And it's a lot of work ahead for the language models developers to be closer to the human performance. So you can consider these models as your assistant, as someone who will help your maybe less experienced colleague, because these models are very good for users who are not familiar with SQL but still need to work. Because yes, they can write their queries. After a few attempts, after some learning, you can create very complicated queries with a lot of joins. Like you can combine 3, 5, 7 tables. You can add complicated conditions. You can even write self-joins with AI. So you can do a lot of things. And all of this without SQL knowledge. So yes, and it's very good for well-known databases like Postgres. And it's a good point to start if you are learning the SQL language. And it's not necessary that you are just a student. Maybe you switched your database. Maybe you always was like, I don't know, Oracle developer, and now you work with Mongo. Do you know how to write queries to Mongo? Maybe, maybe not, and that's where AI can help you. And here, the end, and I'm ready for your questions if you have them. Thank you very much. No questions. Thank you, guys. You were very good listeners. Really appreciate it. You give the description together with the table. Hope so? No, we don't. At least for now. Too many things, and I try to be at 3 places